Yeah. Sir, can we start?
Yeah, please.
Okay. So a very good morning to everyone. We are at the third and last day of this conference time 2021. And we'll start with a talk by Sangeeta ma'am. She is the head of the mathematics department at Sanskriti School, New Delhi, and she will be talking about teaching and learning maths with Google Apps. Yeah, over to you, ma'am. Ma'am, you're muted.
Yes. Good morning, everyone, and thank you so much, Professor Rana, for doing this, every alternate year. And I'm very fortunate to have been associated with this program, this special event for many years. So it's a wonderful platform for all of us to get connected, to learn and share together. And this is a third day. And I hope everybody has had a good learning experience. And the best thing of virtual sessions is that everything is recorded and you will be able to access it if you were not able to join in live. And I'm looking forward to doing that because we all have been busy with our various activities and schoolwork and other commitments. So today's session, I'm very glad to be here to talk about teaching and learning maths with Google Apps, with an understanding that, yes, my role is of a maths teacher. I head a maths department at Sanskriti School, been a maths teacher for 30 plus years now. But I'm also passionate about using technology in whatever form I can learn and I can practice. And Google Apps had been part of my this transformation for several years now. And I'm fortunate to have become a Google certified innovator and recognized as Google certified trainer. And now currently with the online scenario where the teachers needed a lot of support, we came up with and joined hands with Google Educators group of world and came up together to put a group of teachers who are helping and supporting each other. So I'm also leading the GEG of Delhi NCR, and you're all welcome to join in. Maybe somewhere later, I will put in few links for you to join our group. Follow us on YouTube so that we can learn together. So it is not only for maths teachers. So GEGs are for all. And I hope you will share this information with your colleagues and have them join us so that we can learn and grow together with Google, as we say. So that is the focus today. So I'm glad that I got this opportunity to talk about not only the math specific tools, but also look at how Google Apps, which are coming under Google Workspace for Education. So Google Workspace for Education, when we think about it, is a part of what you are using as a regular Gmail or general Google understanding that you might have, but it is specific for education. So Google Workspace for Education is known to have an understanding that it is something which will bring possibilities and opportunities for students, teachers, educators, all learners to be creators, to, of course, stay connected with each other. And the most powerful feature of Google Apps is collaboration. So all of that comes under Google Workspace for Education philosophy. And the apps that comes under it, Google Workspace for Education brings a core suite of apps. And those core suite of apps has, again, the various categorization, very broad categorization, but still there is an overlapping among them. So you must be familiar with Google Docs, Google Sheets, Google Slides. So all these icons that you are looking at here, they are something that you are familiar with, right? So if you are either a regular consumer of the, one would say, the general Gmail user, you would still be familiar with Google Docs, Google Sheets, Google Slides, and of course, everything that houses inside the Google Drive. Jamboard has been a regular now, a part of for any teacher, if I may say, a part of our teaching and learning process day to day, because it kind of provided us that whiteboard that we were missing when we went online. So these are all great apps for collaboration. So they help you collaborate anywhere and anytime. And how we would possibly think of using it in maths is something we will try to cover today. And of course, Google Keep Calendar manages all our tasks, and everything as far as Google Workspace for education goes is very heavily dependent on having a platform which is known as the Google Classroom. So it is a learning management system where anything that a teacher wants to communicate or share or assign can be done through Google Classroom, to the extent that the integration of various math specific tools also with Google Classroom has made a big difference. So you've been looking at workshops and heard people presenting on GeoGebra. So GeoGebra also is integrated with Google Classroom. We can assign a GeoGebra applet right from GeoGebra into the Google Classroom, to the extent that each child will work on their own individual applet and can turn it back in, can submit that work, and teacher can view it. So that is the power of having two very important tools kind of connecting together and integrating. And so is even Desmos. So you can pull in the roster of your Google Classrooms into Desmos, and you can assign activities and follow the work of the students. Google Forms also assessment tool, but initially, of course, a survey app turned into an assessment tool, has played a great role, whether it is an English teacher or if it is a maths teacher who wants to give daily homework. So Google Forms plays a big role there. Gmail, Meet, and Chat are, of course, for communication. And of course, if your school has adopted Google, that would mean that there is an admin control to anything that you and your students do, then that can all be managed with the admin app. So these are the core apps that comes under Google Workspace for Education. So how do they or how are we possibly able to use them as a math specific tool? They're not math specific, but how would we be able to use them as math teachers is what I would try to show in today's session. But pausing for a minute there and thinking about what's the purpose of bringing in any kind of a tool into the classroom. Keeping up with this quote, which is by Paul Holmers, who says the only way to learn maths is to do mathematics. So when we have been looking at, and I myself have talked about Mathigon for the past 2 days, the whole purpose was that when you're looking at a tool, there is something which you are allowing the students to work with, something which they are using as an exploration, something where they are either creating or discovering as they work with those manipulatives. So manipulatives definitely play a role. Desmos and GeoGebra gives you those multiple representations. So all of that is what any other tool, if it can do, you may think about its place in your classroom. At the same time, anything that I'm going to show today, or what we may do with Desmos, GeoGebra, Mathigon, they all cannot be, be the only way to do maths. Maths has to be done with a paper and pen, and that can never be replaced at any cost. So with that thought in mind, let's take a look at few of the possibilities that can arise by looking at these Google apps that we just had a quick glance through, and see how they might fit in our maths classroom. Starting with the very popular app, that is Google Slides. So Google Slides is the app which is mainly a presentation tool. So right now my presentation is on Google Slides. At the same time, it is as we look at the past few years of use of more and more of these apps only for education, these Google Slides have actually been used for multiple reasons, multiple ways, not only restricted as a presentation app. They can be used to create simple drag and drop activities. No matter what level you might be teaching, you might be wanting to have some situation where children are labeling something. So even those can be easily done and created through the Google Slides. So here are a few examples how you might want to think of using them in any other classroom. So again, manipulatives. You now, with these simple Google Slides, can create these manipulatives. All it needs is an image and some kind of a background for the children to work on. So this is a very small example of how one might give an opportunity to the students to think about numbers. So this could be used in grade 1 or 2, and the child is being asked to think about numbers representation in tens and ones. Once you use Google Slides, there is an opportunity for you to insert videos in it. So make it self-learning for the student, or as a review, you can add the video which talks about the concept, and then follow up with more slides where you are inserting these images which are giving children a structure to work on, and they are able to explore the concept of units, places, and thinking about putting them in the language of the blocks, which they would otherwise do. But here you're not now restricted by, well, in my class, I might have 40 students, but I have only 5 kids. So who will get a chance to work on it or not? It has always been a debate. This one will solve that problem for you. And again, when we look at, what is known as linking slides with another, so hyperlinking within the slides, whether you are using any other kind of a presentation tool, it is always up to you as to how imaginative you can get. So unit circles and thinking about the practice of the trigonometric functions values at different angles has always been a challenge for maths teachers. But what happens if I give a chance to the students to create something which would kind of give them a way to review? And this one is simply done by hyperlinking each slide text box with the other, which gives you the value of the trigonometric functions at different angles. Angles could be in degrees, angles could be in radians. And as a tool, if I have created it and I shared it with the student, it becomes also a way of review. So a quick revision can be done by the students if they have this one little applet ready for them. So this could be one final slide that has been published and a link has been given to them, or it could be this work of students themselves that can be put together and can be shared with them. So that is, again, what you're seeing right now is nothing but set of slides all hyperlinked with each other through the text box. That's all that it needs. Again, open middle problems. If you Google for them, they've been very, very popular with the understanding that they give students a very low floor to, high task kind of a situation where the student is invited to explore without any risk of failure. And these problems can be easily done on paper, surely. But what if I, especially in the virtual environment, want to check and see what they are thinking about, or give them a chance to try and retry till they get their solutions and get varied solutions? All it needs, again, as you are seeing here, is like a drag and drop possibility. So there are, this one I have taken again from a source that was available. Again, this is definitely a credit to educators who have transformed all these ideas into digital solutions. And each one of them is linked with a slide which can, again, prove very, very useful for you. You can create them yourself as well, simply by adding in different images or text boxes which can be dragged and dropped into the possible place. So you can, if you wish to get the link of this particular activity, you may even scan this QR code, which I have kept ready just in case you would like to test these out and see what this open middle math, the problems look like. but they are the ones which give students a chance to explore, to think about, and every problem, most of the problems in fact have more than multiple solutions. So if you have a class of 10, you might even come up with at least good 6 or 8 solutions from that group, and it gives a lot of scope of discussion, and discussion in the sense of building up their mathematical concepts. So this is something which can be definitely explored and must be looked at. Google Drawings is an app which is not counted under the core apps of Google Workspace for Education, but it is one of the apps which actually is very, very powerful. It's most versatile because it gives you a blank page. And on that blank page, you can add in all kind of text, shapes, content, even hyperlink. And that has helped us create those basic manipulatives or those particular hands-on activities, which on paper had been done for years. But when you turn them into digital mode, it gives students a better chance of exploration, and for you as a teacher to look at their work and have a kind of a possible opportunity to take that discussion forward. So here are a few examples of what you can do with Google Drawing. And again, all that I'm showing, even if you do not have Google Workspace for Education in account, you can use your general Gmail account, and in your Drive, you will be able to find all these apps very, very easily, and you can start creating for yourself. So again, with the younger ones, we often want them to try. So these are a few ideas that I'm sharing by a NetTech expert, Eric Kurtz, who comes up with these absolutely amazing ideas. And all it requires is a page and then insert some images there. And then the question is simply how many lines of symmetry can you insert in each of those objects below. This is what a Google drawing looks like. And the background usually is transparent. You can change the color, and you have all kind of tools here. So you have a line tool, arrow tool, elbow connectors, etc. So if the child just picks up the line tools and try to then draw that line of symmetry and then respond or answer the questions, maybe you can have this assigned through the Google Classroom, because that is how one would use them in a more appropriate manner under the with the understanding that there is going to be a process of assigning and feedback and submissions included in it. So as the child work in a live mode or as an asynchronous, the student will be able to work on it, submit it through the Google Classroom. So an activity as simple as this can be assigned, and all that the student need is pick up these simple tools from here and draw those lines of symmetry and think about how many lines of symmetry can they insert for each one of them. So that is, I kept this ready as a live just to show you what Google Drawing would perhaps look like. It's nothing complicated. It's a very, very clean canvas, which can be customized as you may want to use it. Again, yes, some of my examples are coming as a very, for the, I would say little ones, but they do need this. They do need these manipulatives to understand. So again, I know that there are ways of using maybe just counters in your classroom. As a math lab kit, perhaps you might have them. And this is what you would do. You will try to get red and a yellow together, or a red and a green together, as we saw in Mathigon as well, and take positives and negatives and make a 0 out of them. Now, again, using just the Google Drawings, there is a blank space on the sides, which you can always use to put objects. And again, create these kind of manipulatives, virtual manipulatives without, so again, it would be low tech, but it is something that each one of you as a teacher can customize for your own students. You can give them or call out various numbers and say, okay, we are going to now find the sum of maybe -8 and -3, or -8 and 10. And they can easily pull these yellow and red counters from the sides and test it out and respond to to the answer. So just one applet can work wonderfully well and can help you take the discussion and explorations in your classroom and establish again before you give them a result. They're exploring and experimenting before they reach a decision about what they are learning. So these are definitely all possibilities created just with simple Google drawings. Again, geometry, when we think about some of angles of a triangle, the interior angles adding up to 180-degree, there are so many ways. You can use GeoGebra, you can use just simple paper cutting and pasting and demonstrate and verify the result. But what if you want to give them a digital experience, considering that you want every child to be able to do this in their own way and not restrict to just one triangle, but maybe try different types of triangles? All they have to do is in a Google drawing, you might give them a start, give them a template, or ask them to draw from the scratch. They just draw one triangle using just the triangle tools right from here, the shapes, and then leave them to explore. Is there a way where you are able to line all the three angles together and get a 180-degree angle formed? And this is just as simple as that. And with that itself, you're able to, maybe if you have a facility of projecting, if Google Classroom is used and all the files have been submitted, each student might have taken a different shape of a triangle, and you can show them that the result is going to be true, no matter what kind of a triangle it is. So all these verifications that we do in our MATLAB activities can easily be demonstrated and recreated with Google apps. And the Google drawing definitely is a way to go forward with. Moving ahead, the next app is Google Docs. So Google Docs, when we think about, it's simply an app for as a word processor. So you are creating reports. Mainly we think about adding text to it. Of course, there are some features where you can have a voice typing coming in, collaboration coming in. You can share a document and multiple people can work on it. You're also looking at a possibility of inserting images. So you can insert images in a Google Doc. You can do research within a Google Doc. And all of these can be easily used if you want children to learn, and to learn where you want them to follow their own path of learning. So the whole purpose of bringing these opportunities for students to use technology is to give them a chance to explore, learn on their own, and not to be fed with every detail and then to be just learned by heart. So looking ahead also, especially now that we have from, if you look back at say 2018 or 19 to now, we have come a long way. So we have realized that students can be trusted to be given a chance to learn and study on their own. Looking ahead also, the future is of a blended learning, where we are thinking about giving students a chance to learn on their own, come back, discuss, and then again take the learning forward in their own time, at their own pace, maybe at their own place, and follow their own path. And in doing that, Hyperdocs is going to make a difference. So Hyperdocs is based on the 5 E's model, where you are giving children to explore and of course engage and explain. So you're looking at all those possibilities coming with the help of using either Google Docs or slides. It's not only Google Docs where you will find Hyperdocs, so you can have Hyper slides as well, which are also commonly known as Hyperdocs. But what you're looking at here is one full class 9 lesson on coordinate geometry. This was experimented many, I think 3 years back by me in the class 9 classroom itself, when we were not even thinking of going into the virtual environment and thinking about online, etc. But this lesson was created so that the students can learn at their own pace, because this is a topic which doesn't require the teacher to be really sitting down with them and dictating everything, but something which they can explore. At the same time, we wanted to give them a chance to try out what this Cartesian system is. So starting with, of course, the historical aspect of it, and then giving them a chance to maybe plot points so that the teacher can also see what they are doing, and student can also practice what they are learning. So a template, something like this, can be given to them, where you are basically dragging and dropping the point at the corresponding point to show whether they have understood what is the first coordinate, and will the point lie when the point is not in the first coordinate. So what is inserted here was nothing but a Google drawing. So you can add Google drawing into the Google Doc. So this is, if you double click it, it opens into a Google drawing. This is kind of like a fill in the blanks. You have an image inserted here, and the students have to name the ordered pair. So what would be the 4,0? The student is expected to go along and identify that, come back to this text box and add in the corresponding letter. And then, of course, once they have done with all, they can save, or partially as well, they can save and close. And as the student is working, if it has been assigned through the Google Classroom, teacher can follow their progress. So this could be a lesson which is assigned for over a period of time. So it could be 2 to 3 days, perhaps the time is given, and teacher is able to follow, seeing which student has started working, what kind of progress they have made, and give an instant feedback as well. So you can, add a comment here. Of course, you can add an oral voice comment as well if you have another super extension known as Moat attached with your Google Workspace for Education. So you can do that and give a oral feedback comment to the student as well, so that the students can learn from it, or if they have submitted the work, they get a feedback about whether they have done it right or not, or any other direction that you want to give them. So this is one way of, using simple Google Docs and taking the learning forward. Again, here are something which I didn't highlight. Here is some online games as well, which are linked for children to engage with, so that they can practice the concept in a different way, getting an opportunity to try this out in a different way. So again, these games, because we know children play online games, but what if the teacher has already tested it out, seen the effect of it and significance of it, and then assign it, and let the kids take their own time, whether they want to spend 10 minutes on it or only 2 minutes on it. Let them decide whether it will work for them or not. And it would just reinforce the concept. So that is, with that thought, if you can find something suitable and insert it there, it definitely goes a long way. Same is a lesson on polygons. So again, this is a lesson which is created using just simply Google Docs, where the student is being asked, in a sense of being given a direction about to explore and learn more about polygons. So it starts with the definition, and then the student is asked to identify the polygon. Again, this is nothing but a Google drawing. So that's why I mentioned or talked about Google drawing before Docs, because Google Drawings has made a big difference. You can insert a Google drawing and then do what you would like. Would you want to give them a chance to decide whether it's a polygon or not? And so they might even pick up this shape and put it in a polygon. So again, this might give a teacher a chance to discuss and say, well, go back and read the definition of polygon. What exactly does it say? Does it mean a heart shape or any closed curve is going to be a polygon? And from there, they start thinking about it. They get a space to express their thinking and writing. They also get a chance to do more activities there. And you can even add in a video. So here is where I had added a video. So here, polygon names. Polygon got their names from number of size they have. Watch this video to do a quick review. And the best thing about, these new changes that are coming in Google Apps time and again is that now you can have a very neat button for the YouTube videos added in. The student can actually watch it in the document itself. It will not open in another page. So there is less distraction. And the child is following a structure decided by the teacher, but they do have a choice of jumping and moving on or going back to the video again to decide what would be the way to follow a concept or define a concept. So it is completely left to them how they want to learn and follow that particular lesson. Same thing can be designed as a choice board. Once you have done the chapter, you want to give them a review. So for review, you can give them number of opportunities, not just one, and tell them that you have to do minimum of 3 out of this. All of them giving students a chance to be responsible for their own learning, yet giving them a chance to take that decision as to what is making them comfortable. So all put under a structure coming through either as a slide or as a doc as your main place where things are structured and placed for them with the minimum of the directions, but some directions definitely students would need. As I said at the beginning, Google Jamboard, when we look back at maybe 2 years back, Google Jamboard was very, very basic and not much was known about its use. But when we went online, everybody started looking for, especially the teachers, that is, started looking for a board, a blank space where we can write, also where we can give students a chance to collaborate and mainly annotate. And that is where Google Jamboard came up with more and more features, giving us a chance to turn that into a big learning space. So what it looks like is just an empty space, which I'll just try to demonstrate. I also want to give credit to this particular idea that I'm sharing to the Kentucky Center for Mathematics, where they had developed a lot of lessons for teachers just using Google Slides and Google Jamboard. So this is one small example, which I really like the way they had shown this, where they are talking about how they can teach. So using it as a teaching tool, where how they can use Jamboard as a teaching tool to demonstrate, to teach how the students are going to understand the concept of division. So this is, let's see if we can open up this Jamboard and take a look at what it looks like. So definitely do, if you are keen to learn more about the kind of work they have done, then do visit their website and take a look at it. But what it comes up with is, again, a bit of a structure. There is a table added in there where the student will make a record. Now, again, if it is something where you don't have technology in your classroom, you can give students just a plain worksheet and do the demonstration as a teacher. So how many plates, how many cookies on each plate? So this is the record which the student will make as we proceed. So here is, if I remove this card, then underneath, let me see if I can zoom in. So here it says get 6 plates, put 2 cookies on each plate. And so how many cookies do we have? So what the student is expected to do, take a look at this. This is a neat way of getting those 6 plates onto the screen, right? So you can have that in a Jamboard. I can delete this for the time being, and I can get those 6 plates coming in right from here. So all you have to do is find an appropriate image and make copies of that, just layer them up. You would know that there are so many of the plates there. And now the student is expected. So again, the table said how many plates. So the first column will have these entries, and then they will put 2 cookies on each plate. And then the students are going to do the counting. So something which is as simple as, just a drag and drop, but a visual coming in. This can become a very powerful tool for any teacher who's trying to make the little ones convinced of how multiplication, how repeated addition, how division, all these concepts are taking shape. They can do this with the help of a simple screen. So this is our Jamboard. These are the pen tools that one can easily pick up, and you can, just to highlight or illustrate, you can keep writing on it that we had 6 plates and we're putting 2 cookies on each. Let's keep counting how many are there. And you go back and fill up these tables as well, and thinking about all the other questions that are coming in. So very simple idea, but I hope if you are dealing with young ones, small ones, or if you are training teachers who are teaching young ones, then these are few ideas that you might want to try and see if they would make a difference in your classroom. So let me take a look. Right. Need to close that. Okay. So let's take a look at what else we can do with Jamboard. Which one does not belong? I wonder if you agree with me. There are times when you want to just bring in something which would make the students interact with you. There are, especially now that we are online, we are looking for those moments when the students will just speak. And I know Professor Rana in his opening keynote itself talked about the interactivity in our online classrooms, or in fact I would say lack of interactivity, because students do not talk. And so we need to bring these little moments in between where we would just talk to them or give them an opportunity to talk, and if possible talk maths. So which one does not belong is a great way to bring in these brain breaks in between any virtual class, or an icebreaker if you want to start a class with the students that you are not familiar with. And there is definitely a great website for that as well, wodb.ca. Which one doesn't belong? So which one doesn't belong is basically set up all these images where there is something common, something similar, yet they don't connect with each other. So if you start with maybe a simple Jamboard and you put these little circles on the sides and tell them, okay, I'm sharing this jam, and now you take a call as to which one does not belong. It could be numbers, it could be shapes, it could be graphs, it could be equations, or some other mathematical concepts that you're bringing in, and give them a minute to put their dots in. Now, this can be done in multiple ways. You can have Google Slides, and Google Slides has a wonderful add-on with the peer deck. So you can have that so that the students can place their dots. But if you don't want to get too fancy with it, you can simply create a Jamboard, insert that image in the background, and get these little circular dots placed on the side. Each one child, because it's anonymous, the student's name is not coming along with it, you will find that they will all respond. And they will respond in a different yet similar fashion. So as you can see, many of them are going towards C, whereas one student has come to the D part. So this is where your conversation would start. And you would try to ask the person who had placed the dot at D that, okay, let's hear your justification for it. Why do you think a particular number does not belong, but the others belong? And that is where the conversations would start. So a simple idea created just using Jamboard can make a difference in your classroom. Give it a try and see how you feel about it. But which one doesn't belong? Definitely in whichever way you want to use in your classroom will prove helpful. We cannot miss on Google Sheets. We've seen how, whether it is you're thinking about using Excel as a Microsoft product, or you are using Google Sheets, how these play a big role in analyzing the data, how we are looking at the graphical representations that come from Google Sheets. They prove helpful. Google Sheets, again, thinking of it as a collaborative app, can also prove pretty useful, especially when you want all 30 students in your class or 40 students in your class to just share one value. And from there, we are trying to get into some generalization. So again, this is again a credit going to Eric Kurtz for his idea of how collaboratively they would discover the value of pi. So this is again a common exercise that we might do on a regular notebook. But then a child is asked to find maybe 2 or 3 circular objects, figure out what the circumference is, what the diameter is, and calculate the ratio. But what if you want to really take this data to another level? Maybe every child can find 5 objects and put that in a Google Sheet. And if you have 40 students in your class, you will immediately get 200 set of values. And all it takes is a simple formula added in one of the columns. And as those values come up, as the calculation changes, the average changes, and there is a discovery made that there is something happening. These values are going closer and closer to the approximated value of pi. So that is where this Google Sheets can prove very useful when you want to gather data from your students and then bring in some discussion and exploration and reaching out and taking that forward. So this is one small way of doing that, but it is powerful. It has been practiced and tested, and in no time, this activity can be completed. And it is done in a live mode so that everybody can see the effect of these values that are getting collected together. So think about if that is something that you might want to try in your class. Again, some ideas that you can bring in your classroom just to gamify the learning using Google Sheets. So this is a kind of an app smash of bringing in an image into the Google Sheets using conditional formatting, so that as the student answer these questions, so this is simply on factorization. As they answer these questions, if the answers are correct, each tile will show up. It's all linked with the concept of conditional formatting. And the moment their puzzle is completed, that means they've got all the right answers. So it is a way of assessment, but it is gamification, because this is where the child is waiting to see what kind of an image will emerge. And if it doesn't, then they know that they have got something wrong. This is simply Google Sheets and conditional formatting. Here's another one example of the same. It's kind of a self-check worksheet. So the questions are coming up here, and as the answers are fed in, the student get an immediate feedback. And also, if there are 10 questions, then this bar is changing on the top, indicating whether the child has been able to do it all, or are there still more to be left to be done. And again, I want to give a shout out to Mandy Tolan, is a maths teacher whose website Infinitely Teaching has many of these resources and also tutorials on how to create such kind of worksheets. So if you would like to check that out and try and create something of your own, then please try to follow her and see if you can do that for yourself. So again, this is nothing but Google Sheets transformed into a self-check worksheet, simply using conditional formatting, nothing else. The answers are linked with another sheet, which is hidden. The student is not able to see it. And again, you can assign to the student through the Google Classroom, or you can give a link with a make a copy kind of a thing for all of them if you don't have Google Classroom in your school. Then comes a little more interesting aspect. Google Docs and Sheets and so on, they seem to be something that, yes, we are familiar with, we might have tried and tested it out. But Google Earth is kind of a 3D rendition of, what the maps would look like. So Google Earth is an amazing aspect of what you can do with the technology. So sitting at home, you want to visit another place, what it looks like. Maybe you want to visit Paris, so you might want to go to Eiffel Tower and you want to visit what it looks like. You can do that through the Google Earth. So how does maths come in? In Google Earth, there are certain projects that are already ready, which you can use in your classroom to give students a chance to explore maths in real life. And this is one of the projects that is ready-made, and that is on triangular structures. I hope this is open now because it takes a long time to open up. So I was trying to open it as we started. But what it does is, let me see if it does. Let's try once more and see if it will open up. It does take a little while to open up, but I hope it will do it. What it does is great. I'm happy it's done. So this is where it starts. Let's explore and see, and then talk about what you are observing. So this is like a set to slides, from one point to the other. You're talking about triangular structures. So the very first structure that has been linked is Bank of China Tower. And again, as it says, Bank of China Tower has a number of triangular shapes in its structure. Notice the triangular shapes on the exterior of the building. Architects use triangular forms to strengthen buildings. And then there is also something called as a learn more. We'll come to that in a moment. But what is happening here? In the Google Earth, you can go as close as you want. You can go right on the ground level. But if you want students to explore the triangular structures, you can go and zoom in and talk to them about what do you observe. What are the things that you are able to identify here? You can zoom in and out. You can actually drop a person right at the earth level here as well. And you can try to bring that, closer and closer exploration of it. And there we go on the ground level, which is not so helpful to understand what is happening to the triangular structure. But just in case you want to take a tour around, and since we are giving a chance to the student to learn something different, then why not? We can always have that understanding coming in, and you can zoom in and out from there. The learn more is connected with a video, right? So if you want to click on that, let me see if I can open it in the new tab. You will find again a chance to take this learning forward and talk about the geometry. So you can have a video where geometry applications, triangles, segments, etc. And there is a geometry video linked there. Moving ahead, you want to take a more, structures coming in. Let's click on this arrow and we go to Eiffel Tower. So we are now into the Eiffel Tower and we are looking at the possibility of triangles present there. So this is, again, for any one of us who doesn't get a chance to examine these wonderful places and structures at close range, Google Earth allows you to do that. And what better way than to bring maths into it? So again, there is a little write-up which you, if you're creating these projects on your own, you can add these write-ups for yourself. So Eiffel Tower is made up of a network of triangular shapes. Take a close look at tower and you will see a multitude of triangles. So how does one take a close look at the tower? So bring that, this is where your Eiffel Tower is, and we can go closer and closer to that. So let's move this here and then zoom in and then have the children look at the structure at close range and try to see the presence of those triangular structures everywhere, absolutely everywhere. So that is the possibility of, having a Google Earth project coming into your classroom. More structures are added in here, in fact. So there is a luxury hotel in Nevada. Again, you will find that it has the shape of a square pyramid. And notice its triangular sides. So again, this is, again, something which possibly one would not ever get to know, but you are taking them and again, building up that engagement in the classroom. Maybe you're setting them off to the class 9 and 10 chapters of triangle and geometry, and you want to bring up some kind of a discussion or give them a project. Why should we have something ready-made when you can ask them to be the creator? So let's try to see what can happen if we give them a chance to create something. So maybe You can ask them to look for maybe polygons around us or shapes around us. Keep it open. Ask them to look for maybe shapes around us. And they are left to figure out, are there any particular, maybe nature has given us certain shapes, or you are looking at certain well-known buildings that have shapes. So one of them, this is the way that the students can create these projects. So here is the first landmark added in, pentagon. And so when we are talking about polygons and we talk about regular polygons, do we have any pentagon around us? Are you ever seen a building which is in that shape? Maybe go and explore and see if you can identify. So that is what you're looking at right here, right? Again, I'm going to put it in the present mode, but this is in the editing mode, where they can actually add a new feature. They can search to add places. They can add place mark. They can even draw line or shape. And we can have more add folders and having subfolders. I'm going to put it in the present mode to show you how one can use the advantage of plotting lines and adding shapes to it. So we have come to put a place mark on pentagon. And then the student is being asked to discover what it is. So here is where pentagon is. And using the draw and add shape tool, one can easily draw these shapes. And this is what students will do. And what fun it would be when they are presenting and each one has come up with a different place mark and has identified a different building, or they have done some research and figured out if there is a shape in the nature which is perhaps in an H form. So here is another polygon that can be identified, and they're again going through it. They'll mark it, they'll read about it, they'll do a research and maybe think about the historical aspects of it. So again, interdisciplinary projects, if you want to create, that is something that can easily be done using these tools. So here's another way of looking at, this one is still to be done, but here is a place mark, and then they can go and add their shapes, etc., bringing in again the significance of triangular structures or pyramids, or maybe even a circle. They will have enough opportunities to see these shapes that we often talk about and leave it only at the textbook level, but take it to the real world. So Google Earth is going to definitely, bring in loads of learning opportunities for each one of us. Closing in with the last thing that I wanted to highlight is sometimes, when you open these Google apps, you find them to be a little inadequate in terms of what the major struggle of maths teachers is. How do I type maths? How do I make my maths digital? So if you have not explored Equatio so far, I would advise you to go and try that. That's a Chrome extension that you can easily add into your browser and use that to type maths. Type maths and also create, digital content where you are looking at a possibility. Let me see if that is coming up. Okay, so something is missing here. So let me give you a quick demo of Equatio, and then we will stop at that. So here is, it's loaded now. So this is our Equatio as a Chrome extension that you will find in your browser. You can install in your browser. And once you click open Equatio, you will find all these little tools here. You can have an equation editor. If you know LaTeX, you can use a LaTeX language. You can insert a graph, again, integrated with Desmos. You can handwrite and Equatio will recognize your handwritten maths. You can speak maths, and so there is a speech recognition as well. You can scan a handwritten text with your mobile phone and link it up with Equatio, and it will transform your handwritten maths into the digital maths. All that possible, along with it, something which you might want to try and explore later as math space. I'll need a one full hour session if we have to talk about Equatio. So I'm not going to get into that, but wanted you to understand that sometime when we open up a Google Doc and say, okay, where am I going to get my maths in? Yes, you can get Google Maths in through the input of the equations. But if you wanted to be more specific and get more stuff in slides and also in Google Forms, and if you have a Google Workspace for Education account, you can sign in as an educator free for Equatio and use it in Google Forms as well. But in docs and slides, it's free anyway for everyone. You can just install the Equatio Chrome extension and try using that. So with that, I'm going to stop and thank everyone for joining in today. And I'll be happy to take any questions, any queries that are coming in the chat, which I have not been able to keep up with. But if you have any, I'll be happy to answer that. And feel free to reach out to me if you want to get any clarifications or any resources or any ideas, or if you have anything to share, I'll be happy to get those ideas from you. So thank you. And thank you, Professor Rana, for the opportunity, and wishing everyone Merry Christmas and Happy New Year.
Thank you, Sangeeta.
Thank you, madam. Yeah, if one of the some of the audience has any question, please you can unmute and ask.
Sangeeta, I just wanted to ask, yesterday, were you there in this Padmanabhan's lecture?
No, sir, I couldn't follow up. Yesterday, I had lots of evening engagement.
Okay, he used Google Jamboard.
Okay.
To know the participants.
Right.
So that looked very nice, a very simple kind of application.
Yes.
How does one do that? Do you have an idea about?
So he might have just shared the link with anyone can edit, and everybody can just join in. So they can, yes. So you just have to look at the sharing settings of any Google app that you use. So it can be, just one particular person, but if you want it to be open to anyone on the internet who can edit, you can change the settings and everybody can join in there.
Okay, good. Thank you.
All right. So no queries in the chat I have seen. So yeah.
Yeah, chat doesn't have anything, any questions or queries or suggestions.
Yeah.
So much of you have given, they have to assimilate and probably later on. Yeah. Soumya, go ahead.
Yeah, thank you, ma'am, for this nice talk. So we will meet at 11, I guess, the next talk. Let me just.
And probably, Sangeeta, you can share in the chat box, you can share your email so that if somebody wants to contact you.
Right, sir. I'll put it in the chat. Thank you.
Yeah, so we meet at 11.
Yeah.
Soumya, can we get a sound for this movie? This is so interesting. I love it, but we are not able to hear it.
Yeah, I think while sharing,
Hmm.
you need to optimize for audio and share, something like that. So
Okay.
yeah,
I will share it again.
Okay,
yeah.
sir.
Yeah. Okay. Let me stop sharing. Where is that gone?
There is a optimize for video and share audio option.
Yeah, no, I'm just looking at where is my control for Zoom. I minimize it and I'm not able to maximize it. Yeah, fine. Stop screen share. So I have to optimize by
Both video and audio.
after clicking screen share.
Video and
Yeah, okay.
Around someone.
Is it okay now?
Yes, sir, I can hear. Thank you.
yeah.
So you figure it out by staying right where you are.
Ah! But how do I do it?
Infer the shape through the shading. See?
Square, how are you?
Not bad, not bad. Is my brother in?
I can't do it. Am I stupid? I must be a feeler.
Sight recognition isn't easy, I know, but it'll come to you.
Your brother is here.
We'll continue the lesson in a moment.
Do we have to? I got him! We're gonna get him! Yes, we got another one! I got you! No, you didn't! Yes, I did! No, you didn't! Yes, I did! No, you didn't!
B square.
A square. What's this about representing a line?
I haven't taken her case yet. I'm meeting her this afternoon.
But she's a chromatist
Accused. Like 5% of the population.
of the male population. She's the first woman who's
Just
joined the...
because you work at the ministry, you can't go around accusing people without evidence.
Oh, there's plenty of evidence, big brother.
Ah, so another show trial.
Can't you talk any sense into your husband?
I might puncture some into him.
Don't forget your peace cry. You could be arrested. That's not funny. Don't encourage her, B.
Hey, Hexagon. How's my favorite nephew?
Okay, what are you talking about? Is it about chromatism? Is it? Chromatism is cool.
Where did he hear that?
Go to your room. But my lesson.
In your room.
Oh, all right. Can I get you anything, B?
Well, I can't stay. Big doings this afternoon. The president is going to meet with chromatistes.
A concession?
Just don't go out for a while. That's why I came by, to warn you.
But my client, I'm meeting her this afternoon. I never miss an appointment.
Listen to your brother for once.
Sometimes even lines give good advice, big brother. Attend to your configuration.
Attend to your configuration.
President Circle, sir, where are you going?
Follow me. We'll talk as we head for the hospital.
Hospital of Reconfiguration?
Yes, the first line had a child last night. Something went wrong, an irregular side.
I'm so sorry, sir.
These things happen. The hospital has good doctors. In fact, I'm heading over now to see my son for the very first time. Completely reconfigured by now.
And your wife? Is she all right?
Yes, of course, in the recovery room. But she picked a terrible time for a pregnancy. The chromatists, Senator Chromatistes, the constant threat of war on the border. So, did you review my plan?
Yes, sir.
Problems?
No, sir.
Good.
Professor Barry Kisson, are you here?
Yes, I am.
Yeah, please, you can try sharing your screen.
Thank you. Okay. Can you see? Can you see
You
my
see your full
calculator?
screen, I guess. Yeah.
Yep, I want to share the full screen. Yep. Can you see my calculator and also PowerPoint? And can you see?
Yeah,
the
now
PowerPoint?
we see the slides. Yeah.
Can you see the slides? Okay. And that's good. And you can see the calculator now?
Yes. Yes. we
That's
can
great.
see.
Okay, that's all I need. Thank you very much. I'll stop sharing now and I'll share it again later so you can continue the cartoon or whatever.
Yeah. Okay.
Okay.
And the speech?
Brilliant, sir. Absolutely brilliant.
Good.
What's wrong with Hex? He doesn't seem interested in his lessons.
One of his older brothers told him that he was reconfigured.
What?
Hex was making fun of them, taunting them. Low class, low-sided. I think E-Pentagon just wanted to make him shut
Now,
up.
why did E go and do that?
Hex was being pretty nasty.
There's no shame in reconfiguration. It was a small genetic defect. We should make Hex proud that he's a hexagon, the first in the family.
Some humility would help to temper that pride. Go talk to him.
I will.
Find the physician.
Yes, sir, Mr. President, right away.
So, B square. Is everything in place?
Yes, sir.
No doubt it's just year 3000 madness.
Color can't make us all equal. It's morally repugnant.
Mr. President?
One moment, Doctor.
Sir,
One moment. Affairs of state. The evil of it is so perfectly straightforward. There is good and evil, B. Why can't they see
I
it?
can't explain such blindness, sir.
Mr. President, sorry to interrupt, but I must inform you, your son,
Oh, no.
I'm sorry, he didn't survive the
Where is
procedure.
he? Where's my son? Son! Where is he? Where's my son?
Shall I?
Son! Son!
We did everything we could.
Son, where
His
is
body
he?
just couldn't take
Son!
the procedure. The deformity was too great.
Son! Son! How could you do this to
We
him?
did try.
No, of course. You're all good men.
Is there anything we can do for you,
He
sir?
didn't even have a name yet.
Sad day,
The
sir.
loss of a child
I'm sorry.
is like having
Sad.
positions for incompetence.
Please, gentlemen, one moment. We all have to be brave, make sacrifices for the greater good. Please, accept my apologies for my emotional outburst.
Totally
Inability to
understandable,
show
sir.
emotion is a sign of strength and
Perhaps we should postpone our plan.
No, this country needs me, especially now. Grief is a luxury that a leader cannot afford in these times.
Barry, is it all set?
Yeah, I think so. Can you see my screen?
Yes, I can hear you clearly and see your screen both.
Okay, and you can see me and hear me. You don't need to see me, but you can hear me.
Yes, sure.
Wonderful. Okay.
So it's the time to welcome our speaker for the second session, Dr. Barry Kesan. He is Emeritus Associate Professor of Education from Murdoch University, Australia. So thank you, Barry, for being with us, and please share your ideas.
Thank you very much, Professor Rana, and good morning to everybody, or good afternoon from here in Perth in Western Australia. It's a great privilege to be involved in this interesting conference. As you can see, my talk is concerned with scientific calculators, and in particular advanced scientific calculators, and I'll explain what those are in a moment, and in particular using tables on the calculators. And you can see on the opening slide here, you can see a table of values, the triangular numbers and the sums of the successive sums of squares of integers, but we'll get onto those examples a little later. What I'm going to talk about today is to firstly remind ourselves of the educational importance of scientific calculators. Some people think, and I'm one of them, that this is a technology that's often forgotten or neglected. And I'm hoping to encourage you to think about it a bit more positively than that. I'm going to use a model for learning with calculators that myself and my partner developed some years ago, and as background to what we're doing. And I'm going to show you then some examples of how tables might be used in various learning contexts. My focus is on the students who are learning, not on what the teacher is able to do. And then I have a few brief conclusions. As you know, the early calculators, I can remove, trying to remove this thing from the bottom of my screen, I can't. Early calculators were originally designed for computation, for arithmetic, and many of them are still like that. And there's a picture here of a calculator I saw recently in a market in Vientiane in Laos. And I've seen calculators in India in the same sorts of market contexts. Scientific calculators, of course, were more important than that. They extended the capabilities somewhat, so that you didn't need a book of tables, of log tables or squares and so on. But the recent developments of calculators have been educational. And so we come to advanced scientific calculators, which have come a long way in 50 years. We still call them scientific calculators, although I really don't know why. They're not really for scientists and engineers. They're actually now for schools. And all of the refinements of calculators over the years have been for educational purposes, to allow students to explore, experiment, and to understand mathematics, certainly not just to calculate. And the changes that have happened about representing mathematics in more natural ways, more conventional ways, the functionality, what they can actually do, the user friendliness, how easy it is to do that, and the kinds of software that are available are important. Now, I don't know why I can't get rid of this thing at the bottom of my screen. I'll just have to put up with that. I guess it's necessary to justify a little bit why in this day and age we would be thinking about calculators. There's a whole bunch of technologies that people can use in schools and do here in Australia, and certainly clearly in India. And we've seen some lovely examples of those over the last couple of days. Computers, netbooks, of course, they need software. Tablets, the internet has been very prominent in our discussion, smartphones, but not so much calculators. I've heard very little discussion about calculators. How do we choose from technologies? And why should we choose them? So I have some criteria to share with you, and these might help understand why I'm here. I want the technology to be used by the students, not by the teachers. So that means they have to be easy to use, and they have to be affordable to almost everyone. If it's not affordable for almost everyone, it won't actually be part of the curriculum. It'll be an add-on for wealthier people or more affluent environments. They need to be designed for the school curriculum, not repurposed in some way, designed for some other purpose, but used in schools. So they should focus on what's important in schools. They should be flexible, allow the person using it, in this case the student, to take charge and to be responsible for what they're doing and to think about what they're doing. But they shouldn't be too distracting. They shouldn't require lots of extra purchases like internet facilities, computers, Wi-Fi, staff, and they should last a reasonable amount of time so that they're affordable for schools. Many schools are relatively resource cash strapped in my country as well as yours. And importantly, they should help to connect and align teaching and learning and assessment. So how do their various technology stack up? Here's my sense from 2021. They're all pretty easy to use, these various technologies. Not so much for mathematics. For example, if you're using a computer for mathematics, you need to get some software, you have to find it, download it, learn how to use it, and so on. So it's not immediately easy to use. The internet is quite problematic to use for mathematics. You've got to know where to look and you've got to know how to interact with it. Smartphones are, I think, frankly, a disaster for mathematics, although some people think they're okay, but the limitations are too substantial. Affordable, the first three are not really affordable to many families. I've heard Professor Rana the other day saying, when you think about rural schools and villages and so on, the affordability equations are quite different. Smartphones appear to be ubiquitous in India as they are in my country, but in my country, many students are prohibited from using smartphones in schools for what I think are pretty good reasons. No, most of these are not designed for mathematics education in school. In fact, arguably the calculator is the only thing, the only piece of technology designed expressly for mathematics in schools. They're all very flexible, but the first four are very distracting. I know of nothing more distracting than a smartphone, unless it's perhaps a tablet or a computer. That's one of the reasons in Australia, in some schools, in some states, phones are banned from schools. Students are not permitted to have them because of the potential distractions of many different kinds, most of them unhelpful. You do need extra resources to most of these technologies. They are problematic in terms of their lifespan. And as far as assessment is concerned, in Australia, the only one of these technologies that is routinely permitted for use in high stakes examinations, national kind of examinations, are calculators. The others are used in school, but not used in the examination system. So there's a disconnect between what you do in the classroom and what you do in an examination environment. So I think, as you can see from this screen, I'm unmistakably an enthusiast for using calculators for these kinds of reasons. Now, there's some common worldviews about calculators. You can see them here. You may even hold these views. I often hear them in my wandering around Asia and around Australia, and certainly around India, that the calculators are basically for doing arithmetic. To get an answer, you do your mathematics first, you do your thinking, and then you might use the calculator to get a numerical result. There's a bit of a focus on what you will do in an examination when they are allowed to be used in examinations, and a focus on using them efficiently in that context. They're really just a tool. That's a common view. I don't share that view. This is the view I have. The calculators are interactive learning devices. Students can interact with them. You do something, it does something back again. They are designed to help develop insight into mathematical ideas. They're part of the learning process. Lessons might involve using calculators, not after you finish learning, but as part of the learning. So there might be a focus on what do we do in the classroom? How do we design lessons to make use of this technology? And I think of the calculator as a learning tool. So these two side by side are quite different worldviews. I'm in the right-hand column. I don't know you or where you are. You may well be in the left-hand column or somewhere in between. I'll share with you briefly the model I mentioned for using calculators in education. Why would we do that? And I think, and Marion and I, my partner, thought there are four main reasons. Firstly, to represent mathematical ideas and relationships between ideas. Represent, perhaps also in the sense of represent, present in a different way. Computation, yes, calculation is important, particularly if the numbers are awkward, too large or too small, or real numbers, you've measured them yourself or got them from a good source, a statistics book or something, then a calculator is certainly helpful. Exploration, playing with ideas, investigating, discovering, that's how we learn things, by doing things and then thinking about what we've been doing. And finally, affirmation, which is about checking your thinking. What will happen if I did this? What will happen next? And so on, is about thinking mathematically. Janaki Ghosh the other day talked very nicely about how we might think about mathematics in the context of technology, and affirmation is certainly part of that. The model details that I mentioned a model, this is written as a form of a paper. You can download them from my website. I'll put my website on the or you can send me an email if you don't have time to take a note of that. And I won't say more about it right now. But let's go back to calculators. Tables have been available on calculators now for almost 20 years, and they're easily to find and used. You need to generate a table with a function of some kind. You need to set the parameters for the table, you need to set an increment size, a starting point and an end point. You need to navigate around the table. And of course, there are constraints with a small calculator screen on how big a table can be and how sophisticated it can be. So that's the big picture. Now we'll look at some examples, but in the back of my mind, I want you to think about how could a learner use these tables? And in particular, think about someone who has not yet learned the mathematics that's involved. That's important when thinking about learners. Think about someone that doesn't know mathematics yet, rather than thinking about the teacher. So let's look now at some examples. I'll just change this. This technology is proving to be quite tricky for me. Trying to change this to, here we go. There we go. Okay, hopefully you can see my calculator over here. Just to give you a very, very quick look, this is a Casio ClassWiz, an example of an advanced scientific calculator. There are other examples, of course, but this is the one I happen to have available to me and I'm reasonably comfortable with. You can see that at the moment it says it's about calculation, but it also deals with, in some sense, complex numbers, numbers to different bases, matrices, vectors, statistics, probability distributions. There's a spreadsheet involved. There's a table, which is what we're going to be looking at, equations and inequalities and ratios. I've just been told, hold on, I'll plug in my, now I don't need to tell you, you never have that problem with a calculator. Okay, so let's look at linear functions. And I'll think of a very simple example here. So on my calculator, I've got a big screen up here. You can see more easily what's on the smaller screen down here. It's just a clone of the screen. Let's think of a very simple linear function. The students that are just learning about these, and we ask them or advise them to put in the function f at x is equal to 3x add 5, and to maybe start with 1, x is equal to 1, going up to 10 in steps of 1. And here's our table. So you can see that what we have is firstly a symbolic representation of the function in the conventional mathematics terminology. And we have the representation numerically as a set of ordered pairs of the function, 1 and 8, 2 and 11, 3 and 14, and 4 and so on. And in fact, students that are beginning to learn about these things, if they have some examples, will see that these seem to go up by 3 each time. Given the particular function, the teacher's not surprised, but the students might be. And we can even ask them to say, well, what would be the next one? What would happen if x were 5? And because the screen has only 4 lines on it, this question comes up quite often. Well, hopefully students can say, well, it's probably going to be 20. And indeed it is. And next time we think it might be 23. And indeed it is. Of course, if you wanted to draw a graph of this function, having a table would make that very easy. But also learning about how the parameters affect the function is relatively easy as well. So for example, what if we had not 3x add 5, but say 2x add 5? What difference does that make? So this is a similar kind of function, but now it's going up by 2s. Eventually we will start to call this the slope. And indeed, if we draw a physical graph, we'd call it a slope. You might think of an advanced scientific calculator as a graphics calculator that doesn't have a graphics screen. And one of the reasons, incidentally, that they exist is that there are some parts of the world where graphics calculators are prohibited, but scientific calculators are okay. And so we have many of the facilities of a graphics calculator, but without critically the graphics screen. But as you can see, we can students can play with the parameters and see what kinds of effects they have. So for example, we might even say, what if it was not 2x add 5, but 2x add 6? What difference does that make? So that now we have the first one is changed, but they're still going up by 2s. The slope is still 2. We could ask questions like, will the function have a value of 60? Well, it seems that so far it doesn't seem to have a value of 60, but students might be able to think about making a guess about this. So which function have we got here at the moment? 2x add 6. They might think, well, to get 60, you'd need to have 27 doubled and add 6 to it. So we could see that on this calculator, you can actually say, what if x was 27? And indeed, it turns out that the value for y then is 60. So we can think about functions and equations at the same time. So you can see the environment here for thinking about the calculator, thinking about linear functions. What about quadratic functions? Those are different, and normally the next step for students learning about functions is to go from linear to quadratic functions. These are different, of course, from linear functions, but many of the same capabilities are built in to the environment. So again, let me just look at an example for you. Here we'll clear that one off and put in, say, I've got some written down over here to remind myself, say x squared, oops, daisy, x squared, add 4x, add 3. Now you wouldn't start with that, but that's not the first quadratic function you do, but let's do that. Let's use the same range, it saves time. What we see here is, again, we've got a set of ordered pairs for the function. But unlike linear functions, the slope isn't constant. Then it's not changing by the same amount each time. From 8 to 15 is 7. Now, then it goes up by 9. Then it goes up by 11. What will happen for the next one? If it went up 7 and 9 and 11, it probably 13 wouldn't be a bad guess. And indeed, that's what happens. And the next one is probably 15, which might be 63. And yes, it is. So students can think about that as they go when they're playing. This is the student playing with this, not me playing with this. So there's lots of possibilities there, again, to change the parameters, see what happens if we were to change some of these. See what happens, for example, if we change the range from -5 up to 5, say, again, in steps of 1. And what we see here are some interesting things. Firstly, we see the values seem to be going down. 8 down to 3, down to 1, down to -1. That's a bit strange. And then they start going up again. We see some values that are equal to 0. Here's one that's equal to 0. And there's another one. It happens a couple of times. We can see the symmetry associated with the quadratic function. 8, 3, 0, 0, 3, 8. So students have a chance to see there's something different about these than was the case for linear functions. And of course, they can put their own values in and see all of that as well. They can see that it's nonlinear. They can see that it has some kind of symmetry. They can see that it has 2 roots, and it always seems to be the case. And of course, if they put in other examples, the same things will happen. Okay, so I got back to my same problem with this device. What about trigonometric functions? Again, we can get a set of ordered pairs and a symbolic representation. And from these, we can visualize the shape and think about the properties of trigonometric functions that are important to us. So for instance, let's go to here. I need to check. At the moment, my calculator is set to radians. So I'm going to set the calculator to degrees. Of course, you can always do that on calculators these days. And let's put in a function like, say, the sine of x, which is probably where most trigonometry begins. Let's say, think of some values dealing with degrees. So let's start from 0. Let's go up to 435. And we could give the students these values and say, what do you notice? have a look at the table of values for this function, see what you see. And what we see is it starts at 0, it goes up to 1, and then it starts going down to 0 again. That's a little bit different from linear and quadratic functions. And then all of a sudden it's negative, right down to -1. Then it starts getting up again, up to 0. And then we've got the same values that we had before.
Barry, hello. Is there some issue with your mic? Your volume has come down.
I'll pull the mic out and just speak. Is that better?
No, still can't hear you properly.
I'm very sorry. I don't know.
Now it's okay.
More loudly, okay?
Yeah, that's fine. Please go ahead.
Okay, I'm sorry about that. I didn't. Thank you for telling me.
No, it's okay.
So from a table like this, students can see things about the quadrants, the periodicity of the functions. They can see at a more unsophisticated level what happens between 0 and the first quadrant. The numbers go up, the values of the sine function go up, but they go up relatively in what looks like a strange way, not a uniform way, as was the case for linear functions or quadratic functions. It's something different from that. But we can see, we can visualize what it's like going from 0 at 0 up to 1 at 90 and then coming back down again. And notice the symmetries. It's the same at 105 as it was at 75. It's the same at 120 as it was at 60. So we get a sense of what the shape of the graph looks like. But we could, for instance, we can do more. We could put in a cosine function. The students can put in a cosine function. So what happens with cosine? And let's look at the table. And cosine looks rather different. It starts at 1 and it gets smaller. But notice that some of the values look to be the same as those in the sine column. So some of the, and in fact, if you look more carefully at that, the cosine of 15 degrees is the same as the sine of 75 degrees. The sine of 60 degrees is the same as the cosine of 30 degrees. So there are relationships here that we can see. We can see that we can see what happens if we start to play with the actual functions. What if we had 3 times the sine of x? And here we've got, let's make the second one just the sine of x rather than, so we can compare how is sine of x and 3 sine of x related to each other. And we could see, students can see that it looks like 3 times is simply 3 times the value. 1.5 is 3 times 0.5. It goes up to 3 rather than going up to 1. So some of these relationships are built in here. And likewise, we could see some of the other properties that we're interested in. So for example, what if we had students, this wouldn't be the first lesson, of course, make it sine x for that one. And let's look at same time, sine of 2x. What happens? What happens when you get a different argument? And so you can see immediately sine of 2x goes from 0 up to 1 rather more quickly as x goes from 0 up to 45. And so, and then it goes the same kind of shape. It goes back down to 0 again at 90. So we get a visual sense. We can visualize what's actually going on there. So all those properties that are important are accessible by playing around with the table. Equivalence is a very important idea in mathematics. In fact, a crucial idea. A pair of functions, if you use a pair, not just a single function, you can think about equivalence being studied. Equivalence basically means 2 different ways of saying the same thing. And this appears in all kinds of contexts. So for example, let's go back to here. Let's think of an expression like, and hence a function, like x times x add 1. And think about also the expression x squared add x. and choose some values that make sense, like say 0 up to 10 in steps of 1. You can see it's an easy interface for students to use. And extraordinarily, these always give the same value. Why is that? Many students think about algebra as something to do with letters, rather than something to do with the properties of the functions that those letters represent. And so here we have a way of representing equivalence. And we could say, well, what if we change the X value? What if maybe this just happens for whole numbers? We should be skeptical. What if it was, say, 2.5? Are those two values still the same? It looks like they are. What if it was something like pi? Are they still the same? It looks like they still are to lots of decimal places. So it doesn't matter. The two functions have, those two expressions have the same value. Mind you, some students, for example, think that x times x add 1 would be x squared add 1. There are lots of those around that I've certainly taught over the years, and they will find this a bit disquieting because, in fact, the two are not the same. They might occasionally be the same as they are here, but in general, they're not the same. So thinking about equivalence is a powerful process with a calculator at your disposal. And think about, for example, the expression we had previously for quadratic functions, x squared add 4x add 3, and we can see that that's always the same as x add 3 times x add 1. Notice, as I said, the natural display. We're representing things in the same way we would in a textbook or on a page. These two expressions are always the same. That's what factorization is about finding things as a product of factors, but it's the same idea, it's the same expression, it's the same function, but represented in a different and probably more helpful way. Okay, let's try. We can even think of identities. So here's an example for you. And think about the sine of x squared added to the cosine of x squared. Notice this is a slightly different terminology than we use in mathematics. The mathematical terminology of saying sine squared add cosine squared is actually very defective, and all computer systems have a bit of trouble with it. Let's do that. We don't need that one. And here we get an expression that is always equal to 1, which is quite remarkable. Always. What if we put a funny big value in here like that? It's still equal to 1. So this is an identity. It's not a proof of the identity, of course, but it's actually representing the identity, that this expression always has a particular value. That's what makes it a kind of an identity. And students can explore other identities which might seem at the first hand sine of 2x. It's probably natural, particularly to students, it seems to be natural to think that should be the same as 2 times the sine of x, because that's got each of them has a 2 in them. So again, we'll put some values in, and indeed it turns out that they do seem to be the same most of the time, but then they start being different from each other. They're not actually the same. So it's not an identity, although it might look like it for small values. And you know, and indeed I know too, that in fact we need to have 2 sine of x times the cosine of x for this to actually be an identity that's always an identity. Well, not always, no, it is actually an identity. If it's not always, it isn't actually an identity. So you see the idea. So equivalence can be represented with a pair of tables. One table isn't enough. And the early calculators had only a single table. So this is actually an improvement of a kind. Okay. Solving equations. A crucial part of lower secondary and indeed upper secondary mathematics answers the question of when, if at all, does a particular expression have a particular value? That's what solving an equation amounts to. So for example, when, if ever, does x cubed have the value of 3 subtract x squared? We can do that in various ways on this calculator, but using tables in particular, let's think about that particular example. So we'll say we've got the value of x cubed. We'll make a table of values for x cubed, and we'll make a table of values for 3 subtract x squared. And ask, are these ever the same? How would we know? We'll better choose a big range of values to have a bit of a look to see if they're the same, say -10 up to 10 in steps of 1. This particular calculator has a constraint that it can have no more than 31 entries in a table, but for most purposes, that's not a significant problem. So let's see what happens. Are these two expressions ever the same? Well, it doesn't look likely at the moment. This one is very negative and getting less so. The other one is, the other expression is, that's the x3 subtract x squared, is negative and getting less so. But it all looks a bit more promising here. The first function has become positive and then becoming more so, and the other one is becoming positive and then doing something strange around there. So it looks like there might be a place somewhere along here where the two actually have the same value. So we could look, it's probably somewhere between here and here. This left one goes from 1 to 8, which is an increasing. This one goes from 2 to -1, which is decreasing. Somewhere in the middle, they might be the same. So we could have a closer look at that between when x is equal to 1 and x is equal to 2. And by a closer look, we'll just take a smaller step. It's a bit too small, maybe just 0.1, and see, are they ever the same? This is looking promising, but it's actually quite hard to, this is a very tedious process. I'm going to suggest we stop doing it and think about this another way. Rather than saying, when are these two the same, we could say, we could rethink it a bit and say, when is this value, add x squared, subtract 3, when is that equal to 0? It's a bit easier to find a 0 in a table. So let's try that again. And is this ever equal to 0? Well, it looks, it's here it's negative and here it's positive. Looks like it might be somewhere between 1.1 and 1.2. Let's try that again. 1.1 and 1.2 and 0.01. This is not the practical means of solving an equation. It's a means of trying to understand what solving an equation actually means. So it looks like here, these are all negative and all of a sudden it's become positive. So somewhere between 1.17 and 1.18. Let's have another go. Between 1.17 and 1.18. So we can get in closer and closer, rather like the idea of zooming on a graphics screen. We have to go like so. And I keep doing this for too long, but you can get the idea. This is now getting very close to being in there somewhere. That's negative, that's negative, and now it's positive, but a very small number. So it looks like somewhere between 1.17. We could keep going, and indeed students like to keep going because they like to get a powerful sense of what's happening here. So you can see the idea that we can actually, let's do it just one more time because I can't resist it either. Let's try between 1.174 and 1.175 looks to be the point where it changes. So 1.174 and 1.175 is easily changed, and you need to be careful to have a step that doesn't give you too many terms in the table. Now let's try that. And now it's negative, 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 negative. Oh, it's very close to there. So we're very close to the value of a solution being something like let's call it 1.175. We could go back if we liked in the main screen of the calculator and say, what's the value for X at the moment? 1.175. Okay, so let's see what happens with X cubed. X cubed is, X cubed. What is the value of X cubed? It's that number. What's the value of 3 subtract X squared? It's that number. They're very close. Or indeed, if we could say X cubed, and we're now kind of checking the calculator's thinking, if you like. X cubed, add X squared, subtract 3. What's that equal to? It should be pretty close to 0. It's not exactly 0, but it's pretty close to 0.002. So we're getting close. We could get closer, of course. Okay. So the idea of an equation can be dealt with here. The calculator itself has more powerful means of solving equations than this. That's not the point. We're thinking about students understanding the ideas of equations, not as a set of rules that you follow to do the same thing to both sides or something like that, or find the factors. Incidentally, when I left school very many years ago in the 1960s, I couldn't solve this equation. I couldn't solve it at all. I don't know about students in India, but I suspect it's a similar problem. So we could solve only a very small, restricted collection of equations that we could do the same thing to both sides, find the factors, and not much else. So I think we need to broaden the curriculum a bit to think about other kinds of equations that don't fit those molds. Sequences and series. So we can represent a sequence, we can represent a series as a sequence of partial sums, and we have a difference from our normal approach to sequences and series that we can actually access the sequences directly. So let me show you an example of what that means. I have to go back to the table part of the calculator. Think about the sequence, the geometric progression here, 3, 6, 12, 24, etc. Takes a little bit of thinking for students, but not impossible to see that that's no problem.
You can unmute yourself because somebody was doing, so I muted everybody.
Okay. Think of the expression as this is the generating expression for that sequence. And let's just check that out by putting in some values like 1 up to, say, 20 and 1. So here's our sequence. 3, 6, 12, 24. The difference with our normal approach to sequences and series is we're not dealing with formulas and evaluating expressions. We're dealing with the actual sequence. So if we had questions like, for example, what's the 8th term of this sequence? I simply go down and say, well, there it is, it's 384. Or if we had a question like, which is the first term of the sequence that's larger than 1,000? There it is there, it's the 10th term, which is 1,536. So we can answer questions about a sequence by accessing the sequence itself. And of course, as before, we could easily manipulate the expression. What if the expression was this one? What difference does that make? Well, again, we have a different sequence, but it's of the same kind. Each term is twice the previous term. It's a geometric progression with a common ratio of 2. And indeed, if we changed the 2, we could see what happens if we had a common ratio of 3. So it's easily manipulable environment to see what sequences are like. Here we have a common ratio of 3. Each term is 3 times the previous term. Let's go back to our original sequence, which was 3 times 2 to the power x subtract 1. And so what about the associated series? Now, as it turns out, as you can see from the screen here, if you've got a good enough resolution on your computer, that the calculator actually has an expression for doing that. And so we're going to find the expression of the sum of this sequence, which we now call a series, going from, oops, daisy, that's going to give an error. Yes, I didn't finish the expression, my mistake. We want to go from x goes from 1 up to not a particular value, but a general value, which we'll just call x, which is the parameter for the table. And so now just takes it, the calculator's taking a moment because it's having to do some computations. It's not slow, but it's not super fast either. So you can see here the second column of the table, 3 and 6 make 9. 3 and 6 and 12 make 21. 3 and 6 and 12 and 24 make 45. The next term here would be 6, 12, 24, 48. We'd expect the next term to be 93, which is 48 more than 45. And indeed it is. So it seems to be working okay. So we can deal with this with the series in the same kind of way directly as we could deal with the sequence. And again, everything is easily manipulable. So there's opportunities there for playing with and learning about sequences and series. Limits and convergence are important in the upper secondary part of the school. So thinking about, say, the limit of sine x over x or limits to infinity. The tables can allow us to represent the idea of getting closer and closer to something. So let's try that first example, which is one of the more interesting expressions for finding limits because the result is quite unexpected. Sine x over x, as x tends to 0, we certainly don't need that. X tends to 0, what's that mean? Well, let's think of some values that are close to 0, like negative, say, 0.5 and positive 0.5 and going up in steps of 0. I know that's not very close to 0, but we'll get a bit of an idea. Oops, daisy. What have I done? No, it's not. Let's see what I've done. I can't see what I've done myself. Syntax error. Calculator's complaining that I haven't got the range error. These things happen in public. Well, let me choose a different table range. Let's go from negative 0.1 up to positive 0.1 in steps of 0.01. That should be acceptable. I don't know what I was doing there before. So as you can see here, as the values for x get closer to 0, we have an error there. I know what the problem is. I'm using degrees. I beg your pardon. Entirely my mistake. I'll now change to radians. It's always helpful to make mistakes in public. Okay, here we go. So you can see here that these as x gets closer to 0, these values appear to get closer to 1, but of course cannot be defined when x is equal to 0. And if we took getting even closer than that, negative 0.01, which is quite close to 0, 0.01, of course also quite close to 0, and did the same thing. Now we're getting closer. We can see the values are very close to 1, but of course we still can't get a value when x is equal to 0. And now the values that's showing at the bottom getting a little bit further away as we get further away. So the idea of a limit here being approaching a limit from both sides is we can represent that idea of getting closer and closer in ways that we simply couldn't previously. Thinking about limits to infinity, the example on the screen there, the limit to infinity as x tends to infinity of 5x. The calculator only allows me to use x, so I have to, in my mind, or the students in their mind have to think this is the same idea as a limit of 5n add 2 divided by 3n subtract 1 as n tends to infinity. You can't do infinity on a small machine like a calculator, so but we can get an approximation to infinity by taking some very big values. So let's take, say, 500,000. That's a pretty big value. And finish at, say, 600,000. And have a step of, say, 10,000. And what we see is it looks that as we get larger and larger values, this is seeming to get closer to a limit. Let's try something more drastic. In Australia, we use the term a billion. I think you have a 100 crore or 10 crore or something. I don't know. I'm sorry about my ignorance. Let's say a billion and say up to 2 billion. And we're going to have to go up in very large steps of, say, 100 million. I hope I haven't mistyped that. I haven't. So we can see here that as the value approaches infinity, this looks very much like 1 2/3, which of course is related to 5/3. So we can get impressions of limits quite well from a table. And even things like the exponential function, for example, if we did 1 add 1 over x as to the power of x for very large values as x tends to infinity. We'll even try these. We can see we're very close values there, but it's taken us about 10 billion terms or a billion terms or something like that. If we were to choose different formulations like this one, which I'm sure you'll be familiar with, the sum of the successive terms of the exponential series, 1 over x factorial, as x goes from 0 up to, say, 20. That's not correct. Let's go back. Oh dear. I caused myself a problem. I didn't mean to do that. Let's go back here. I want to go up to 20. I want to go up to x. So some particular value from the table. And in the interest of time, let's just go from, say, 1 up to 20. So only 20 terms. And you can see very nicely how the values start and converge very quickly to the value for E. So students can learn about convergence, about rates of convergence, and so on. Okay. And then finally, I'm running out of time as my phone just reminded me. An advanced scientific calculator has commands for derivatives and integrals, which allow students to learn about these things, not as algebra, but as ideas. So for example, think about the derivative of x squared at any point x. And let's take, say, the first 20 values. Let's even take the first 10, we're in a hurry. And students can see that the derivatives look like this. 2, when x is 2, it's 4. When x is 3, it's 6. When x is 4, it's 8. They might guess. The next one is, well, it's probably going to be, looks like it's twice that first one. It looks like it might be 10. And yes, it looks like it might be 12. And in fact, we could test or check that in general, it looks like the derivative is twice the value for x, which is quite surprising, as indeed it is. And in a similar kind of a way, students can play with the idea of the, sorry, wrong one, the integral of a function. Let's try, again, a fairly simple example. The integral from 0 up to x. I'm not going to do that. Over range. And it looks pretty clearly, hopefully to students that are studying calculus, it's pretty clear. These are the squares of the integers in the first column. So the next one is likely to be 25, I think, and then 36. Yes, it is. And indeed, we could check that in fact, in general, it looks like the integrals are related to the squares. And indeed, it's not a huge jump to go from there to start to look at values, the notion of the fundamental theorem of the calculus, the relationship between derivatives and integrals more generally. So I've only got a couple of minutes left, but I hope I've shown you enough examples for you to see there are strong connections between the mathematics and the calculator. And the students can be doing this. In a classroom, the students can be directed to use tables in a certain way. We can give them activities to try for themselves, to experiment with for themselves, to change the values, to see what happens. It's much less powerful, of course, for the teacher to do it than the student, as has been the case here. You haven't been playing with your calculator, probably, but I have. I'm enjoying myself. You're just watching. It's not quite the same. And of course, all of this work needs to be built later, built upon with formal analysis to build on the intuitive foundations and the insights that the calculator might provide. All of what I'm saying is in a written paper, which I'm pleased will appear in the lovely journal At Right Angles. I hope you've seen this journal. It's from India, as you can see, from Azim Premji University, from the foundation. It'll come out, I believe, next March, all going well. And if you haven't seen this publication, find it. It's very nice, and it's got lots of really great stuff for your students and indeed for yourself. So everything I'm saying here will be repeated there, but said in a different way. And in case you're interested in such things, there's a free resource book for this particular calculator, which I wrote some years ago now. I think it was 2015. So the calculator's been around quite a long time. Lots of explorations and activities, including many different topics, and many of them use tables. That's how I've come to know that tables is a very powerful feature. The emulator I'm using is also available as a download, a 90-day evaluation copy as a download. Beyond that, you need to pay for it. But just a reminder that the calculator is meant to be used by students, not used by the teacher. So having an emulator is not sufficient. If I were in India, and I wish I were, I'd much rather be having a workshop with people who have a calculator in their hand than watching me enjoying myself. Finally, just to remind you of the model on which my thinking is based, I hope you've seen examples of the concepts that are represented on the calculator, different ways of thinking about functions, about slope, about symmetry, about equations, about sequences, series, calculus, derivatives. All of the kind of things we deal with can be represented, but in a different way using tables. The calculations are being done by the calculator, and they're not what's important here. Calculators are not just important for calculating. It's the playing with ideas, the exploration, the investigating, which I've given you, I hope, a little bit of a flavor for here. And then, of course, several times I've stopped and checked and thought, what will happen next? What would happen if I do this? What do I expect to happen? That's how we learn things, by thinking about them and then seeing what happens with our thinking. So here are my conclusions. Firstly, tables offer lots of opportunities for students to learn mathematics, and I've shown you only some of them. That's not a surprise. These devices have been designed for learning. That's not the case for other sorts of technologies. This one is designed for learning. Computation is not the main idea. Representation, exploration, affirmation, those are important ideas. The calculator provides productive experience. It doesn't just give an answer. So thank you very much for your attendance. I'm sorry about the technical glitches along the way. I hope that you can still hear me. Okay, so I'll stop screen sharing now. And I think I've left time for questions, but I'll try and answer them if there are any. I haven't looked at the chat menu at all.
Thank you, Barry. There is one question. What is emulator? Is it different from calculator?
The emulator is the version of the calculator I've been using on the computer screen. The calculator itself looks like this. It fits in my pocket. It's a handheld device. The emulator is the version I was using to demonstrate with. An emulator is for demonstration, not for using.
A digital version of the physical quantity calculator.
Say again?
It is a digital version of the physical calculator.
Yes, yes. And it's designed, the teachers in Australia commonly don't use scientific calculators. They commonly use graphics calculators or computer algebra calculators. But almost all teachers doing that would have an emulator on the screen. So they can help students say, here's how you do this, or why don't you do this on your calculator and see what happens? And let's all do this and let's compare what we get and so on. So it's a kind of a classroom projection device. But yes, it's a digital version of the calculator.
Yeah. Any other questions from the audience? You can unmute and ask if you want to ask. 1 or 2 minutes more. Yeah, Ramanujam, would you like to ask something?
Yeah. Yeah, my question is about the generating functions and use of the sequences in series, these demonstrations that you had.
Yes, yes, yes.
They were really beautiful. Is there a way to discover formulas as well? I mean, I could see that with these progressions, students could be conjecturing and
indeed
verifying and so on. But I would like to hear your opinion.
Yes, the students can be conjecturing, but the calculator is a relatively unsophisticated device. It won't produce an output of symbolic representations. So the students can conjecture and then use their conjecture to test it out. So, for example, in the context of sequences and series, they might have a conjecture about how you find the sum of a certain number of terms of a sequence. And they could put that into the calculator and see if it seems to be matching what they get when they find the sum directly. But that's what they need to do. They need to conjecture and think, and they can use the calculator to check and test and what we call affirm. So the calculator is, I think, an enormously stimulating and productive environment to stimulate thinking, but it doesn't answer the students' questions. They have to do the thinking.
Yeah. Thank you.
Does that answer your question?
Yeah, very well. Thank you.
Okay.
Anybody else has a question to ask?
May I say something?
Janaki, yeah, please.
Yes.
Janaki.
Yes, Barry, thank you very much for that wonderful session. I think your talk really, this is more of a comment and an observation. So whatever you've shown, the whole gamut of, the concepts that you dealt with, it fits in very well with the school curriculum. So that's one big takeaway, I think. You also, in the literature, we all talk about and we try to implement the multiple representations, that is the graphical, numeric, symbolic, and so on. But I think with this tool, we understand that the tabular form or the numerical form is a very powerful form, which kind of tends to get neglected if you have a graphical representation along with it. So suppose, we are exploring functions, the first tendency is to get the graph and then start discussing it. Yes. And, you then later might look at the tabular representation. But with this device, I think, that's my thinking, I have always been calculators, especially graphics calculators, has been my favorite for a long time.
Yes, yes, mine too. Mine too.
Yeah, but now I've started seeing the strength of this representation. So I just wanted to ask, as a pedagogical question, that suppose a teacher is using this tool and is going through the concepts that you showed. Do you think that a graphical representation should be brought in at some point, or by the end of the numerical exploration, the students should be shown, or how do you think that should?
Yes, absolutely. I think the rule of three, the symbolic, numerical, and graphical, is a very good rule. And I said in the presentation at one point that you can think of an advanced scientific calculator as a graphics calculator when you're not allowed to use graphics. Many people with graphics calculators, as you said, Jonaki, neglect the tables. I think that's unfortunate. They have a rule of two, have the symbol and then they have the graph. So I think we shouldn't do that. And the same with the work with tables. Yes, of course, we would want to be drawing graphs. If not in our mind, and that's an important thing to do, by the way, sketching something in our mind, imagining how the sine function is changing between 0 and 90 degrees, for example, imagining how a linear function is changing, going up or going down, but actually doing it, sketching it on a piece of paper. The environment doesn't allow the technology to do it, but it's still very important to do. So yes, I completely agree that all three modalities are important. And what the scientific calculator provides is only two of them. So we have to provide the other one and encourage students to do what we probably routinely do ourselves. We look at something and we can see, when I said it's going up, I'm thinking about a graph. So yes, get some paper out and sketch the graph as well. So I think that's important to do. But it's a good reminder, I think, for those who have lucky enough to have their children have environments that are much richer and hence much more expensive, by the way, with a graphic calculator or a Desmos or a GeoGebra, that the numerical aspect is still very important. That's what makes sense of things. So let's not become just so focused on graphs that we don't think about other ways of thinking about things. So I totally agree.
Thank you. Thank you.
Are there any more questions, suggestions, comments? You can unmute and ask if you like. Well, Barry, once again, thank you.
It's a pleasure.
Yeah, a pleasure on our side also. I always say pleasure is always mutual. Otherwise, it is not pleasure.
Thank you very much. Thank you very much. And it's been a lovely conference. Thank you very much. And I should have said at the end, I meant to, Merry Christmas and a much happier New Year to everybody.
Yeah, same to you. Thank you very much.
Okay.
So if close the session for the time being and have a lunch break. We'll be meeting at
1:30.
1:30 again. And you can remain logged. I will play that movie which was being played in case you want to watch. That is movie called Flatland. Actually, it is available on YouTube. So I'm playing it from YouTube for you to see it. So we meet again at 1:30 for a hands-on on autograph, which is going to be also very nice and productive for us to learn how to involve students in your lectures, especially in the present times. So once again, thank you, Barry, and we'll meet again. Thank you. Bye.
You ready for your first sight recognition lesson?
I guess so.
What do you see when you look at me?
A square.
Is that what you really see? Go
A
on.
line.
Is that all? What do you see at the edges of the line? Look closer.
I see like shadings.
That's the ether, the fog. It dims the light the further away you are. It's everywhere, so to children and the uneducated, it's nowhere, invisible. That's why they have to feel their way around, touching people in order to figure out who or what they are.
Feelers are Sticksville.
That's right, that's right. Now, suppose two individuals are approaching. A triangle and a pentagon. Which is which? No touching. If that were a real triangle, you could hurt yourself on a sharp angle.
Why can't I just walk around it? That way I could see the shading easier.
That's not done in polite company. Sometimes when there are a lot of people, you can wiggle back and forth to triangulate, but you don't want to go all the way around someone. So you figure it out by staying right where you are.
But how do I do it?
Infer the shape. Through the shading. See?
Not bad, not bad. Is my brother in?
I can't do it! Am I stupid? I must be a feeler.
Sight recognition isn't easy, I know, but it'll come to you.
Your brother is here!
We'll continue the lesson in a moment.
Do we have to?
B square.
A square. What's this about representing a line?
I haven't taken her case yet. I'm meeting her this afternoon.
But she's a chromatist.
Accused. Like 5% of the population.
Of the male population. She's the first woman who's joined the...
Just because you work at the ministry, you can't go around accusing people without evidence.
Oh, there's plenty of evidence, big brother.
So another show trial.
Can't you talk any sense into your husband?
I might puncture some into him.
Don't forget your peace cry. You could be arrested. That's not funny. Don't encourage her, B.
Hey, Hexagon. How's my favorite nephew?
Okay, what are you talking about? Is it about chromatism? Is it? Chromatism is cool.
Where did he hear that?
Go to your room.
But my lesson.
In your room.
Oh, all right.
Can I get you anything, B?
Well, I can't stay. Big doings this afternoon. The president is going to meet with chromatistes.
A concession?
Just don't go out for a while. That's why I came by, to warn you.
But my client, I'm meeting her this afternoon. I never miss an appointment.
Listen to your brother for once.
Sometimes even lines give good advice, big brother. Attend to your configuration.
Attend to your configuration.
President Circle, sir, Where are you going?
Follow me. We'll talk as we head for the hospital.
Hospital of Reconfiguration?
Yes, the first line had a child last night. Something went wrong, an irregular side.
I'm so sorry, sir.
These things happen. The hospital has good doctors. In fact, I'm heading over now to see my son for the very first time. Completely reconfigured by now.
And your wife? Is she all right?
Yes, of course, in the recovery room. But she picked a terrible time for a pregnancy. The chromatists, Senator Chromatistes, the constant threat of war on the border. So, did you review my plan?
Yes, sir.
Problems?
No, sir.
Good. And the speech?
Brilliant, sir. Absolutely brilliant.
Good.
What's wrong with Hex? He doesn't seem interested in his lessons.
One of his older brothers told him that he was reconfigured!
What?
Hex was making fun of them, taunting them! Low class, low-sided. I think E-Pentagon just wanted to make him shut
Now,
up!
why did E go and do that?
Hex was being pretty nasty!
There's no shame in reconfiguration. It was a small genetic defect. We should make Hex proud that he's a hexagon, the first in the family.
Some humility would help to temper that pride. Go talk to him.
I will.
Find the physician.
Yes, sir, Mr. President. Right away.
So, B square. Is everything in place?
Yes, sir.
No doubt it's just year 3000 madness.
Color can't make us all equal. It's morally repugnant.
Mr. President?
One moment, Doctor.
Sir,
One moment. Affairs of state. The evil of it is so perfectly straightforward. There is good and evil, B. Why can't they see
I
it?
can't explain such blindness, sir.
Mr. President, sorry to interrupt, but I must inform you, your son,
Oh, no.
I'm sorry, he didn't survive the
Where is
procedure.
he? Where's my son? Son! Where is he? Where's my son?
Shall I?
Son! Son!
We did everything we could.
Son, where
His
is
body
he?
just couldn't take
Son!
the procedure. The deformity was too great.
Son! Son! How could you do this to him?
We did try.
No, of course. You're all good men.
Is there anything we can do for you,
He
sir?
didn't even have a name yet.
Sad day,
The
sir.
loss of a child.
I'm sorry, sir.
Like
Sad, sad.
the
Stop.
physicians for incompetence.
Please, gentlemen, one moment. We all have to be brave, make sacrifices for the greater good. Please, accept my apologies for my emotional outburst.
Totally
Ability
understand,
to show
sir.
emotion is a sign of strength and
Perhaps we should postpone our plan.
No, this country needs me, especially now. Grief is a luxury that a leader cannot afford in these times. We all must attend to our configuration.
Attend to your configuration.
Let's roll.
Okay, sorry about the delay. Your mother and I had something to talk about, and son, that is you, isn't it? My son Hex with a purple side?
out how
Remove
to
that
do it.
coloration at once.
Dad!
Son, society makes laws for a reason. You're old enough to know that that's
If I
against
was
the law.
a circle, I could change the law.
But you're not a circle.
Why can't I be more of a polygon? I could have been a heptagon if you'd been a pentagon. Why
Fewer
couldn't I
as
have
many
skipped
sided
aside
as
when
you,
I was
son.
born?
Fewer still are certified pre-circles. And I wouldn't be so impressed by them either. They aren't true circles.
They aren't?
No, of course not. Circles simply have lots and lots of sides. Some have 36, some have 72, 360. Now those are the ones that are the closest to the divine circularity that we all aspire to. But none of us will ever be able to achieve
Why
it.
do we have the ability to colorize if we can't use it?
Hex, what am I to do with you? Be satisfied with your configuration. It's crazy to want more. You are what you are.
Just leave me alone!
Noon News with Peter Pentagon.
Noon, I'm late.
We never finished my lesson. I'm gonna be a feeler forever.
You'll have to wait. I never miss an appointment.
The day. In other news, additional troops are being deployed to the northern border in a show of force.
Why don't we go seriously? Work in the bill. That's enough.
Where can I get me some good internet?
My votes are getting denied. No one else.
Can you direct me to the Great Hall?
I understand the dial
I'm going to have to change my vote one of these days.
Oh, get a load of that one. President Circle's arriving.
Attend your configuration.
We have the right to color!
We have the right to color.
Attend to your chromatization.
Attend your chromatization.
Attend to your chromatization. Attend to your chromatization.
Attend
to your chromatization. Attend to your
Attend your configuration. 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 Attend your configuration.
Watch it, buddy.
I'm not a chromatist. Can't you see that?
What are you in for?
I want to see my lawyer. I'm innocent.
I want to speak to someone in charge. Report to the colonel.
Careful. She's a chromatist and a female.
Accused chromatist.
Yeah, that's what they'll all say. She ain't no accused female. She's very sharp and can kill you in a second. Watch yourself. If she gets out of line, be down the hall.
Miss Line? Miss Line, I'm your court-appointed attorney. I'm required by law to tell you that I'm not obligated to take your case. Is that understood? Now, you must answer me if I'm to remain.
I understand!
Good. Now, do you wish to confess
Confess?
your affiliation with the Chromatic Sedition?
My what? Is that what they said?
Yeah.
Do I look like a chromatist?
But the arrest warrant states that you were picked up as a
I
chromatist.
was arrested for failing to use my peace cry.
What, is that all?
Yes!
Well, I'm afraid the charge just can't be changed.
So why are you here? I know why I'm here, but why are you? When you came in, I was dreaming about, I can't explain it. There are no words. A not here. An else. A something else. Elsewhere. It wasn't here. It wasn't our world. In my dream, I thought, so this isn't all there is. I know. Crazy. What else is there but here? This flatland.
What did you say?
Oh, nothing.
Why do you call the world flatland?
I don't know. Because it's flat?
I don't see your point. I mean, the world is a plane. Of course it's flat.
I know. But in my dream...
Dreams aren't admissible in court. I don't see any angle I can take that could possibly change your sentence.
Which will be?
Do you want to hear what the judge will say? His exact words?
Yes!
Angles of sharpness will pierce and slice and segment your person until you are dead. Oh, I didn't mean, I'm sorry. Is there anyone? A husband? Children?
No, I'm alone. Who am I? What am I? Counselor, what are we here for?
To prepare your defense.
Maybe I'm nothing, or will be soon. So hey, why not simply do it for them now?
Do what for them?
My execution!
Because that's against the law? Oh, wait a minute! No, wait! Guards! Stop! Wait, stop! Please, wait a minute! Guards! You're not going to find her. She didn't escape.
You don't mean she... But you're her attorney. How could you let her do that?
And how was I supposed to stop her? I told her it was illegal.
What's going on here? Where's the prisoner?
She ate herself, sir.
What?
It's true. I was in the cell with her discussing her defense when she...
You couldn't stop her?
I don't know, what was I supposed to do? She was a line. She could have killed me. There was nothing I could do.
Nothing? All attorneys should be sliced into little pieces and fed to the irregulars. Oh, I've seen a lot of things. I've rounded the Cape and watched the burning of Glenawson. I've seen compatriots split in two by the thousands, and I've killed just as many of the enemy in my time. But in all my years, I have never seen such a sniveling coward as you. Get out of my sight!
Come on, man. I'll show you out.
I'm going to inform the Bar Association about this.
He didn't mean what he said.
Yes, he did. And he's right.
This is a bad time. Big things in the Senate today. I'd get home as soon as possible if I were you. All the CDF units in the city are mobilizing.
Mobilizing?
That's all I can say.
Citizens, this is a crucial moment in world history. Conflict looms between our republic and our northern neighbors. Even now, the engines of war are building at the border. I understand the need for reunification. For too long, families have been torn apart by the political divide. For too long, we've watched our poor brothers across the border crushed by the tyranny of the northern monarch. Citizens, has it been so long since we've cast away the cruelty of kings that we've forgotten how precious freedom is? The Northern Kingdom preaches equality, but practices chromatism. They allow irregular children to avoid reconfiguration. Some years ago, we followed suit and allowed reconfiguration to become optional. And what happened, friends? We blurred the line of freedom, perhaps forever.
Interesting trinkets, aren't they?
I can't take my eye off them. What are they?
I don't really know.
What is the purpose of the glowing?
No clue.
Are they alive?
No. Maybe. No.
What are they made of?
Rocks, minerals, crystals, something. Don't know, really.
Where are they from?
A distant territory in the Northern Kingdom.
The North? But you can't sell those here, can you? That's illegal.
Well, they change the law every other day. I can't keep up. You won't turn me in, will you?
Well, I'm an attorney. That makes me an officer of the court.
I guess that entitles you to a little discount.
What do you call them?
Glow points.
Do they do anything except glow like that?
That depends.
On what?
On your mood. Here, hold one. Careful, they're delicate. And be careful what they touch. They can go dead in a heartbeat.
All right, how much?
Oh, they ain't cheap. Tough to get all the way through the border, you know, especially in these times.
Of course, of course.
Senator Chromatistes does have his points. Of course, reunification under our own terms is desirable. But under chromatistic terms, a thief could color himself to resemble a priest. A rapist could color himself to resemble an attorney. Under chromatism, the whole science of sight recognition perishes. Citizens, how are we to protect our daughters and wives under the senator's scheme?
Let me through. Let me
Wherever
through.
possible, our priest circles seek equality for everyone. That's why we have the hospital of reconfiguration. Yes, we lose some children, but in every case, the parent knows the risk. What is civilization based on if not regularity and equality of angles? It is nothing. Do any of us seriously believe that there is no connection between geometrical and moral irregularity? Citizens, there is good and evil.
Let me through. Let me through.
Civilization as we know it would end. We would relapse into barbarism.
Me through. You can't go on repressing the lesser-sided forever. Color is equality. We can find a third way. Let us consider compromise with the Northern Kingdom.
Citizens, look what happened when we relaxed our standards and allowed our elected officials to include citizens of any shape. We now have an irregular as a senator who introduces this
Hello,
color
I am
bill
Stephanie
to our
Korn,
body.
an
A
instructional
bill
tech
that, if
specialist at
voted
East High
into
School.
law, would
And
allow
I'm
our
joining you today
citizens to
from
color
my Zoom
themselves as
meeting.
they see
We're
fit.
going to look at how to use Jamboard, a Google Whiteboard digital instructional tool within Zoom. So it's a great backup if the whiteboard in Zoom is not working.
The Northern Kingdom
You
will
can
see
use
this
it a
as
couple of
weakness
ways.
and
The
enslave
first
us
way you can
all.
use it is just as an instructional tool. Maybe you have a math problem you want to show the students how to use. This would be a great way to do it. So I have opened up
Senator,
Jamboard.
you don't know that. You are hoping that. I am not willing to gamble away our very survival on your hopes. You've already put the future of the Republic at stake. At any moment, the North might attack, and it's your fault.
Oh, stop. No. Ooh, that's Mars. Oh, goodness. Oh, no. Oh, God. No. Oh, wait a minute. No. Don't put that there. Ouch. Oh, no. Hey, now, I'm warning you. I'm peaceful, but no. Oh, no. No. Oh, my goodness.
He interrupted my speech.
We can fix the record, sir.
The bloodshed, the death. Are we doing the right thing? How will history remember me? As the man who saved the Republic, or a butcher who destroyed innocence? Can I
Don't
sleep
falter
tonight?
now, sir. Great figures in history never falter.
I don't want to be a great figure. I want to be a good person.
Mr. A Square, go
I
home.
dropped my glue point. I gotta go back and get it.
Go home and lock
Wait,
your
I dropped my-
doors.
Do you know the way out of here, brother?
Can't you see there's a riot going on out there?
Do you know the way out of here? Out of this world?
Out of this... You old fool, there is no out of here.
We'll see. We'll see.
Gods preserve his angularity in death. Gods preserve his angularity in death. And children! He was more than a soldier. He may not have been a big, important man, but he was worth something. He was practically my brother!
I was so worried that you said those horrible chromatists had started a riot.
Yeah, I was caught up in it.
Are you hurt?
No, geez, I'm just exhausted.
What happened?
It's the end of the world. The blood and death and murder, everyone killing everyone.
What are we to do?
Oh, not much to do. We keep the door locked and we'll stay inside.
I'm frightened.
Well, perhaps a new day will bring a new world. Hello? Hello there? Can you hear me? Hello? Hello there? What's going on here? Where am I? What's all this monotonous chirping, you little line?
Little?
Monotonous?
I'm King of Lineland, monarch of the world.
What are you, puny-voiced intrusion?
I'm A Square.
A what?
Square.
A what?
A Square.
A squire.
Don't talk gibberish to me.
Let's just say I'm a voice.
You are not one of Lineland's voices.
I would recognize you.
Let me hear your bass voice.
My what?
Your other voice.
I don't have any other voice.
Then you're a woman?
No! No! I'm a man.
I thought you said you were a queer.
I'm a visitor. Let's say from another world.
There's no world beside Lineland.
Oh, you're wrong about that.
Is that so?
Prove it. And address me as your majesty.
But, Your Majesty, you can't actually see lines.
Impossible.
Although,
In death, yes.
some of us believe we will experience this mystic awareness of a straight line in an afterlife.
Ah, yes, of course. I must be from that world. The world of your afterlife, where you shall join me in the absoluteness of two-dimensionality.
Nonsense.
Well, I see to the left of you two lines, a point, a line, a point, a line, and 2 points. Is that correct?
What do you mean by left?
I mean to your base end. And to the right are 2 points, a line, a point, a line, a point, and 2 lines. Now, how did I know that if I couldn't see them?
Tell me the length of the 999th mail to my backwards.
I can't see that far.
Ha!
3 inches. By the same means, my shape can be exactly ascertained.
Behold me.
I am a line, the longest in Lineland, over 6 inches of space.
Space of length, don't you mean?
Idiot. Space is length.
Don't interrupt me again.
Oh, forgive me, Your Majesty.
Hear now, with your own ears, how by means of my 2 voices I reveal my shape to my wives. who are at this moment over 6,000 miles away. One forward, one backward. Listen, and I will sing.
Why don't you just feel your neighbors?
What?
Explain yourself.
Feel, touch, come into contact with.
That offense is punishable by death.
Really? Why is that?
And what purpose would be served by touching?
When there is sound.
But isn't life in line land just a little dull? I mean, to see nothing but points. Not even be able to see a line.
Mindless man, aren't you?
Mindless? Sounds like your music is mindless. I can tell with the glance how many people are to your right and to your left. And there's nothing easier than a glance.
What is this left and right?
And how could you see the line? The inside of anything?
Left, right? You must mean backward and forward.
No, not so.
Exhibit these directions to me.
I can't. I mean, unless you step out of your line altogether.
Out of my line?
Out of the world?
Out of space?
Well, yes. Out of your world and into the greater plane of 2 dimensions where all is plane and you can move in 4 directions.
If you can't show this or describe this to me,
then go away.
Hasn't it occurred to you that you could move in some other direction, towards which your side is facing?
What?
Never.
What do you mean by side?
There is before and behind.
Nothing more.
Fine. Let me show you. Here, I'm going to move into your world. Here I come. There. Can you see me now?
Yes.
But
you're only a point.
Well, to you, I'm only a point, but in fact, I moved into line land. Now, I'm going to continue to move, and from your perspective, I'm going to vanish. What did your majesty say now?
Charlatan!
Tricks! Tricks!
Come back!
How did you do that?
I moved out of line land. Convinced?
If you had any sense, the smallest particle of...
You ask me to believe that there's another world? You say there's another motion besides forward and backward.
But when I ask you to show it, all you can do is babble and practice magic tricks.
You must be a madman or dimensionally deficient.
You 6-inch idiot! You think you're the perfection of existence, but in reality, you're the most imperfect. You say you know the world, but all you see is a point. You can't even see lines. Well, I can. In fact, I am a line of lines, a square. In my world, as superior as I am to you, in my world, I'm nothing compared to the greatest of polygons.
Enough!
I'll pierce you through.
Die, evil creature! Die, evil creature!
Go play in your rooms. No, in the house today.
What for? It's New Year's Eve.
The city's not safe, okay? Inside today. And mind your angles and points. Yesterday?
Yes?
She killed herself.
Your brother warned you.
Good morning, Inda.
Good morning, Douglas. I was waiting for you.
Good. It's 8 o'clock in the morning here, and it's still dark.
Oh, yeah. You're up 8 o'clock.
That's okay. I've been up earlier than this for engine things.
Yeah.
You're 5.5 hours ahead, aren't you? Excuse me.
That's right.
All right, let's do that.
It's dark by 4 o'clock in the evening, I think, right?
Hey, oh, yes, it is. Yes, we're right in the middle of winter now.
Yeah. Has it started snowing? Not yet.
Oh, no. Sometimes it does. Just depends. When the wind blows from the Arctic. But it's not doing that at the moment. Right, so I can reduce that. I think we're nearly there, aren't we? That one. So how many delegates have we got doing this workshop, do you think?
Till now, morning we had around 35.
That's good.
And now it's 14. Hope they're not sleeping and because it's after lunch, people may tend to have a small snooze.
Good idea.
Okay. Would you like to connect and see your screen?
Let's do that.
Great.
Now, can I assume that everybody who was here this morning was at my talk yesterday?
Would you like to ask?
Well, I could do, couldn't I? Otherwise, I'll just quickly run through the same things by way of a summary. Which
I think it doesn't matter.
Yeah, it doesn't matter, does it?
Yeah. Shall we begin or you want to wait for some time more? I think we can begin and then you can spend 5 minutes, 10 minutes on recollecting and
That's a good idea. And then we'll have a break at 9 o'clock or whatever time it is for you.
No, whenever you feel like having a break in between, tell me.
Yes, I think so. I think 2 hours is too long. We'll have an hour and then a break and then finish off.
Yeah, we're starting at 1:30. So around 2:30, you would like to have a break?
I think so, yes.
Oh, okay, fine. How long? 10 minutes?
Yeah, there's plenty, yes, just to get a cup of tea.
Oh, yeah, sure.
Tea was grown in India, of course.
Pardon?
I said the tea was grown in India.
Yeah, that's right. So we are starting.
Yeah, let's do that.
Let me welcome you all back to the first afternoon session, which is going to be on the software called Autograph. So this is a 2-hour workshop, and most likely Douglas will take us along and handhold us, and you will learn about the autograph. So Douglas, over to you.
Inda, thank you, and good. I'm saying good morning to everybody because it's 8 o'clock in the morning here in England. It's still dark, but the sun will start shining soon with any luck.
Yeah.
Good. I'm really looking forward to this opportunity of sharing Autograph to you. What's happened since I was last physically in India is that Autograph has become a free download. That makes obviously a huge difference. It's a wonderful program. It is in its fullest form on a PC only for the time being, but during today's workshop, I will also introduce you to the growing web version. It's coming along, and you can see you can do an awful lot to it, but there's still lots to do. But I will show you that too. Just by way of a summary, I'll just run through some of the slides from yesterday's talk. This is where I live now at Cirencester, which is a beautiful old Roman town. And it's between Bristol and Oxford. Now, to get ready for excuse me, this workshop today, that's the address. So if you want to just scribble down completemaths.com/autograph, or just go into a web browser and put in web autograph. That's to show that that works. Okay, here's Chrome and Google search. It's come on the other computer. Just pushing WEB autograph. And it gets you straight there. So we will need both versions today. So this is the web version as it is at the moment. So if you click on this, you go straight in, which is good. Whereas if you click on this one, this is the old way of doing things, as I'm sure you're familiar. You have to download and install, but it is free. And if you click on download for free, and we definitely want you to do this, so I'm going to leave time now for you to do this. You have to put in your, no, you haven't got a username and password, I doubt, at this stage. So you haven't got an account, so down you go. You have to declare whether you're a student or a teacher. If you're a network administrator, you'll get the software in a different form for putting on the network. You click on one of those and then fill in the details after it. Make up a password that you won't forget. And off you go. And you should, in about a couple of minutes, be looking at autograph in this form. So I'll just pause. Now, the only way today is going to work is if you use chat. I will keep an eye on the chat because it's not a presentation, it's a workshop. So if you've got any questions, please scribble away in the chat and then I will be able to answer them straight away. That's the best way to communicate with me while I'm sharing my screen. While you're doing that, I'll just run through the slides from yesterday's meeting in case that's of interest. I think it's important you realize where autograph fits into the spectrum of dynamic software. And the ones that people are talking about a lot are GeoGebra and Desmos. And soon, I hope autograph will be tripping off their tongue in the same frame. But also the Geometry Sketchpad is still going, and that is a lovely program, as is Cabri. So that's the complete set. Those are the three that most people seem to talk about at the moment. The way GeoGebra is sorted out is you've got these 6 different applications, one of which is GeoGebra Classic. And GeoGebra Classic is the one that contains all aspects of GeoGebra in its previous incarnation. What they want you to do is to concentrate on these different apps, which is fine. Resources, there are over 1 million free resources for GeoGebra on the web. My worry is that I don't know how many of those have been moderated. There's another big difference between GeoGebra and Autograph is that people tend to use Autograph from scratch. In other words, you start with a blank screen and you build up your objects. And there's a lot of learning that can go on as you build them up. Well, whereas a lot of people tend to use pre-made GeoGebra files and then just use those. Desmos is the new kid on the block, and it's only been around for a few years. But again, it splits into different packages to do different things. The resources are very well organized for students and teachers. The way Autograph is structured, it's at the top here, you have these different page types. You've got statistics one, that's a single variable statistics, 2 variable stats, and all 2D stuff in here, all the way from vectors to differential equations. You name it, volume to revolution, and complex numbers page. We've also got the split between standard level and advanced level. Standard level has no radians, no calculus, and you can see there's an obvious need for that for students who aren't quite ready to see options like radians in the menus. And the resources, I like to show these because I'm very pleased with them. Over the years, we had a lot of workshops at Oundle near Cambridge, technology, secondary, mathematics. So tsm-resources.com looks like this. Now, these are all links to individual short videos of how to use Autograph. So Helen's problem, circle theorems, velocity time, domain range, and so on. Those are the standard level problems, and these are the advanced level videos. We've also got a lot of Autograph files if you like to do that. This is a good way of learning, certainly. So this is all the Autograph stuff. You've got the manuals and other documentation down here. And over here, you've got links to integer lists. And these are, first of all, lists of prime numbers, lists of powers of 2. Very important when you're plotting 2 to the x, just to make you realize what 2 to the x actually looks like. These numbers get very large very quickly. Mersenne primes are always fun to talk about, and here they all are. And Pythagorean triples, likewise. Lots of mathematics tied up in those. Lots of images. And all these are images that you can see around the world, and I've put them all together, either parabolic or circular. No end of data. The web is heaving with data. So there it all is. These are actually Excel files. These are websites that include information about statistics. These are teaching sites for problem stats. These are tutorials on Excel. Excel, of course, is a seriously useful tool for mathematics. And that's mainly UK-based stuff. Lots of math links here, lots of entertainment links here, and there we go. So that's the resources taken care of, and here they are. And yesterday I showed I won't do it now because there isn't time, but the difference between working out the area between 2 functions using GeoGebra, using Desmos, and using Autograph. GeoGebra has the problem that it has the logic is that you have to choose your operation first, then go and find objects to apply it to, which means that the entire canon of possibilities have to be on view somehow. And the way GeoGebra does it is through a thing called a command line, where you have hundreds and hundreds of options. So you have to know what the word is, and you have to know how to spell it. So it's not my favorite interface, but it does make for a very powerful program. Desmos has a similar problem, but in that you have to know what certain codes are. You have to put in the word int if you want to do an integral. Sort of okay. I can understand the logic behind that, but it's not obvious. Autograph will be doing in due course. Now, I need to be sort of happy with the fact that you're definitely there and not gone to sleep or anything like that. There's nothing in the chat yet. So if you've managed to download Autograph and have it running, if you could just say, hello, I'm running, or something like that in the chat, it would make me feel a lot better. Oh, somebody says yes for Inda. Excellent. Well, that's one. What you should have is that.
Yes, Richa says yes.
Risha says yes, good. I think I have to give it another couple of minutes just to be sure, because I think people might be having trouble.
Yeah, probably. In case you're having trouble, look at that website you have forgotten from where to download, please ask. We'll show the link again.
Yes, I certainly can.
Or you can put in the chat box the link.
Yes, just search for search for web autograph. And there it is.
Strongly recommended that you download and go along what Douglas is telling us. That will be more interesting.
Oh, definitely, yes. Otherwise, you just sit and watch me do it. That's not the idea at all. And when it's me sharing a screen, I can't see everybody.
Does anybody, does one has to sign up or anything, or without sign up one can use it?
No, you have to sign up, but that's very quick. You click on Autograph Complete Maths and click on this one to do Autograph 5. Download for free. Haven't got that yet. So get an account, say you're a teacher, put in your email, make up a password that you won't forget. And off you go.
Yeah, the bottom details one needs to be filled or not?
Yes, you have to put your name and last name and the country. It just, they're giving away a major program, and I think it's fair enough. They should have the information. But they don't use it in any other way. It's just the way it goes.
Right. So if you have done that, please say yes. Those who have done it, please say yes, so that we feel confident that you are along with us. Five. Is it downloadable on a mobile? I think the web version should be okay.
No, the Autograph 5 is only for Windows PCs.
What about web? That is okay.
The web Autograph is for anything, yes, for a phone or tablet or.
Yeah.
I was going to do this one first and then concentrate on the web version in the second half.
Now, because most of the people may be using mobile for the conference, so they may not have a laptop or a desktop.
Okay. Maybe we'll switch to the web version then for now. There's plenty there to get going with. So let's do that. That means This is the one you're going to be looking at. Go to web autograph. Yes, you can only use this one if you have a PC laptop with you. Okay, Amita says cannot download. So Amita, I suggest you go back to this page and do the web autograph. So we will not do the autograph 5 in this workshop. We'll do the web autograph instead. Then we know that everybody can use it.
Okay, thank you so much, sir.
Yeah.
Yeah, Rebecca, you're quite right. Just click on this and it should launch it straight away. So much easier than having to download and install. But I see one or two of you have done a download, which is great.
Yes. Now you can start something.
I think so. I think so. So we go to the web autograph. And so how many people do you think we have tuned in?
Well, there's no idea as such, but
right.
Yeah.
Of course, because the screen's being shared. Yeah. Okay. Everybody, if you listen carefully, if you can use the chat to say, stop, I don't understand, or please do that again, that's the way you can communicate with me. Because when I'm screen sharing, I can't see your faces or anything. I'm just talking to a screen. Now, this is the web version of Autograph. You have the standard axes here. It is equal aspect by default. These are the modes. That's the point mode, for example. So you can put points anywhere. This is for intersections, but there's nothing to intersect at the moment. This is to scribble. This is to rub out. This is to shunt the whole thing around. This is to zoom. Now you either zoom by clicking or you zoom by making a little one of those. That zooms out. And it's quite likely you're now in a complete mess because you don't know what's where. So I'll just let you play with these buttons for a minute or two. And then we'll start doing something useful.
I think there is a do and undo at the top also, which is useful.
Oh, yes, there is. Here it is. Here's undo.
On the left side, probably, right?
Yep. It's going to be quite useful for you to sign in because you can then share your files and save them in a community environment. Now, if you have done a login for Autograph 5, that will work. Otherwise, you'll have to set up your own sign up. It's very quick, literally just email and password. Ah, I've remembered it. Yippee. So what I've done so far is played around with some of these things. This is the point mode. And as soon as you have a point, notice that all new points are all selected. If you want to go to the select mode and click nowhere, they all become deselected. You can drag points around And as soon as a point gets selected, on this side is the information about that object. So this particular point has an x of 4.8, yes, that's about right, and a y of 1.6. Yeah. Anytime you like, you see the folder here, you can have a new page. That just starts it all again. So if I put a single point on here at 1, 2, now what can I do over here with my single point on at 1, 2? To get this page here, remember I went to this option here, to a new page, and then in the point mode, I put a point at 1, 2. That's not quite there. I'm going to use the arrow keys to correct it. Now what am I doing? I'm pressing the right arrow, 2, 3, 4, 5, 6, 7, 8, 9, and it's going in tenths. If I press the up and down arrows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, goes in tenths. And over here, it tells me what the coordinates are. But we've got, this is all applying to, it's called a point A. We're not showing the label at the moment because the label, which is this one, is turned off. But if we turn it on, you can see that this point is called A. What does this do? That deletes the point. So if you do anything you don't want to, just press undo and it comes back magically. If you want to hide the point, this is the one to do that with, and it's gone. If you want to hide the label as well, it's all still there. Now, animation I could do with the arrow keys, but I could also do it down here, where you've got X, 1, and Y is 2. I can animate 1 by moving it to the right. Or I can change Y, the Y value, let it go up and down. I can change the step. Or I can turn this into a slider. That's this one here. And drag it from -3 to +3. If you want to change the start and finish, you go to the cog. The range at the moment is -3 to +3. You can change that. The step you can change, or you can make it a list of numbers like what these. And the animation can either go up and down, or it can loop, or you can just do it once. If you do loop and set it off, you can see what it's doing. It's going up to the top and then down to the bottom again. So that's your first exercise, to put a point on. Just make sure you understand what all these buttons do. That hides it. That puts the label on and off. That deletes it. Here you can manually change the values of X and Y, or you can animate it down here, either as a slider or individual values. Okay, let's put on a second point. Let's move that one down to here. Let's put on another point here. Now remember, the select mode is good because it means you just select things or deselect things. So if you click nowhere, nothing is selected. And when you select, they stay selected until you deselect. So I'm going to select these two in this order. And I want to draw a hexagon on this. So what do? Add objects. Add a shape. A regular polygon of side 6. So how did I do that? I selected this one, then this one, and then added a shape with regular polygon. So it's selected in a clockwise manner. That followed by that creates an object like this. Go to the mode and pull it down.
I have a question here.
Yeah, of course, yes.
Supposing I have only 2 points on the canvas,
Mm-hmm.
and I select make a triangle out of them.
You can't make a triangle out of 2 points, but you can.
But it makes it.
Well, it'll think about it. Oh, yes, it will. It'll make a regular polygon out of it.
Yeah, regular polygon with 2 sides is possible. Yes. Yeah.
Yes.
Fine. I was wondering how is the 3rd point taken?
Well, it's an equilateral triangle.
Yeah, right. Equilateral. Yeah, fine. Thank you.
Good. Now, the lovely thing about this is that these points are active as well. So if I deselect now, just by clicking nowhere, I can select this one and this one and put on a square. So shape, regular polygon, 4 sides will give you a square. Aha. So I'll just undo that, do it again, deselect, select, select. Now, Krithika, I'm just wondering why it is coming on top, right side of the line, but not downside. There has to be a convention. It's got to do one or the other, hasn't it? You're expecting it to go this way, are you? The convention that Autograph has gone for is that the 2 points you select creates a clockwise object. So if I want to put a square on here, I do this one, then this one, add shape, regular polygon, 4 sides, done. What I'm interested in now is what polygon will fit into here. So I'm now going to be clever. I don't like to be too clever, but I'd like to be a little bit clever. So I'm going to select these 2 and put on a shape, a regular polygon with an unknown number of sides. Now, when you put constants into Autograph, they're always 1 to start with. So by pressing N and done, nothing will happen because it can't draw a polygon with just more than 1 side. So Down here, we can animate n. N, of course, we don't want the step to be 0.1, we want the step to be 1. And this is the one that will animate it. So you go 2. Now 3 should suddenly spring into action. Ready, steady, boo! There we go. 4, 5, 6, 7. Have you all managed to guess what size the polygon, regular polygon, is going to have to be to fit this object? 10, 11, 12-sided polygon, dodecahedron. So how did I do that? Do lots of those. Oh, another one as well. Right, end's completely gone from here. So I click nowhere, make sure you're in select mode. Click, click. I want to create a polygon coming out this way. Add, shape, regular polygon, sides n. N will be 1, so nothing will happen. But if we make the step 1 and increase n to 2, to 3, to 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'll just pause there for a minute, give you a chance to get that picture up on your screens. Pentagon, of course, is just 5 sides.
Douglas, I was
yes.
Probably at this stage before inserting 12 gon or whatever it is, if we ask the students to measure the angle between the pentagon and the square.
Good idea. Let's do that. So I'm going to select that just by clicking on it. Okay. And then I press the delete key, which is on our keyboard. Gone. Yes, this angle, that would be a really good exercise, wouldn't it?
Yes.
So let's do that. So click, click, click. Again, it's in a clockwise manner because I want the angle to come in here. Plus, now if it's not what you find here, it might be in the create menu. And it is, angle measure. We probably don't want more than 1 dp. 0 dp is enough. I'm not sure. We're going to find out in a minute whether we're in degrees or radians. Okay, ready, steady, go. Hooray, we're in degrees. Yeah. I'll show you how to change that.
Yeah, now at this stage, probably one should ask students if it is an interactive class or something.
Yeah, absolutely.
With this angle, what is the regular, what should be the size of the polygon?
Exactly, yes.
And then construct that polygon and see if it fits.
Yep. That's a really nice exercise. So to construct the polygon, again, click on nowhere, always click nowhere to clear the selection. Click, click, add, shape, polygon. If you've worked it out, it's 12, fine. Otherwise, put n and go through the way of doing it that way. Done. Animate n down here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Good morning, Sangeeta.
Good morning, Douglas. Good morning. Such a pleasure to attend your workshop once again. Thank you.
It's like old times, isn't it? And you've discovered Mathagon. That's really exciting, isn't it?
Yeah, I'm enjoying it. Thank you.
Where does Mathagon come from?
It's a US team that is building it up.
Right.
Mm-hmm.
Well, I think are you in touch with them? Because they ought to be very pleased with your work.
Not really, or only on Twitter. So that's the connect. Yes.
Yeah. Very good. I'm trying to think how many years ago it was I did a workshop at your school.
Yes, it's been quite a while now.
Yeah, it has, certainly.
Yeah.
Still, here we are. We're doing this despite the pandemic. And that's good.
I think web autograph looks much less threatening. It's easier to follow.
I hope so. I hope so, especially now that it's free. And this version will evolve. It doesn't, the real thing it doesn't do yet, it doesn't do any stats. It doesn't do differential equations, doesn't have attributes, which is a great shame because attributes are fabulous. But it'll all come, it's just a question of the programmer being given the time to finish it off.
Yes.
Now, let me just take you through, I think, sorry, private conversation with Sangeeta. But never mind, it's a huge pleasure. Now, let's have a look at these buttons up here, see what we've got. If you have an object selected, this will change its appearance. So if you didn't want it to be green or anything else, or this also reminds you of the number of sides. But if you go to style, here we are, you've got all these different colors you can make it. Oh, that's for the boundary, that's the line color. The solid is green at the moment, but it needn't be. You can have a gradient, all sorts of things to play around with. The thickness of the outline, to make it thicker or thinner, or not at all. That green bit is just the selection. So if you deselect, it's gone. So if you want to have one without a border, that's the way that's done. So just select an object and play around with the paint pot. And that's the style and all these options down here. Now, there's one more thing that you can do with a selected object. Here's the object selected. You can add a text box. And until we've got a calculator and attributes, it just decides to give you one object, one attribute, which I think is area. So you can put some text before it, area equals. You can put some text box afterwards if you want to. If you want to do meter squared or something like that. I don't think it's got access to a squared at the moment, so that's no good, is it? There's the preview down there, and that's done. You can move it around. You can do that. So the on-screen keyboard that some of you might be familiar with the regular autograph hasn't been implemented yet. The trouble with working on the web is there's no right click. I mean, if you do a right click now, you do get something, but it's nothing to do with autograph. And so that's why all the objects, all the possibilities have to be listed either in here or one of these objects, buttons. Now, let's get you all signed in because I think I'd like to make this into a GIF. So make sure you have done that. So if you're not, if I'm going to sign out now, and if I sign in, you haven't got an email and password. So you sign up, student, teacher, put your email in and think of a password you're not going to forget. If you've already done this for autograph 5, then use those. And so it wants all this again, I'm afraid, but that's not too bad. It's bearable. Once you've done this, that's you done forever. So I'm going to sign in. Oh, there we are. That's me. So this file I can now share. And because it's on the web, this is a web address which I can copy just by pressing that button there. So if I go to a web page, which is nothing to do with autograph, here it is. Paste, enter. There we are, out of nowhere, it's just a web link. So that's important, I think, to be able to share the page. In the old days, of course, you saved an autograph file and then had to send it as an email attachment. Now you just send the address. Now I'm going to create a GIF file. And as soon as I set it to record, I'm going to make the animation happen by playing around with the value here of the number of sides. Okay. Let's just start at the bottom then. Ready, steady, record. 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 frames. Processing. There is your GIF file. And there's the address of that GIF file, which you can copy and use as part of a Twitter or whatever you want to do. So let's give you a couple of minutes to play around with these. Once you've signed in, that's important, you must be able to sign in. You can then save in these forms. You can share it by sharing an address, which will create this page, or you can make an animated GIF.
Barry, at this stage, one would like to know whether I can save it as a JPG or PNG.
Oh, you just want the image to be saved, don't you?
Yes, because I may like to include it in a worksheet or something.
Yes. I mean, I use, there's so many free things around the place that will do this for you. What do I use? I got it here. So I'm on the other computer now. TechSmith Capture is a free one.
Yeah, but that is has to go out of autograph, right?
Well, not very far. I mean, here it is. It's a free application, and you just do whatever you like to do. I think I hear what you say. That would be quite nice if there was something built into autograph.
Right. You can export it as a
yes.
the
here
canvas.
it is now. Here's a canvas, which you can do whatever you like to.
Yeah, that's right. What was the software you said, the free one for others to know?
Yes.
TechSmith?
TechSmith, they're the people who do Camtasia. Whenever I do tutorials, Camtasia is a fabulous piece of work for that.
Yeah,
you have. It's the same company.
Is the old version which is free, or?
Yeah, that isn't free, but TechSmith do a free version of Capture, which is very good. So
Okay.
I'll put it into chat. Well, TechSmith Capture app. Download for Windows. I wonder if it's Windows only. I can't believe it is. Anyway, Capture, there it is. And it's quite good because you can do clever things with it, like scribble on it and so on. So you've got an arrow you can put on as a call out. You can put some text in there. You can put a shape on there. Well, you've got a shape there already. You can do that. You can highlight. You can undo and redo. So quite a useful little tool. Capture image preview. And it's a freebie. It's another application that wants you to sign up, I'm afraid. It's the way the web's moving. They want to know all about you. If they're giving it away for free, you can't grumble, really. So I've got some more topics here I'd like to explore. So we'll finish with that. Not using that. And we want this back. This is our file, isn't it? Oh, that's interesting. I've just noticed that the zoom in and out happens with the wheel on the mouse. If you've got a mouse, that is. If you're using a tablet, you probably haven't. Otherwise, zooming in and out is done through these. Remember, the zoom in is either a click or you make a little region. Now, what I haven't done for you yet is what to do if you get in a muddle and you literally lose the plot. That's my only joke today, but you're very welcome to laugh at it if you wish. So here, what do we do with this? We're stuck. So let me introduce you now to this button here, which is very, very useful. This is sorting out the axes, the spanner. And the most important one is the tick. If you're familiar with the regular autograph, it's a red tick, but here it's blue. Click on that and it will just sort everything out. So at the moment, the x-axis goes from -6 to 6, the y goes from -4 to 4, and the ranges are automatic. Equal aspect mode is pretty important for a lot of things, and you can see that it just needed a small adjustment there. Options, lots of options. You can change the labels. If you don't want to be called X and Y, you can call it by feet and inches, or velocity and time. This is changing the variable. So if you do have x as t along here and v up here, we haven't done entering equations yet, but I'll come back to that in a second. Otherwise, what you might have, the horizontal might be time brackets seconds, and the vertical axis might be velocity in meters per second. Options, lots of options here. Snap settings, that's really useful. The snap settings at the moment are 0.1. If you change the snap settings to 1 for x and y, I'll see what happens. Let's put a point on. And you can see that what we've done, we've labeled the axes velocity and time. And if I go to select mode, it's snapping to integers. Look, you see, it's only going to whole numbers. Very, very useful occasionally. These are all local things. If you open up a new page, it will all go back to the defaults. Time for a new page. And I'd like to have a look at the topic of the area of a triangle, keeping things nice and simple to start with. So let's put a point here. In fact, let's go to Spanner, Options, Snap Settings, 1, 1. Let's just see how that works. So here's my point. Select mode. I can drag it around. So I'll just pause there for a minute, give you all a chance to put a point on here and to set the snap to 1. Options, snap settings, 1 and 1. Okay, let's put on another point, and let's have a point here. And let's have a point at the top. I'm going to select those 3 and make a shape. There we have a triangle. What did I do there? I selected 1, 2, 3, add, shape, go for it. Don't need 2 shapes, I'll just undo that. If I select the shape and add a text box, it should give me the area. So let's do area space equals space. Space equals space. Done. Half the base times the height, that's correct. Now the fundamental way that autograph works, I think, in the classroom is to say, I'm going to move that top point to the right. What's going to happen? This is where dynamic software comes in. Has the area changed? No. What happens if it goes even further? Ooh, it's still 6. It really is determined to be 6. That's the start of a nice discussion. Quite nice to be able to just run it back to the start and then forward again. So it's a nice little controller you've got here. Now, I promise you a short break just to get a glass of water or a cup of tea. So I think to earn your cup of tea, I think we'll have a new page and we'll have a new graph, because I haven't put a graph in yet. Add equation. Y equals 2 to the power of x. I've got caps lock on somehow. It's not supposed to be like that. Let's do that again. Y. It looks awfully like a capital Y, doesn't it? You definitely want slow plot mode. Now you have to click it twice. I'm not quite sure why, but you just do. That's slow plot mode now. And I really am puzzled by this. I may not like this at all. Oh no, it's okay, it's working. Now you can pause anytime. But again, you have to click twice. So it's one of those things that needs sorting out, I think. But so let's do that again from scratch. New page. Add equation y equals 2 to the power of x. 2 clicks to get slow plot on. But once it's going, it's controlled from over here. So off we go. Done. Pause. And these 2 clicks to stop it. Because there's lots you can do with the pen at this stage. What is 2 to the minus 1? A half. Ooh, let's put a half in here. What is 2 to the power of 0? 1. What is 2 to the power of 1? 2. What is 2 to the power of 2? 4. So you can have all this discussion while it's sitting there pausing. And off we go. Boom, boom, fantastic. Now I need a select mode to deselect that. And actually, I should have just left it selected. I'm sure it's okay, because I want to do the gradient function of 2 to the x. Gradient function. We're on slow plot, that's good. Don't want symbolic. First gradient of that. Startup options. Okay, I think we're all set. Ready, steady, go. Now what's it doing? It's drawing a tangent on the parent graph, working out the gradient and doing a dotted line. So that is clearly well, you can tell the lesson we're about to embark on let's first of all get rid of these little bits of scribblings. You can just select them like that. Whoops, not that one, but that. That's obviously going to be tricky to select.
So can you please tell the gradient function once again?
Yes.
Sorry to interrupt.
No, please do interrupt. That's the whole point of this.
Thank you.
I'm going to undo all of this. Back to there. So now all we've got is 2 to the power of x. Okay, you need to select it so it knows which one to do. And plus gradient function. Now, if it's not there, it may be you've got to just deselect it and select it again. I don't know why. That's, again, you've got to understand this is young software. So occasionally there's little things that go a bit wrong. There it is, it's selected.
Thank you.
Plus gradient function, slow plot on, definitely slow plot.
Yes, got it. Thank you.
Okay, so what do you think we're going to do next? Well, what you want to do, of course, is change 2. Okay, so this one here, if you click on it and click over here, you can actually change it. So how do I do that? Just check that. I'm selecting the curve. As soon as you select the curve, its details are over here. Okay, I want to, instead of having 2, I want to have a constant a. Now, if a is 1, which it will be, it's not very exciting. So let's move a back to where it was using the animate down here. 2. So let's just pause there, give you a chance. Indra, I think we'll push on actually. I don't want to have a break now. I think we'll lose the momentum.
Yeah, it's okay, Barry. Sorry, Douglas, it's okay. You don't need to have a break now. Whenever,
no, I think I'll push on because
yeah,
if you want to rush out and get a cup of tea, do that.
No, it's okay. I'm just saying for you also, because you are speaking most of the time.
That's all right.
Breather. Actually, I was going to suggest an exercise on the triangle so that people think and you have a breather.
Oh, right. Okay.
See the basic that area of the square.
Yes.
Sorry, area of the triangle.
Mm.
When you moved it, it remained between the parallel line, right?
Yes, that's right. Because I set the snap to 6 to
yes.
1.
So it was area was not changing. So that is geometry there that they should recollect. Students should recollect that.
Oh yes, absolutely.
Right. That is one. And secondly, if you make it a right angle triangle, then corollary 2 is that area is same as a right angle triangle.
Oh, of course, yes. Why not?
Right. And that right angle triangle can be made a rectangle.
Yes.
By congruent kind of triangle putting on the diagonal.
That's right. So many things to think about, aren't there?
And then from the area formula comes is the half of the rectangle and then half base into height the area.
Yes. Comes. Yeah. Yeah. All those possibilities.
Yeah. So that
think along the right lines, Ender. Well done.
Yeah.
That's excellent.
I thought some such thing you can give it. Others may think of some other ways of using that same thing. So we'll know how different teachers think of creating and.
Yes, absolutely.
So
now the one thing they haven't done yet is to be able to pop back and have a look at that file. Because I didn't save it, and you haven't got a tab system along the top here. There's that one, which happens to be still there, but not the one with the triangle.
No, it's okay. Some other future
yeah, absolutely.
Yeah, some such.
Now, at the moment, what I've done here, you see, it was 2 to the x. I've just changed the 2 to an a. And I think I ought to just show that again so you can see. At the moment, it's 2 to the x. Make sure you're in select mode, deselect everything, and select the graph. When you select the graph, over here, and you click on it, you get all its information. Now it's 2 to the x at the moment, but I want it to be a to the x. I'm going to delete that 2. A to the x isn't very interesting when a is 1. So down here, you can animate, because we've introduced a constant, you can animate now, and let's make that step 1, make it up to 2. So we're now back to exactly where we were before, except instead of being 2 to the x, it's a to the x with a equal to 2. Does that make sense? Hope so.
So in your slider, you will be taking a positive always?
Oh, yes. But actually, this method I think is better than a slider, and I'll show you in a second. I'm going to change 2 now. I want 2 to be bigger than 2, and that's a bit dramatic. I'm going to go up in 0.1s. Are you ready? 2.1. Now, what's going to happen if it's 2.1? Well, let's just think about this for a second. That's going to go up a bit, isn't it? This is going to stay where it is. This, if it's 2.1 to the power of x, and x is -1, that's going to go down. So that's going up, that's staying where it is, that's going down. So let's see what happens. Ready, steady, go. Yes. Look at the gradient function. It's getting closer and closer. Ooh. Ooh. Job done. Have we discovered a new constant, which I'm going to call E, which is 2.7? Correct? Guess what we're going to do now? Zoom. Best thing on the planet is zooming. So one thing that just makes dynamic software so special. You cannot do this with a chalkboard. Here we go. Now, what are we expecting? If we zoom in on a curve, will it still be curvy? Answer, no. It'll be more and more straight. Local straightness is a very important concept. And here it is. And however much you think it's 2.7, you can always split them up. And this is where a slider bar really is no good whatsoever. Unfortunately, GeoGebra and Desmoth only have sliders. So you cannot do this sort of thing in either of those programs. Now I'm going to reduce the step and increase this. Reduce the step and decrease this. Time for another zoom. It's already there. Zoom, zoom, zoom. This process, of course, will go on forever. 2.718, haha. Let's reduce the step. Let's come back a bit. Reduce the step, go up a bit. 2.71828, not bad. I think I'm happy with that. E, of course, does not equal 2.71828. That's well on its way. Just say if you'd like me to run that through from the start again. If I undo, we should be able to take it back to where we were. There's our point. Now, of course, 2 to the x increases very fast. And it's just the same as it was when I was showing you the TSM resources page. Integer lists, powers of 2. Here they all are. You've only got to get up to 20 and it's already in the over the million. And if you have a look at 2 to the power of 222, it's just huge. So the doubling process is very powerful indeed. You notice, of course, in things like Who Wants to Be a Millionaire, and doubling process there is very powerful.
Douglas?
Yes.
It may be a good idea at this stage, you are taking the function x to the power a, right?
Yes.
How about we also side by side have a to the power x? No, sorry, x to the power a.
Oh, the inverse function.
No.
You could have a log function there. That would be quite nice.
No, not the log function. I'm just looking at the power function.
Oh, right.
So it is, your function is a raised to power x, right? What is the function you have?
Yeah, a to the power of x.
Right. So there is the exponential function you're taking, right?
Yes, so it's e to the x, really.
Yeah. So now I want other way around. Instead of a to the x, right?
Mm-hmm.
X to the a.
Oh,
right.
Let's have a look.
That will be interesting for students' point of view. How do the two compare?
So you want x equals a to the y.
No. The function is y equal to x to the power a. For a, you can have a a slider.
Yes. And it would be. Are you talking about the same a as this one?
Whichever you want.
Yeah.
So, you can have a same a, or that will be nice to compare what the two. See, one is a power function, other is the exponential function.
Yes, right.
Confuse between the two.
Yeah, I can see that. Huh. What happens up here? Yes, they merge, don't they?
No, one of them takes over actually. If you
is that right?
Zoom.
Oh, there we go.
they will, after a long time, they will one take over the other.
How interesting. That's x to the power of a. That's a to the power of x. Ha! Oh, thank you, Linda. That's very interesting.
Yeah. And now if we change a, you can see what happens, kind of, the two. If you have a array, how do the two change, kind of.
I think we set it quite a challenge. It's working very slowly. We probably don't want the gradient function. That's not helping. Yes, interesting.
please go ahead. I just interviewed.
Yeah, that's nice. Let's do some more calculus, because I think calculus is a great topic for this environment. Let's have a look at the area function. So we'll have a look at I'm going to add an equation, y equals x, it's x cubed, minus 3x minus 1, my favorite cubic that I've mentioned many times. Why is it my favorite? Let's just check. So y equals x cubed minus 3x minus 1. Pause it too late. What we should have done, of course, is talked about it. X cubed, when x is negative, say -3, -3 cubed is minus huge down here. When x is 0, it goes through 1, so it goes through there. And when x is large and positive, it's definitely up here. So you can see what it's all about. And it is a very well-behaved cubic because the maximum is at -1. The point of inflection is at 0, and the minimum is at +1. So lots of nice, tidy values. Now, the intersect, I'll just pause for a minute, give you a chance to draw this picture in. Y equals x cubed minus 3x minus 1, and it's my favorite cubic. Now the intersect, now we've got lots of intersections. Let's see what points can be achieved from this. When you're in intersect mode, you're looking for little circles. As soon as you get a little circle, it says, I know what that is, boom. It tells you where the maximum is, tells you where that is, tells you where that is, that one, and that one. Those are all available. Just be in the habit of going back to select mode all the time. So now let's have a look at the area function and see if we can find the area from here to here. So we literally do that because these 2 points belong to that curve. I think that's all we need to do, but I might have to create find area. So it's a bit hidden. That I'll just show you where that is. It's plus create find area. That's interesting. Angle measure seems to have crept in there. What's that doing? That's just switching between. Oh, that's actually, I see. It's working out an angle different. Anyway, find area, okay. Now, here are all the rules. If you're teaching numerical methods, you can do rectangles, midpoint theorem, trapezium rule, or Simpson's rule. And you can show the option to show the centroid if you wish. But for now, I think we'll just do the general one. And there it is. Select it, plus text box area equals. Come on. On there. Never mind, doesn't matter. And a nice little pull out. What about the area from here to here? Will that be positive or negative? So I think it'd be quite useful, rather than having all these points on here, to just put a couple of random points on. So let's put a couple of random points on, one here and one here, close to each other, so we can talk about an element of area. Quite an important concept. So select, deselect, select, select, plus create find area, and we could have the rectangle. That should be quite a nice way of showing what's going on here. So you can see what's going on here. Ah, I see, there's lots of them. So what we should have done is just have one of those. Which I think is done over here. Yes, we've got 5 divisions at the moment. How did I get that? I just selected that and clicked on area, and down here comes all the bits and bobs. So if I make that just 1, and then move this up, that is an element of area. You can see we could have done the area the other way around. Rectangle to the right. We've got the 2 ways of doing it. Squeezing rule, of course, just does that. Simpson's rule does that. But for now, I'm just looking at an element of area and seeing what happens as we move it around. And let's select that and add text box. Now, something's going on here. That's really strange. I don't know what. Anyway, it doesn't matter about that. That's a little glitch that's crept in this morning. These things happen. And so that area at the moment is negative. Well, of course it's negative because that goes all the way from here to here. And it will always be negative until such time as it goes on this side. Let's move this point along. And move this point along to here. It's now a positive area, so we'll just select that and delete that. Now, what happens if it's sort of half positive and half negative? Well, let's just click on this now and have a few more. Okay, so we can see what's going on. Right, the area is still negative. But there comes a time when the area is about 0. So you've got to be careful when you're working out areas when you cross the x-axis. It's up here, no question about it, it's all positive. Notice I'm just pushing on, even though there's clearly a glitch here, goodness knows what it is. But if things go wrong with software, as they can do in the middle of a lesson, just forget it and go and do something else. You don't want to spoil the flow if you try and fix something. Then the one I did yesterday, those of you who were there, was the area between 2 functions. So let's just have a new page. And let's add y equals 4 minus x squared. There's something wrong with my keyboard, I think. It's producing capital letters and goodness knows why. Luckily, Autograph is sorting it out. So done, that's going to be 4 minus x squared, like that. All agreed? Yep. Then I think it's quite a good exercise to get the students to think of I want a parabola that's the other way up and intersects these at funny places. Okay, so after some discussion, you add another equation, and it's y equals x into. Now, notice there's something that Autograph doesn't do that the other two do. As you're typing an equation, y equals x, it draws y equals x, and I think it's a distraction. I don't think you should draw it until you're finished. Y equals x into. Now we want it to be this way up, so we want the coefficient of x squared to be positive. So we want to be x, something x minus 3, that'll do the job nicely. That'll go through here and intersect in wild places, so that's good. Fantastic. Now the way to get the area between these 2 functions is, first of all, to put a point here and a point just a bit further out, just to make the point about how it actually works, how it is possible to get an area that is positive, even though a lot of it's negative. Now, what you do to do an area between, very simply, select, deselect, select these 2 points, select the top function and select the bottom function, plus create, find area, all the usual choices, done. Now, how is it possible that this creates a positive area? Let's select that text box, and we've got the usual problem. Yeah, it doesn't like it. Anyway, it doesn't matter. There's some of the problem there, but at least it's getting the answer. That's what I want. So the area is 1.383, and it's positive. Now, how is it? Well, how come it's not nearly zero? Because this is negative and this is positive. The answer is quite straightforward. This area is from here to here. Now, from here to here is positive, okay? But we're doing the difference between this and this. And the difference between this and this being negative makes it positive. So that minus minus makes that plus. So the area between the two is actually the sum of these two areas. And that, therefore, you can take all the way around to there. So the next thing to do is to intersect mode, one there and one there. Perfect. Select, deselect, select, select the upper and the lower. Which is just the same way that GeoGebra does it. It's just that you have to produce this rather strange command line expression, which is horrible. Anyway, off we go. Plus, create, find area, general, done. So let's spend a couple of minutes, see if you can recreate this picture here. I've created area equals in another application and copied it. That's how that works. There we go. Now these text boxes, of course, you can format them how you wish. Select it and go to the paint pot. There's the text before, style, color, border, and so on.
Douglas?
Yes.
I have a question on this area below the curve.
Yes.
I want to, the function, does the autograph handle absolute value?
Of course.
Okay, so let us try to find out the area between -1 to 1. Not of this thing, something else actually.
Okay.
If you want, no, I don't know whether you have finished your exploration, then it is okay.
Yeah, I think so. Yes, let's just push on.
Yeah, let us do one more problem on the area. So the function is fx equal to mod of 2x minus 1.
So x equals, did you say, or y equals?
Y equal to absolute value, 2x minus 1. X, 2 times x.
There it is.
Okay. So I want to find the area below the graph of whatever it is, -1 to 1.
Is that what you expected?
Yeah. So now why I'm doing this is because normally when I have tried this in calculus class.
Oh yeah.
So when you do it from -1 to 1 of absolute value 2x minus 1, they normally forget the absolute value.
Oh, I see.
they take it -1 to 1 of without the absolute value. And that answer comes out, I think that comes out negative. If you forget the absolute value.
Oh, it would do, yes, because it's going down here.
So I think that maybe one is a good way of showing using graphs that the area
Yeah, definitely
is a signed area that you're looking at actually.
Yes. The absolute value symbol is between the shift key and the Z key. And it's a shift character. It just depends what keyboard you've got.
Please carry on.
Yep, okay, let's push on. Let's look at some elementary geometry, circle theorems. They work out very nicely in this environment. So new page. Now, what you can do, if you open up the spanner, options, no axes or grid, because if you're going to do some geometry, the actual numerical values are irrelevant if you're doing circle theorems. So we're talking about Euclidean geometry, so no axis or grid is quite a good option to have. So where was that? So it was in the spanner, options, full axis or grid, no axis or grid. It's nice to have one click to do that. So you can have a radius of r. So you can then drag it out to whatever size you want. Oh, r is 1. So we're over here now, and we want the circle to be a bit bigger. There we are. So how did I do that? Spanner, options, no axis or grid, point mode, stick a point in the middle somewhere, add a circle of radius r. point about that being that R now comes down here in the animate area, so I can increase R whatever size I like. Values are irrelevant because we're about to do the angle at the center is twice the angle at the circumference, and therefore numbers are irrelevant. So I'm going to put a point here, put a point here, put a point here. Now at the moment, the dynamic creation of line segments hasn't gone in yet. So it will go in typically next week, I believe. So you have to do it the laborious way, which is select 2 points and then line segment, deselect, select, select, add, line segment, deselect, select, select, add, line segment, deselect, select, select, add, line segment. So it's a bit of a pain. Next week, you should be able to grab one of these icons here and just do line, 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 which of course is what you can do in the regular version. That's the diagram we need for this bit of work. So I'll just pause for a second now and give you a chance to create that. So each of these lines were select, select, add, line, line segment. Okay, now we want some angles. So once again, you select 3 points, 1, 2, 3, in such a way that the angle is created in a clockwise manner. Add, create, angle measure. Now, I don't think we want 1 dp, we want it to be exact. So there we go. That'll do. 91. So as we move this around, so it changes. Perfect. And what about this angle here? This one, and this one. Add, create, angle measure, 0 dp, done. Now that indeed is half of that. Now if you're going to do a proof of this, you have to put a line from here to here and look at the isosceles triangles and so on. Obviously something quite special happens when this angle is 180. Ooh. Now it's jumping from one side to the other because one of the options when you create an angle I've got to get back to that, is to allow reflex. Here we are, yes. So how did I get that? I selected the angle that I want to change. And over here, I selected angle as well, and it's angle 1. If I do allow reflex, it will allow that to go beyond 180. Doesn't quite know which way to turn when it is actually 180. But of course, what you also get when it is 180 is this one is 90. and it's always 90. What about this side? Ooh, 90. Lots to discover and lots to explore. So let's bring this one back to something like 100. So that's 50. Now, what happens if we pull this around here? It's the angle in the same segment. It's always the same. What happens if it goes beyond here? Well, the angle here is going to be a half of this angle. So 260 is that one, plus 100 is 360. 260 divided by 2 is 130. Can you illustrate this thing with some other point than center? I'm not sure. I don't know what you mean. It is the angle at the center that's twice the angle at the circumference, is it not? You can work out all these angles, of course. So forgive me for not quite understanding what the question is. Can you illustrate this thing with some other point than the center? Because that is the center of the circle, that's the trouble. Inda, can you help me out here? I'm not quite sure what the question means. Inda's gone off to have a cup of tea, I think. Lots of other problems you can deal with here, of course. For example, if you select this point here and ask for a line, a tangent, you can draw a tangent to that circle. And if you select these two, add line segment. If we've got a point along here and select this point and this point and this point, select them all, but that one, that one, that one, add, create, angle, no dp, done. Ah, that angle is the same as that one. That, of course, is the alternate segment theorem. Again, the proof is trivial, but it's nice to do it with right angles and so on. That's 40, so there we are. What happens if you move this around? Yes, you get that. So it's always the case. This, of course, is the angle of the same segment, so that's always the same. So the simple geometry, which is pretty well done in the, certainly in GeoGebra, the geometry is excellent because all the geometry tools are just sitting there. You don't have to do the command line. Okay, let's move on to some other topics. The quadratic, yeah, that's a good one. So we have a new page. Or just to remind you how to save that. Once you've signed in, which I hope you have, go to this one and you can save the file to the ecosystem. So let's do that. Just call that circle theorems. Save it to the ecosystem, all right? And it's called circle theorem. If you want to open a file from the ecosystem, there it is. There's all the clock things we were doing yesterday, quadratic and so on. We'll do it in a minute. Here's our program, circle theorem. So that's the way to save those. These are just private to you. If you want someone else to do them, then you use the other system, which is sharing. So we go back to let's close that, to here, and share the file just by sending that by email to somebody, and there is the file. Again, if you want to create a GIF, here we have it. Quite a few frames being down there, and close it, processing. And again, if you want to have that GIF elsewhere, just copy that link and away you go. So, new page.
Douglas?
Yes.
Web version, does it have 3D or not?
Not yet. No, it will. It will.
Oh,
be
okay.
patient. Be patient. But AutoGraph 5.
Can we just move to the desktop version and probably see some 3D?
Oh yeah, absolutely.
That will be good because a lot of people find difficult in.
Yes.
3D
the two sort of big things that work really nicely in AutoGraph 5, which is the complex numbers, which I do know is part of your courses. And just quickly to be able to do some things that I did in the talk yesterday, but very briefly, if you put a point here, that is a complex number which has 2 real and 1 complex, 1 imaginary. And you put another point up here. And if you select the 2 in either order, here are all the complex arithmetic problems. You can add them together and they behave just like vectors. That vector, that complex number is Z1 plus Z2. And there's the negative vector. All the things you do with vectors, you can do with this. But of course, complex numbers have good old Demar's theorem built in. So for example, if you want to select this one and raise it to the power of 2, you're going to be squaring the length, which is 4, but you're doubling the angle, so it's going to be down here. That is the AutoGraph way. You must take that on board if you possibly can. Don't just press buttons and say, oh, look. You've got to think about what it's going to do when you do press the button. And sure enough, it ends up down here, which is correct. And the nth roots are the other thing that I showed very quickly yesterday. Just got room to put 8 on there. Put a point at 8. And put the nth root. If you put the square root, no, let's do the cube root of 8. Because the cube root of 8 is 2. Yes, okay, but 8 can also be here, in which case it's 120. Or it can be, again, 720, in which case it's 240. That's why you get 3 results.
Yeah, but Douglas, there is still 2D going on.
Yes, yes.
I just want, for example, let us have a look at a cone and sections of the cone.
May I interfere, sir?
Yes.
Actually, this is there is no equation for 3D lines, and there is no
wait.
Complex number for 3D.
Chanchal Das, wait.
Yep, certainly can. Here's a couple of points.
No, it's okay. Let him. I want a cone to be. Can we enter the equation of a cone?
Yes, you certainly can.
Yeah.
The best one is R equals Z. It's nice and clear.
My idea is to have conic sections being displayed to students.
Oh, yes.
By section by a plane, intersection of a plane and a.
if you do this, it looks like a straight line in 2D, but of course it's a plane in 3D.
Yeah. So this is how beautifully the conic sections are coming up.
Oh, it's lovely. Yes.
Yes. They are not able to visualize normally.
If you increase A line of this plane here, that's what it looks like in 2D. You make it steeper, you're going to get the hyperbolas.
Hyperbolas, right.
Yeah.
And you make it more horizontal, then you'll get.
And if you make it less steep, that's a parabola. And round you go, and it's now an ellipse.
Yes, ellipse and circles.
And then finally the circle. Yeah. Now you can have a look at this. If you hold down Control and drag, ooh, you can go inside and take a real close look.
Oh, that's great.
Boom. Out the other side.
Yeah, I think it's about time to take some questions if there are any.
Oh, absolutely, yes. I mean, it's been a pleasure, but I've just been looking at a screen and I'd quite like to look at you, see who's there.
Yeah, I think if you would like Douglas to show some particular thing which you find it difficult for students to show, I think he'll be happy to do it for you if he can do it in quickly.
Yeah, I think so. Things like the shortest distance between two lines. Now, if you select those and ask for a point, the shortest distance, one thing is quite interesting is if you put a second point here, you can create a vector in the direction of that line. Right click, vector, vector 2 points. There it goes. I'm a bit worried about view preferences, starting arrows in the middle. I think it's easier to see the vectors. That's better. And I'm going to put another point here. And right click, vector 2 points. Okay, now this is lovely because if you teach the cross product, then this and this point here, and ask for the cross product, you'll see that it is exactly in the mutually perpendicular direction of those two lines.
Yeah, that's quite nice.
Which is lovely, because it's an exercise you do academically, and then it's just nice to be able to see what's going on.
Anybody else has a question to ask? Please ask, because we have 5 minutes.
Yeah.
Sir, I have a question.
Yeah, please.
So similarly, we can show the intersection between line and plane, and also the angle between line and plane.
Certainly can. Let's put a plane in. 2x minus 3y minus z equals 1, something like that. Now the vector 2 minus 3, 1 minus 1 is perpendicular to that plane. There is the plane. If we put a point at the origin, now it's a bit tricky because of the way I've done it. If I select that point and put in the vector 2 minus 3 minus 1, 2 minus 3 minus 1, it will be a vector that is perpendicular to that plane. There it goes.
Richa, is that what you are asking for?
Sir, I was asking actually the intersection of a line and a plane and the angle between them.
Okay, no problem. Let's put a point here. and the point there, and create a line. Select that. Select the line, select the plane, right click, point, intersection. So the way autograph works, because it's the other way around to GeoGebra, if we're used to GeoGebra, it just got another thinking cap to put on. You basically choose the objects that you want to operate on and then the operation. So intersection, and there it is. And you want the angle between the plane, I think, is that, and right click. Been a while since I've puzzled this one out. I'm not sure.
Yeah, that will depend upon, see, angle requires two lines.
Does rather, doesn't it? Yes.
Yeah, so one line is given. Where is the other line? If you
let's do the closest point. Here we go. Now we've got an angle. So we want to go clockwise, that one, and that one, and right click, create. And don't tell me it's not been done. Oh dear, I'll have to look this one up.
There is no unique answer for the angle between a line and a plane, right?
Yeah, that's true.
Yeah, so the question is not very meaningful.
Okay, anyway, that's the closest point, which is pretty good.
So one possibility you're looking at is probably you look at the projection of that. There is no well-defined angle between a line and a plane, I think. What do you think, Sangeeta, as a teacher?
We talk about it more like angle between the line and the normal to the plane.
Normal to the plane.
That is okay. That is okay.
I think that's what Richa is trying to.
Yeah. Actually, that only my purpose is because when we have some such questions also. So we find out angle between line and plane.
Right.
Yeah.
The normal to the plane.
Normal.
Yeah. That's okay because angle requires two lines.
Correct.
Yes. So it is in terms of the normal, and then we take the 90 minus theta.
Yeah, that is.
So we get sine theta basically.
Sine theta.
Calculation.
Yes.
Yeah.
That is what is taken in physics as the angle of incidence, if that is a ray entering the plane.
Very good.
Yeah.
So that's the kind of visualization. So I know we had seen this earlier in autograph. You can use the normal and then find the angle between.
Yeah.
That's okay. That one can find. Yeah.
Good.
Yeah. So Douglas, I think.
Thank you.
Yeah, great. Thank you so much, Douglas.
Yeah.
Well, there we are. You've got a new tool. You've got Autograph 5 anyway, if you've got PCs, but this will work on anything.
Yeah.
Which is fantastic. So watch this space. It will get better and better as the guy spends more and more time. Luckily, the firm that bought Autograph also took on the programmer, Mark Hatzel, who's a total genius. And so if you've got any thoughts about what it should do, because it doesn't at the moment, do feel free to email me and we can take it on from there.
So
Wondering what the best
thanks
place
a lot
to share my email address.
Share your whatever data you would like to share, please.
Yes, I can't remember. I'll put it in my in here. Yeah, DE Butler at argonet.co.uk. It's been that for a long time, and there it is.
Fine, that's great. So thanks a lot for giving the lecture yesterday and the workshop today. And let me say that he himself said he would like to do the workshop. I was very happy to accept offer. So Douglas, thank you very much for.
Thank you, everybody. I will stop the share so we can hear lots of people. That's nice.
Yeah. Okay.
I will just show that here I am. Okay, everybody.
Yeah, I think can everybody? Hi. Can
it's Barry again. Goodness me.
Hi, Douglas.
We keep bumping into each other.
We do.
Can,
we do.
can everybody turn on their video so that we can take a snapshot?
Oh, yeah, that'd be good.
That will be good. Please turn on your video, everybody, so that we can take a photograph. We're
What
not.
time is it for you, Barry?
Yeah, we're not
It's
done
just
anything.
after 6
Now you
p.m.
know how to click.
Oh, goodness, an ordinary time.
I don't know how to click. Does Sangeeta, you know how to click the photograph? Snapshot? Does somebody know how to take a snapshot of all the gallery?
The videos are not all showing yet.
Yeah, we'll just take one.
Yeah, and then share it. That's okay. Please turn on your video so that we can take a snapshot. That will also tell us whether you're sleeping or not.
Yeah, well, won't it?
Yes, if you don't turn it on, that means you're sleeping.
Sir, I don't have camera in on my
I
laptop.
think my video is off. My video is off.
We can't help it, sir. It's your video.
You can't start your video because the host has stopped it. Host has stopped it.
Okay, let me unmute you because there was a problem.
I don't think video is stopped.
Video cannot be stopped. You can be muted.
Video can't be stopped.
All
right, I'm taking some screenshots and I'll share with you, sir.
Yeah.
Right, great to have everybody here.
Yes.
Okay. There we are. I've taken one, if that helps.
Yes. Something for the record's sake, saying that we were there and not only our names.
Video is still off.
I have
people on the second page of the video. There must be asleep.
Yes, second page, we don't have too many people on.
Chanchal Das, I have not muted your video. I cannot do that. I can only mute your mic.
But it is showing your you cannot start your video because the host has stopped it.
Well, I don't know because I can't see it. Well, let me see if I can, because your name also doesn't turn up. So I'm wondering what is happening.
HP, I think that is mine.
Okay. What do you want me to do with HP?
The video should be on.
Yeah, I didn't stop the video. That's what I'm telling you, please.
Okay.
I didn't stop it.
Yeah, the host can't control the video settings, sir, so don't worry.
Yeah, I can. No, it may be showing, but I have muted only once because you are in between the session. There was a disturbance, so I muted everybody. Yeah.
Right.
Okay. So thank you all. And we come back after the break. The paper presentations after the break, and then let me see what is the program. I have forgotten.
Barry, are you on WhatsApp?
Yes, Douglas, I am.
Pardon?
So am I. We'll have a chat.
Yeah. Okay. Right.
Okay, everybody. Well, thank you for attending.
Yeah. Yeah.
Thank you, sir. Thank
you. And do take care.
I've got a picture of you all, which is great.
Yeah.
So I'll send it by email to Inda.
Yeah, please. In case you are still online for the concluding function, that will be nice.
Absolutely.
Yeah. Thank you.
Good. Thank you, everybody.
Thank you, sir.
Thanks, Douglas.
I know your number, don't I, Barry?
I'll message it to you.
Yeah, good idea. Then we can chat.
Got it?
I have. And that's a mobile, isn't it?
Yeah.
It has to be for that to work. Good. Well, since it's an ordinary time of day for you, I'll give you a call.
Wonderful. I look forward to that.
Okay. All right. Bye for now.
Bye.
Cheers.
Hello, sir. I can't hear you.
Yeah, nice to see you, and
yes,
a long time.
Yeah. This has been a very nice conference.
Well, it's a modest thing which is going on and keeping me occupied and others occupied. So it's good.
I think I saw a lot of energy at least all these workshops that we have been having. People are very engaged. So I think that's very good.
Yeah, that's nice. Yeah, that's right. So you will be chairing the session for a paper presentation?
Yeah. So there are 5 presentations.
Okay.
And we have 2 hours. So we'll give about 15 minutes or 10 minutes of questions. 15 minutes of presentation plus 5 minutes of questions. So 20 minutes each.
Okay.
Yeah. And I think some buffer time.
You decide whichever way you want to decide, and just check before the session starts that all those who are listed are present. So,
yes.
Hi, Richa.
Hi.
Nice to see somebody coming from Dehradun and wearing all sweaters and everything. Yes.
Yeah.
So how cold it is, Richa, there? Your mic is
around 15 or 16 degree in the afternoon.
Afternoon, okay. Night goes below 0 or around 0?
No, not yet.
Okay.
So around 5 or 6.
Okay, fine. That bad yet.
Yeah.
It has not started snowing nearby, no? No, not yet.
No, not yet.
But normally Missouri gets a snowfall, right?
Yes, Missouri gets, and we are just in the foothill of Missouri.
Yeah, I know that. I had that place for about 6 months. I was there in near between Saharanpur and Dehradun.
Okay.
Yeah. So I know what the things look like.
Yeah. So we are at Unison, and it is just nearby Missouri on the way to Missouri.
More near Missouri.
Yeah. So that's why this place is colder as compared to the plains.
Yeah, but the views are fantastic of the hills and all that when it is clear.
Yeah.
When there is no fog, on a sunny day, beautiful scenes you see.
Yes, it's all around hilly area here.
Yeah.
And it's sunny also in the afternoon, but yes.
Good.
Chilly.
So we have around how much? 3:45. About
2 more minutes.
2-3 minutes more to start.
Yeah. Sir, I just looked at the list. We have 7 presentations. So I think about 12 minutes of presentation.
Shanta was saying 5. I don't know.
7. There are 7.
7. I made a mistake. 7.
No, I understood what you had in mind of those 5, but it's okay. Yeah, fine. I thought actually there were 8. So I thought 2 hours will be good enough for 8.
I think it's perfect, sir. It's perfect. Yeah.
Okay. I'm taking a short break. I'm just freshen up and come back.
Sure. Richa, I'll do the introductions.
You can start at 2:45.
3:45. There's exactly 1 more minute.
Yeah, so you can start and then no problem.
Yeah, sure. Yeah.
Yes, ma'am. You can start with the introduction.
Yeah, and I'll announce the time limit for the presentations.
Sure.
And please add in whenever necessary.
Yeah.
We'll follow the order that is there in the website. We'll follow the same.
We'll follow the same. Yeah.
Ma'am, can you once share the order here, please?
Which order?
Order of the ma'am.
It's on the website. I will read it in any case. Richa, were you able to send it?
I'll just read that.
I was trying.
I can see in the website where it is scheduled.
Last day.
Yeah, third day, and there is a schedule. So name of the presenters, if you allow me, I'll just read it.
Yeah.
Yeah,
I'm
so-
trying to see if we can send it on chat.
Okay. Yeah, I have opened in my mobile. So first is Chanchal Das. Second, then next is Vivek Vijay, Sandeep Kumar Yadav, and Vivek Sahu.
Oh yeah, I've sent it.
Yeah, you have sent it.
Yeah.
So 10 to 12 minutes per presenter, ma'am?
Yes. So shall we start? It's 3:46.
Yeah, it's 3:46. Good to go.
Good afternoon, everyone. My name is Shanta Bhushan, and I would like to welcome you all to this session of paper presentations. It's very heartening to note the amount of effort that has gone into writing these papers and the research that has gone in. And I'm sure it will be valuable for all of us who are here. We are really looking forward to the presentations. The list of presenters is put up on the website, and I have pasted it also on the chat. Since we have 2 hours, we thought you could present, each one of you could present for 12 minutes and keep maybe 5 to 6 minutes for questions. We will finish by 5:45. I would like to now request Sri Chanchal Das to make his presentation on the T puzzle. Welcome, sir, and you have 12 minutes for the presentation and a few minutes for question answer. Thank you.
Okay, thank you, madam, for the introduction. And can I share my screen?
Not the host, I think. Yeah.
So, good afternoon to all. And myself, Chanchal Das. I will be presenting solving T puzzle mathematically. But this is an international conference on technology and innovation in mathematics teaching. So my focus will be on not exactly solving the puzzle, how this technique can be helpful in teaching mathematics. That from that perspective, I have written this paper, and from this perspective, I will be explaining here. So this is about myself, something whatever I have done, what I am doing, and my activities here I listed below. What I am skipping it, I am not going in details on that. But this is our presentation. Ours is a startup company. We are not from any institution. We have started our startup company to bring a radical change in the way we teach mathematics. And one of the objective means around which our work circles is this. Means at present, anybody we ask about mathematics, they think about it is full of lot of equations, a lot of symbols, and lot of formulas. And this appears that it is millions of symbols, millions of equations, and millions of formulas, and it is very difficult to remember and understand. So if I am trying to make it that no, mathematics is on some geometry, mathematics is some geometrical figures in shapes, these points, lines, surface. If we think in mathematics from this perspective, then mathematics will appear as a very small subject. It means it is comprises some points, some lines, and some surfaces, and some solids. So it will make mathematics understanding, learning very easy and enjoyable. So with this objective, we are doing a lot of work on that. And here, as I told, my objective is not to explain new approaches in teaching mathematics. And this new approach, what we are doing. Can you see my screen? But somebody telling they can't see.
We can see, sir.
Okay. So our objective is to create awareness about mathematics, engage mentoring and scaffolding. Scaffolding is not available at present. What we do, we try to make awareness, we try to engage students, but mentoring and scaffolding, this is the two activities what is required continuously from our startup support. We are trying to provide that. So any problem, not for a T puzzle, any problem if we want to solve, then we require to follow these some steps. So first step is to that mathematical problem. What is the problem? Then try to find out some clues from the given problem. All the problem, the clue remains inside. So you need not go outside. So we can think of what is the clue given. Then from that clue, we can plan how to solve this and then execute that planning. So these are the 4 steps. Any mathematical problem, I will explain it from T puzzle perspective, but any mathematical problem can be solved like this. So here, what is the T puzzle? T puzzle is this sort of 4 pieces, plain polygons, and you have to put it so that it can appear like a T. So that's all the problem. And so to create a shape of T by arranging the 4 given polygons. So here, what is this? These pieces are available in market, and this is a fun game, you can say. And people try to make it from the 4 pieces. They move it here and there, place it left, right, and try to make it T. And many times we get success, many times we fail, and matter ends there. But it can be solved mathematically? That is the question. Then I told, yes, it can solve also mathematically. And that is my paper. Here actually, when we see these pieces, then you can see that you can correlate easily with these pieces, how this 4 pieces forms a T. Now, this is the earlier work of what Dr. Moeller, in his experiment with MATLAB book, he has solved this problem, but he has used complex numbers for solving this. And I will show that what he has done. And with these 4 pieces, he has created this T. Here in these pieces, you can click and drag and rotate and flip, and you can put this in place so that it forms a T. And from the same piece, he has also created some arrows which looks like this. And there is some rhombus also he has created. But for me, this creating this through complex number is really complex, and animating and modeling this process is also more complex. So I am trying to do this in Microsoft Excel. So solving T puzzle in Microsoft Excel, what is the step required? We require create polygon pieces, position the polygons in order, then drag and place the pieces together. If required, rotate the pieces at a desired angle. If required, flip the pieces as required. So these are the activities involved in that. So in these 5 activities, creating the model shapes is to some extent, I should say, easy, because many of us know how to plot points in Excel, and with that plotting idea, we can plot only in this dimension we have to get, and many literature is available, or you can make your own dimension and you can create these shapes. This is not that problem. But next problem comes this dragging, rotating, flipping. This is the problem what comes. And this is actually scientists and engineers, technocrats, engineers, medical practitioners, they require knowledge of this, how to capture the dynamism around the world. So I have analyzed, and it is a well-known fact that any type of dynamism can be captured with these 6 type of transformation. So one is scaling, reflection, shearing, rotation, translation, and projection. With these 6 transformation, we can capture all the dynamism, whatever may be in the world. Not I am talking about particular thing in the globe, whatever movements are there, everything can be done with this 6 transformation. And this is a important information. And once a student learn these 6 things, he can do any dynamic situation, he can model and animate. Now, another beautiful thing is that all these 6 dynamism can be captured through single matrix. This is the 4x4 matrix. With that, you can capture all those dynamism. You can rotate, you can flip, you can scale, you can shear, you can project, you can translate, anything you can do with this 4x4 matrix. But you should know the effect of each element of this 4x4 matrix, then only you can do that. So in our T-puzzle, we require only because our shapes are not getting distorted. So shape remains same. So shape remains same means we can only we cannot scale. We don't require scaling. Scale it. We are not scaling. We are not projecting anything. We are not. Yes.
Sorry, sir. We have another 2 minutes. Can you please wrap up?
Okay. So translation is this. These 3 type of transformation you can do, and this learn 3 activities. I am telling any mathematical problem, you learn 3 activities, then you can solve any mathematical problem. What is the 3 activities? The plotting, matrix multiplication, and adding slider in animation in Excel. So with this, I will be going to show my Excel file. Can you see my Excel sheet? Yes. So these are the data I have used here for creating this object in Excel. Then these parts I have integrated in one place, and randomly I have placed these parts, and I have taken that how it will show like this. So doing that, I have done some pieces in randomly. This is first initial effort I have done randomly. I have calculated the center of rotation, and these are the sliders I have put 8 sliders here and 8 for translation, 4 sliders are there rotation, 1 slider for flip, and this. So now we can place this T. With that, we can place this in whatever position we require, and these are the things, final position what we get. We can achieve this by moving here and there like that. So final arrow I can create here also. This is these things. So what I mean to say, it is very easy thing to do, and anybody, I have experimented with class 1 boy also. He can do whoever can handle Excel or mobile, he can do it easily. And they need not learn that matrix multiplication, what is that? They can learn mechanically, as it require to learn driving accelerator, how works. I don't require to learn the technology about accelerator or brake or something steering. So similar thing is there. They can handle it, they can do it. So this is the thing. And I will show the Molar thing. Molar has done it in Excel. And when we run this program, this is the program. And here he has kept some whatever you want to do, you can select that, and then you can drag it. But here you drag and rotate all these things is means there is no pattern. Student cannot learn anything from it. But in Excel, if they do everything, they can do their own. They can add. They can add any number of slider very, very easily, and this is nice way of engagement. And whenever the new topics comes, then they can contact me, sir, how we'll do this. And we give real-time support for that. So this is our startup thing we are doing, simplifying, and I think I'm well in time.
Thank you, sir. That was a
Thank
wonderful
you.
presentation. Are there any questions from the audience? We have another 5 minutes. You can put it in the chat box or you can unmute yourself and ask.
I have a question, sir.
Yes.
Like you have shown that with these 4 pieces, T-shaped figure or
Yes.
an arrow or a rhombus can be drawn. Is there any other geometrical figure which we can make with these 4 pieces?
Anything. I am giving an example. You can all tangram pieces you can do like that. And not only this, you can I apply it in explaining the symmetry in abstract algebra. In this session only, I have presented one paper on nothing abstract in abstract algebra.
Yeah.
Here also I use this how symmetry we can use. I have used all these rotation things. And here no prior knowledge is required, no programming is required. That is the beauty. In anything you do, MATLAB, this GeoGebra, anything you do, you have to learn the, at least syntax you have to learn, you have to follow their syntax. So you are in follower there. Here you are in driver. Once you start, you can do a lot of things, anything you can do. So I am very excited about that. And I have conducted so many workshops for faculties. Mainly I teach for faculties and I conduct a faculty development program. My next program is in 7th January at Gujarat Data Practical Education for professors of this Gujarat Engineering College and universities. So,
Shanta, can I ask a question?
Yes, please go ahead.
I think the question asked by the previous person was this T shape is made from the T shape, right? Pieces are cut.
Yes,
so
yes.
You can reassemble them.
Yes.
Is there any other shape you can make?
Any shape, sir. Any shape.
You give no. She wants to know some example. So give some example, please.
That was my question. Actually, in your paper you mentioned about 2 figures, arrow and the the rhombus.
What else
can be made? Yeah.
You see, any if you open any this T problem, there are given charts are there. There can be 35. It can be unlimited. You can create your as much as shape is possible if you want. Actually, there is no limit. It depends on your creativity.
Sir, I have a question.
Yes.
So now we learned about Mathicon. So Mathicon gives the same flexibility. We don't need to really learn anything. So would that be more advantageous than Excel, or is there something?
I have not used that. I don't know that. But what I am suggesting is, I was facing problem in mathematics, and I was thinking that if I give shape, then I can understand mathematical concept. So first I learned 3DX Max, which is the animation, 3D animation. We make cinema on that. So I learned that. I am very good in animation. So after learning, I realized that there I am giving command. Suppose I want a sphere throw up a projectile. So if I give command, it is ball is going, but I wanted to know how it is going. So what is the mathematics? That I have not learned. Then I learned MATLAB. MATLAB also, I have to learn lot of coding, and it is not that flexible. Even I have used here 12, 14 sliders. If you add any MATLAB file, 14 sliders, it will be almost crashed. You cannot manage it. And for the same sake, whatever you are telling, I don't have idea how easily animation is required to the movement. And if it gives you flexibility for movement easily, then it can be a good thing. But I do a lot of quarantine, means 3D also in this, and I do complex analysis in the Microsoft Excel with very easily. Okay.
Thank you, sir. I think, thank you very much. I think we will now move to the next presentation.
Yes.
Dr. Richa, can we move to the next presentation?
Yeah.
Yeah, okay. So I would like to request the group Vivek, Sandeep Yadav and their group to make their presentation on Math Lab, Learning Math by Doing Math.
Good evening, everyone. I'm Vivek Kumar Sahu. Can I, ma'am, share the screen?
Sir, can you please give a brief introduction to yourself?
Yeah, ma'am. My name is Vivek Kumar Sahu from IIT Jodhpur. We have developed these instruments for mathematics teaching. Yeah, ma'am, can I share the screen?
Yes, it is already shared. We can see your screen.
Okay, ma'am. My name is Vivek Kumar Sahu from IIT Jodhpur. We have startup education made easy, idiom easy. So, can I present my PPT, ma'am? Okay. Mathematics teaching. One of the great mathematician, Manjul Bhargava, who is field medalist in mathematics, once says, I feel all mathematics is recreational. You have to see the fun, what you are doing to really become passionate about it. For me, mathematics is always fun, but really not out nowadays. Unfortunately, usual mathematics curriculum doesn't do much of that, and that is a reason youngsters are scared of that. Teachers teaching mathematics is puzzle in magic, in music, that helps you see the fun side. Really, if students do math in fun way or activity, definitely the interesting level in mathematics definitely increases. So these are the outline my PPT: mathematical abstraction, mathematical visuality, math lab, learning math by doing math, demonstration, conclusion. This is the mathematical abstraction. These are the some quotation given by a great mathematician. Most of the textbook of mathematics are written in ABC form, abstract before concept, and it is therefore easy for the teacher to follow the same. As the result, student gain only abstract knowledge. Due to the big reason, students are finding it difficulty to visualize the concepts of mathematics and do not connect one topics to another topic. Mathematical visuality. Generally image memory are stronger than theoretically memory. किसी भी चीज को हम जो चीज देखते हैं या उसको करते हैं वो चीजें हमें ज्यादा याद रहती है इन कंपैरिजन टू स्टोरी पढ़ने से. जैसे कोई भी टॉपिक हम पढ़ते हैं उसको हमें 10 से 15 दिन में रिवाइज करना पड़ता है, बट अगर उस चीज को हम एक्टिविटी के थ्रू करेंगे तो वो हमें ज्यादा याद होगी. So it is commonly observed that the understanding patterns and visualization helps students to learn even complex mathematics to apply them to new problem. Like we have a problem, linear polynomial x plus 3. Then find the zeros of the linear polynomial x plus 3. Simply student let px equal to x plus 3 and then px equal to 0. But they know why do px equal to 0. If they know why px equal to 0, so like the zeros of polynomial, simply the polynomial cut at x-axis at that point is the zeros of the polynomial. Similar, so if student they know simply zeros of the polynomial intersecting point of x-axis. So agar if have a question of quartic equation and cubic polynomial, then also be zeros of polynomial of quartic polynomial is intersecting at x-axis. If agar wo visualize us cheez ko kar lete hain to wo quartic equation ho ya cubic equation ho uska bhi questions ko bahut aasani se solve kar le jayenge. So we have a math lab created by Edu and Easy. Math lab we present novel and thought-provoking experiment for the school student standard 6 to standard 10th, which are based on NCERT curriculum, to learn each and every topics of mathematics by doing activity. The objective of mathematics are to provide a platform to the teachers to teach the basic concepts of mathematics through experimentation and visualization, to use equipment for hand-on-hand the topics such as algebra, number system, geometry, data handling, mensuration, etc., and their solution. To visualize the proofs of theorem of geometry, lines and angles, quadrilaterals, symmetry of triangles and other related result. ये जो मैथ्स लैब बनाई गई है, ये हम लोगों ने एक स्कूल में रह करके और उन स्टूडेंट को पढ़ा करके और देखा गया कि उनको कहाँ-कहाँ प्रॉब्लम्स आ रही हैं। उन सारी प्रॉब्लम्स को ध्यान में रखते हुए ये सारे इंस्ट्रूमेंट डिजाइन किए गए हैं और इनको बाद में इस इंस्ट्रूमेंट से पढ़ाया गया, तो बहुत सारे चेंजेस उन स्टूडेंट में देखने को मिले। तो these are the 8 instruments. First is algebra annotator, second is number system operator, third is fraction tester, fourth is equation solver, 5 is geometry expositor, 6 is coordinate system demonstrator, 7th is circle descriptor, 8th is mensuration evaluator. This equipment algebra annotator. Algebra annotator, the biggest challenge in learn algebra is understanding operations such as addition, subtraction, multiplication, and division of variable or function of the variables. Generally, student can solve x plus x equal to 2x, but x into x, still they answer that 2x. That is a big confusion. But by this instrument, we can easily solve x plus x and also be x into x by doing activities. And this instrument also capable to solve linear equation of one variable like x plus 2 equal to 3. Why x plus 2 equal to solution are exist? Why LHS equal to RHS? This instrument are capable for existence of solution linear equation of one variable. The algebra annotator is designed for learning by the visualization or doing the activities involves variables. Second instrument, number system operator. This is a very wonderful instrument. A positive or negative outcome is always a problem in using operation between numbers. Let's take an example, 3 minus 2. So a student, they answer that 1, but 2 minus 3, still they answer 1. That is a big confusion in the number system of positive and negative. But by this instrument, this problem will be resolved. Like one more example, the successor and predecessor of plus 2. Student, they can simply answer the successor of plus 2, that is plus 3, and predecessor of plus 2, that is plus 1. But when we have question minus 2, जब स्टूडेंट से पूछा जाता है minus 2 का successor क्या होगा, तो simply minus 3 बोलता है. That is a big confusion. But by this instrument, this problem will be completely solved. अभी कुछ दिन पहले मैं अपनी nephew को ये क्वेश्चन समझा रहा था, उसको theoretically समझाया, तो उसने भी यही आंसर दिया. I think वो 10 years old की है. बट जब मैंने इस इंस्ट्रूमेंट से उसको वो बताया, तो उसने बहुत आसानी से बता ले गई कि सिंपली -3 का जब भी हम लोग सक्सीजर की बात करेंगे तो 1 डिजिट अपवर्ड जाएंगे और प्रीडिसीजर की बात करेंगे तो 1 डिजिट डाउनवर्ड आएंगे. तो मैंने उससे सिंपली पूछा -3 का सक्सीजर क्या होगा, सिंपली उसने बोल दिया -2, और -3 का प्रीडिसीजर क्या होगा, सिंपली उसने बोल दिया -3. मैंने कहा ऐसे कैसे आपने पहचान लिया, तो उसने बोला सिंपली सक्सीजर हम जब करते हैं तो 1 डिजिट अपवर्ड जाते हैं और प्रीडिसीजर जब करते हैं तो 1 डिजिट डाउनवर्ड करते हैं. और यही नहीं, उसकी थिंकिंग लेवल भी धीरे धीरे क्या हो गई, बढ़ने लगे. जैसे मैंने पूछा कि तुम में और मेरे में बड़ा कौन है, तो सिंपली उसने बोला भैया आप बड़े हो. मैंने कहा ऐसा कैसे तुम डिफाइन कर पा रही हो, सिंपली करिए आप मुझसे हाइट में बड़े हैं. हमने कहा और सोचो, तो सिंपली वो बोली आप एज में बड़े हो, हाइट में बड़े हो. यानी कि उसकी जो थिंकिंग थी वो ग्रेटर और लेस को किसी तरीके से वो नंबर में डिफाइन करने लग गई, यानी कि उसकी थिंकिंग लेवल बढ़ने लग गया. दिस ऑपरेटर हेल्प्स इन लर्निंग कॉन्सेप्ट बाय डूइंग एक्सपेरिमेंट. The next instrument is fraction tester. By this fraction tester, we can visualize the concepts of the fraction. We can do addition of fraction, subtraction of fraction, and also we visualize the concepts of the fraction. Another instrument is this instrument are equation solver. By this instrument, we can understand and visualize the number of the solution of linear equation, and also the theorems we can verify here. a linear equation of two variable have an infinite many solution. From this instrument we can visualize, and also we visualize the linear equation of two variable when their solution are exist or not, how many number of solution are exist, unique solution, no solution, and infinite many solution we can visualize from this instrument. And also by this instrument we can solve the we can find the roots of the quartic equation and quartic polynomial, and when are the solution or quartic equation exist or not, we can, all those things are visualized from this instrument. Next instrument, this is a geometry expositor. This one equipment is the solution of bank of all geometrical concepts, starting from understanding the angles between two lines and visualize the properties of parallel lines, triangle, quadrilaters. And this equipment is loaded with a number of activity outside the instrument, and also with this instrument are capable to solve the trigonometry, and by this instrument we can find the trigonometrical ratios for different specific angle like cos 30, sin 60, and also by this instrument we can verify what is the value of sin 60. The value of sin 60 equal to √3/2, but the sides of triangle will be changed, but the value of sin 60 doesn't be changed. Why? But by this instrument we can understand and visualize the sin 60, the value of sin 60 never be changed. Why? By this instrument we can visualize.
Sir, can you please wrap up in another 1 minute?
Okay. By this instrument we can visualize the coordinate system, ma'am. And this is a circle descriptor. By this instrument we can visualize and prove all the theorems of circle, and we can find the area related to the circle, probabilities, percentage. By this instrument we can visualize. This instrument, this is the mensuration evaluator. From this instrument we can make different types of body, and we can find the different types of bodies of perimeter, area, and also with data handling. We can also understand bar graph, data handling, all those things. This is the 3D shapes, and R&D में चल रहा है ये, तो अभी 3D shapes है, R&D में पहुंच चुका है. इसके थ्रू हम वॉल्यूम, सरफेस एरिया भी 3D shapes के निकाल सकते हैं. और these equipments are the eco-friendly, sustainable, and these have a zero maintenance. And these instrument cover each and every topics between 6th to 10th class. And with this instrument we have written books chapter and chapter wise, and that helps to teacher and student to perform the experiment on the instrument. Ma'am, we have time and 3-4 minutes.
It is 4:18 now. We need time for questions. So just half a minute. Can you just?
Okay, ma'am. These are some demonstrators. I will left that. Okay. Thank you. ये some demonstration है मैम, जिसके थ्रू ये इक्विपमेंट में ये सारे एक्सपेरिमेंट किए गए हैं. Okay, ma'am, कोई question हो तो?
Yeah. Thank you, Mr. Vivek Sahu and group for this wonderful presentation. From the audience, is there any question? You can put it in the chat box or unmute yourself.
Question.
Yeah, please go ahead.
Yeah. So, Mr. Vivek, all these equipments, are they covered a particular curriculum, like a CBSE curriculum only, because you refer to NCERT, or it covers all curriculum?
मैम, जो बुक्स लिखी गई हैं वो एनसीईआरटी बेस पे लिखी गई हैं, बट ये इंस्ट्रूमेंट सभी को कवर करता है. उस पे बुक्स लिखी जा रही है, आल्सो भी R&D में है, कवर करते हैं उन सारे चैप्टर्स को.
So I have a question, like there is an equation solver instrument you have shown. So if you have to show the solutions of linear inequation, then how will you do that?
Ma'am, जैसे like we have a one equation x plus y equal to 2, x plus y equal to 3. So put 2 screws at 3, and sticks, we have a stick, we have a magnet sticks, and join the points at +3 and at x-axis, and one screw at y-axis at 3 and joined by the sticks. This is the equation. जैसे ये मैम लगी हुई है, ये x plus y equal to 4 की है, तो यहाँ से हम x plus y equal to 4 linear equation की सारी properties को समझ सकते हैं.
My question is, suppose the equation, I'm sorry, ma'am, may I?
Yeah, sorry, go ahead.
Yeah. If the inequation is x plus 2y greater than 2, then how will you show them the solution of this inequation? X plus 2y greater than 2.
मैम x plus 2y greater than 2, तो हम लोग x plus 2y को प्लीज यहाँ पे फाइंड फॉर्म कर लेंगे, बना लेंगे, और ग्रेटर देन 2 है तो वो अपर साइड जो एरिया होगा उसको हम लोग बता सकते हैं, जो अपर साइड का एरिया होगा.
How will you like explain that upper side plane is the area or the solution? Why not the lower part area?
मैम बिकॉज x plus 2y is greater than 2, और सेटिस्फाई करेंगे जो भी पॉइंट्स होंगे उसको सेटिस्फाई करेंगे. अगर वो इक्वेशन को सेटिस्फाई कर देंगे, जो भी एरिया सेटिस्फाई कर देगा तो वही एरिया होगा उसका.
Okay, thank you.
Thank you.
Sorry, I have a question. So many of these things seem very interesting. Can you tell us what is the advantage of the instrument over something like GeoGebra or Mathegon, that the software that we have? How do you see it? What difference do you see?
Shanta, just 1 minute. Even before going to digital, there are many hand operated, like Jamboard is there, okay, which can do the same things. Instead of nuts and magnetic sticks, which are probably costly, there are Jamboard available on which already nails are fixed as the coordinate points, and you just put a rubber band to draw a line. They are much cheaper, okay, to make and to use. So what way your thing, say for example, compare with Jamboard 1 and then digital tools which Shanta is saying, such things are available on very lot of sites. Digital Mathegon is there, GeoGebra is there, very other places. So I can take one advantage that they need probably internet. So internet may not be available. That may be your answer, that these can go to a rural place where internet is not there. But let me ask you what advantage this has over a Jamboard, handheld Jamboard, which is ordinary student can make it by taking a piece of paper, by putting nails at the coordinate points, and then putting rubber bands around it. So in what way do you think is your thing is better?
सर जैसे कि ये जो जितने भी इंस्ट्रूमेंट हैं इसमें हम लोग मैग्नेटिक स्टिक्स लगाएंगे, और
तो कह रहा हूँ वो कॉस्टली है रबर बैंड यूज करने से.
सर उसमें क्या हम स्पेसिफिक हो जाएंगे, बट दिस इंस्ट्रूमेंट कवर ऑल द कॉन्सेप्ट 6 to 10. बट उसमें क्या होगा, जैसे कि इरेशनल नंबर को डिफाइन करना तो मैं हर जगह रबर बैंड के लिए कील लगानी होगी, बट इसमें ऐसा
नहीं. इसको इरेशनल, आपके इस कोऑर्डिनेट सिस्टम में इरेशनल नंबर कैसे दिखाओगे?
बुक्स है सर, मेरे सर बुक्स हैं उसमें लिखा हुआ है, क्योंकि जितने भी टॉपिक्स हैं.
आई एम सॉरी, irrational number, nobody in the world can pinpoint a irrational number physically. I challenge. You can only show an approximation of a rational number to irrational number. You can never show it. Nobody in the world can physically show here is a irrational number. Okay.
Okay, sir. But they can.
No, that's what I'm saying. So you should understand what is a irrational number. Do you know that?
Yes, sir.
What is irrational? Tell me, please.
Root 2 pi.
Example. What is irrational? Definition क्या है?
Recurring आता है सर.
क्या recurring होता है?
Recurring नहीं होता सर. 1 point जिसका लास्ट में end नहीं होता.
क्या लास्ट नहीं होता?
Sorry sir, I am not able to give that answer.
हाँ, तो आप कैसे समझाएंगे कि irrational number इसमें डिस्प्ले कर सकते हैं जब आपको खुद समझ में नहीं आ रहा कि irrational क्या है? I'm sorry. It's okay from my side.
Yeah. So is anybody else there from your group? Do you want to add on to anything that Mr. Sahu has said? So I think it's a good, sir, maybe we can do a session on irrational numbers and the number systems in the coming conference or between the conferences. Shall we move ahead?
Shanta,
yes, sir.
I would say that I have a math clinic going on. Every week we have a lecture in that. Probably you should come over and say something about rational and irrational numbers.
Sure, sir. Sure, sir.
Math
Sure.
clinic topic.
Sure.
It is a math clinic topic.
Yes. It's a very important topic, and I think it's one of the struggles that all of us face. And
Okay.
yeah, I think it's a difficult topic. So shall we move ahead, and shall we? We would like to invite Rebecca Thomas and Jay Kareem to make their next presentation.
Yes,
It's
ma'am,
called
I'm here.
Effect of Student Technology Use and 21st Century Efficiency and Beliefs in Online Science and Math Classroom. Welcome. You have 12 minutes and 5 minutes for questions.
Yes, ma'am. Thank you so much for the introduction. Ma'am, I won't be able to share unless Vivek stops sharing.
Mr. Vivek, can you please stop sharing?
Yes, ma'am. I hope my screen is visible. And to introduce myself, I'm Rebecca Susan Thomas, and I would be presenting my paper titled The Effect of Student Technology Use in 21st Century Skills on Teacher Efficacy and Beliefs in Online Science and Mathematics Classroom. This has been co-authored by Dr. Jacqueline Kareem, Assistant Professor, School of Education, Christ, deemed to be University. I'm currently a student of Bachelor of Education at School of Education, Christ, deemed to be University. So for the introduction, I would first like to look at the key terms that's been used in this paper. First is STEM education. What is STEM education? It is nothing but an integrated approach that integrates 4 disciplines, namely science, technology, engineering, and mathematics, such that it allows students to explore 2 or more of these subjects together in real-world situations. Students develop various skills such as problem solving, collaboration and teamwork, critical thinking, communication, and creativity, to name a few. Next one is, what is constructivism? It is an educational theory that says that learners construct their own knowledge based on previously acquired knowledge. The third one, teacher self-efficacy and beliefs. Teacher self-efficacy and beliefs refers to the beliefs that teachers hold about themselves in executing instructional practices that leads to positive student learning outcomes. It is a teacher's self-perceived ability to achieve favorable learning outcomes in a classroom. And various studies have shown that teacher efficacy impacts student learning outcomes, their achievement, it increases their job satisfaction, as well as it helps them to integrate a lot of technological tools and innovative teaching methods in their classroom. And finally, professional development for STEM education. Regular professional developments and workshops on integration of technology increases teachers' technological skills and helps them to integrate technology in the classroom with these. A few of the reviews. The first one is entitled under Effect of Computer Supported Collaborative Learning. Research has shown that use of technological tools and the first research, computer supported collaborative learning using GeoGebra software, has had a significant effect on the students' achievements. And it has also taught us during this pandemic that collaborative learning is definitely possible even in remote learning environment. Teachers need to be formally trained to effectively transform knowledge to students at a distance. The second one, perceptions of teachers towards STEM. There were mixed responses from primary school teachers, as they had both a positive as well as negative attitude towards STEM, about integration of STEM. Therefore, through professional development and through training, this could be enhanced. And there has been reported there is decreased difficulty that science and mathematics teachers face after attending PDs. And and teacher beliefs should be considered in order to facilitate technology integration. And definitely PDs and workshops are a means of achieving this. Going to the need of the study, as I mentioned earlier, it's an important aspect in integrating STEM and K-12 is the approach that teachers have towards STEM in the first place. Awareness of STEM, effective methods to implement STEM, and increasing student motivation towards the same are a few aspects that teachers play an important role in. Research that pertains to assessing differences in teacher efficacy and beliefs, the extent of student technology use as perceived by the teachers and 21st century skills has not much been looked into. Therefore, the present study is aimed at exploring these factors that are necessary to implement a constructive STEM classroom successfully. And I've also looked into the strategies needed for successful implementation of the same, and also through means of interview, the strategies that teachers have been adopting during this pandemic time has also been studied through this research. The research questions that are addressed are, what are the levels of teaching efficacy and beliefs of teachers with regard to implementing STEM education? And what are the strategies that can be adopted for a constructive STEM classroom? And the objectives pertaining to the research questions are also mentioned. And the major hypothesis formed is student technology use in 21st century skills are not significant predictors of teaching efficacy and beliefs among science and mathematics teachers. So coming to the research methodology, this is a mixed research method having both a quantitative part as well as a qualitative part in the form of an interview. Interview with 4 mathematics teachers were conducted to study about their challenges that they faced during this pandemic time, as well as the ways that they adopted different methodologies to transact their lesson. Convenience sampling technique was used for the collection of quantitative data through Google Forms, and the interview was conducted over Zoom. The sampling was 84 science and mathematics teachers across schools in Bangalore. And the inclusion criteria was teachers with a minimum of 2 years of experience. Coming to the tool that was used in this study, it's called the T-STEM survey, Teacher Efficacy and Attitude Towards STEM. It has 3 constructs. The first construct, teaching efficacy and beliefs, had 10 statements regarding the teacher's feelings about their science and mathematics teaching. The second construct was student technology use, having 8 statements regarding the extent of student technology use as perceived by the teachers. And the third construct was 21st century skills, which had 11 statements with regard to the extent of teacher perception on the importance of 21st century skills. Coming to the data analysis, data obtained from the survey was analyzed using SPSS package. And regression, first reliability of the tool was tested, Cronbach's alpha, and it was found that the tool was highly reliable. And based on this data, regression analysis was conducted, and we see that both student technology use as well as 21st century skills affected teaching efficacy and beliefs. Now, coming to the themes that were prevalent through the interview that was conducted, all the interviewees looked at STEM education as either an integrated or interdisciplinary approach. So the statements that I've put up here are extracts from the interview. It's the first one is their view about what STEM is. And the second one was their beliefs on what students do. What is the role of a student while teaching science and math? And that was most of the teachers stressed on the fact that students must be able to think out of the box. They must be creative and collaborative. All these skills should be there. And the third one was strategies for a constructivist classroom. Again, as I told this, since it was conducted during the pandemic, many of the teachers expressed that this particular time helped them go through a lot of resources, and they were able to access a lot of things and do things very differently using technology. And the major challenges that they faced in implementing was the lack of time and preparation. Because of the pressure to complete syllabus on time and the vast syllabus, they didn't really have the time to plan classes out for integrating this as well. And the major results that emerged as part of the study was that student technology use and 21st century skills as perceived by science and math teachers were definitely significant predictors of teaching efficacy and beliefs among science and mathematics teachers. Although teachers possessed a high confidence of their teaching efficacy and beliefs, of the need for 21st century skills to be inculcated in the students, it was not very much aligned with their practices in using hands-on activities that encouraged using digital tools. And this has been previously reported as well. When teachers integrate technology in classroom, they influence the students and hence can impart 21st century skills. This would in turn increase their beliefs in their teaching abilities as well. Hence, all these three variables positively influenced each other in a classroom setting to teach science and mathematics. A few implications of this study is that regular and sustained professional developments and workshops in implementing STEM education will definitely be of help to teachers to implement this. Lack of time resulting from completing the vast syllabus during the academic year leaves teachers with no time for planning and preparation for activities. Hence time and space must be provided for the same. Teachers must be aware about the interdisciplinary and integrated nature of STEM rather than the subjects working independently. Hence, the school management and boards must take the required steps to help teachers plan out on the schedule and carry out relevant activities that would definitely support a constructive classroom. A few limitations of the study is that the first thing is convenience sampling technique was used, and second thing it was majorly limited to the city of Bangalore, and the representation from government schools were low, so there might be discrepancies with regard to that as well. And a few future directions with regard to extension of the study is that we could conduct workshop and look at how attitude changes before and after the workshop, and as well as the attitudes can be studied in depth during such workshops. And to conclude, this pandemic has definitely brought technology into classroom in a very effective way. And teachers have problems with regard to a lot of things as time constraints, but this could be looked into. Teachers must have high teaching efficacy and beliefs in integrating technology, and they must have a positive attitude towards the same to implement it effectively in a classroom situation. That's it. Thank you.
Thank you, Rebecca. That was wonderful. Shall we open up to questions? Richard, do you want to ask anything?
Rebecca, it was the presentation was really wonderful. But can you explain this STEM concept using a topic? Can you tell me briefly a topic and how can you apply this interdisciplinary approach to that topic?
Yes.
Any mathematical concept or any science topic, anything?
Yes, ma'am. The one that's quite very trending right now is robotics. So they have the STEM skill set, the entire tool available where children get into robotics. So when they do such things, it's an integration of technology and then definitely science, because they have circuits coming into picture. And that would be one. And another one would be to execute something very simple, which I could think is applicable in everyday schools is, just for young children, growth of a plant. So now they have a plant, they're growing a plant, and then they're studying how each week the plant is growing. So there is math involved, there is science involved together. So it's integrating two subjects or more than two. So this could be something that could be done with the young children as well.
So it means so just, may I, sir?
Please go ahead.
So for a particular topic, it's not necessary that all 4 concepts of STEM we are using. It depends upon the topic to topic.
Yes.
Like you said, for the growth of a plant, it's only 2 topics, 2 concepts which we can do interdisciplinary thing.
Yes. So it's 2 or more.
Okay, thank you.
I just wanted to ask, supposing you are filling water in a glass, okay? The glass is actually of glass where you can see-through glass kind of thing that we normally use. And it is a shape of a cylinder, very fancy glass with straight glass and some height. And you are filling water in that from a tap. And let us make assumption that the water is coming into that. at a constant rate, right? The tap is not kabhi kam aa raha hai, kabhi zyada wo nahi ho raha. At a constant rate, the water is coming from the tap into the glass. So what will happen? The height will rise of the water level. Yes.
Yes, sir.
Right. So if I want to plot in how much time the height has risen, what kind of a graph it would be? Can you imagine? Height versus time.
Yes, sir.
What kind of a graph it would be?
It
Don't be scared. I'm not testing you. I'm just saying that whether a child could be able to visualize this or not. Yes?
Yes, sir. So as time increases, the height of the water also increases. So it would be
Yes.
a linear graph.
Very good. So now, supposing the graph is slightly more fancy, it is more of a top is more open and the bottom is normal glasses, no? Where the top is bigger and the bottom is smaller, right?
Yes, sir.
What change will come in the graph? Yeah, I'm saying now this is a very simple STEM activity.
Yes, sir. True.
You are right. So their mathematics is coming, and actually one can take some softwares, measure the height, plot. You can actually do an experiment as a math lab kind of a thing. And you can also try to visualize and whether your data comes at par with. Oh, this is a very simple kind of activities that we should look at. Not go to robotics where a student has to probably find some expensive instruments and invest money to go into STEM education.
Yes, sir.
There are many simple STEM activities which don't require anything. Okay. Do you think there is mathematics in cutting a tree?
Yes, sir. Definitely it would be there.
It could be, it is, and that is a STEM activity. How do
definitely.
So these are very simple kind of things.
Yes, sir. Definitely.
So I'm saying that as your teacher, what are you doing? You are a student?
Yes, sir. I'm doing my final semester of B.Ed.
Okay, good. So you are going to be a teacher and you're going to be probably interacting with the teachers. So try to stress that you don't have to go for expensive gadgets, right? You can
sure.
Simple things. Please. Okay. Thank you. Nice presentation.
I have a quick question, Rebecca. A lot of it seems intuitive, right? I mean, when you started the study, you would have expected what the result is going to be. So my question is, did you get any insight or did you get any surprise during the period of the study, or it went as predicted?
One thing was again with student technology use. So we had collected demographics of teachers as well across different boards. Which boards was that? So the student technology use was something that we never thought, at least the pandemic time, since everybody has been into using technology and using a lot of tools. So that was, we thought that would be on the higher side. But it wasn't that way, and there was a lot of difference between the boards as well, the school boards. So that was something that was a little away from what we expected. So it's something that we understood, that not all schools are actually integrating technology, or probably the teachers are not aware about it as well. So that's something that we got from this.
Yeah.
Just a last question. What do you think could be a way of, you said the teachers are not motivated enough to use of technology, right? That was one of the feelings you got. So give me one suggestion, which thing you think will motivate teachers?
So first thing is, one suggestion that I would personally give is teachers have to be aware about what can be done through use of technology. What are the positives that would
you see, you have to be not what you will do it if you have to do it. I'm asking.
Okay, as
it has to be done. A lot of research has been done about those things, right?
Yes, sir. So if I were to think about it, probably I would, in the smallest way, share about a tool which I think is useful and which I've tried and it's useful for my students. I would probably share it with another teacher. So
that's a very good idea. That's a very good idea. You should have a small cluster of teachers, either your school alone or nearby schools, put them together and have some weekly or monthly kind of meeting where you share these ideas with them. That is the only way of spreading and teaching. Okay, thank you.
Thank you. Sir.
Yeah, thank you, Rebecca. That was lovely.
Thank you,
Can I now request Ashwini Utkhede to make a presentation? The topic is use of technology in math classroom. Madam, you have 12 minutes. We should, and about 2-3 minutes of questions. Yeah, go ahead.
Yes, ma'am. Thank you so much, ma'am, for the introduction. And I have attending the conference from last 3 days, and I've seen the expert faculties presenting different softwares and sharing their experiences. So during pandemic, I also used many software. So before starting with my presentation, let me give introduction. I am Ashwini Utkhede from one of the CBSE school from Maharashtra, teaching to grade 9 to 12. And I would like to share my experiences that how does this tools and technology help me teaching mathematics during pandemic in online classes. Is my screen visible, ma'am?
Yes, yes, clear.
Yes. So using technology, how does it help to learn mathematics in online classes? So it has helped in the following way, that it has made the students engage throughout the class actively, has given a meaningful learning experiences, and it has also helped teachers of my department planning and developing differentiated instructions to meet the unique needs of students as individual learners. And it has also provided an opportunity to my students to explore and make discoveries with games and some simulations with these digital tools. So the methodologies that require to adopt to have this integrated technology integrated teaching is, very first we have redesigned our curriculum. We as a group of teachers sat together and we have given a thought that how we can integrate these tools and technology to make our curriculum more effectively and to create the interest among students. And as per that, we have adopted different methodologies for our learners. So very first, we have come across with this software, which is very popular, that is GeoGebra. We have integrated this software for different topics at different level of the school, right from middle school to senior secondary. So the topics that we have integrated and taught to the student using this software was polygon and properties of polygon. Then in high school, we have taught like angle sum properties of polygon, then properties of triangle, quadrilateral, and circle. Even it is used for explanation of coordinate geometry, linear equation. In polynomial, how does the graph of polynomial is obtained and the nature and behavior of the graph, obtaining zeros of the polynomial using GeoGebra software. With the traditional method, we used to teach the student to find the zeros of the polynomial by doing calculation. But this GeoGebra software has provided an opportunity to teachers as well as to students to actually visualize that how do we find the zeros of the polynomial, how does the graph varies if the polynomial changes. Then different theorems like midpoint theorem in standard 9 we have explained, then congruency of a triangle, similarity of a triangle, all these concepts we have explained it through this software. Then at senior secondary level, we have integrated it with conic section, then linear inequalities, observing the graphs of different trigonometric functions to determine the range and domain of the function, including straight line as well. I can even present the demonstration for any one of the topic, but as in the previous session also, we have seen how this GeoGebra and the other software help us to give the visualization for this concept. So this is one sample I'm sharing here with you all, that earlier in the maths lab, we used to teach students the verification of angle sum property by paper cutting and pasting. But during online classes, this GeoGebra tool has helped us to verify the angle sum property of triangle, quadrilateral, and other many properties of triangle, circle using this tool. Then another interesting tool was MathsPad construction tool. So how do we teach students to draw perpendicular bisector or construction of spatial angle bisector? So for that we have used this MathsPad construction tool, wherein we can explain all these constructions to the students, and we can also check and verify whether students are able to use it. The link of the same tool was shared with the student during online classes through the chat box, and we have cross-checked the work of the student as well. Then different online manipulatives which are available to make the mathematical concept more visualized. These manipulatives are used, algebra tiles are used for representation and solving simple equations, addition and subtraction of integers using number line, then factorization and algebraic identities were also explained and discussed, and many activities we have conducted through the algebra tiles which are available online in the Mathigon. Then Math Playground was one of the site where we got different online games and the different story-based word problems. So all types of word problems on different concepts were discussed in form of stories. Then for conduction of lab activities, OLab was one of the site that we have referred, and through this we have conducted different lab activities in the classroom, where volume of the sphere, surface area of sphere, angle sum property of sphere, and many other topics like how tangent drawn from the external point to the circle are of equal length. Such type of things were shared during online classes. Then teaching the concept or completing curriculum was not only the target or the challenge for us, even the assessment of the topic and the concept covered during classes was another challenge, and for that we have integrated the tools like MindMap tool, where we can ask students to share their understanding in form of different graphic organizers. So this was another tool which really helped us to check whether student have understand the concept and whether he or she is able to present it or make the graphic organizer based on his or her understanding. So here you can, even this tool can be used for explaining or for reinforcement of the concept or for the summarization of the concept as well. Then Padlet is another tool which we have explored during online classes and have integrated with our curriculum, because we were not sure whether whatever we are discussing in the class, students are able to apply all those things in problem solving also, because problem solving is also one of very important part in the mathematics teaching learning, which we as a teacher has to focus. So for that, this was another thing we have incorporated in our curriculum, where students can upload and share their work during online classes, and teachers can check and verify and give approval to the students' work in the class itself. And then Google Form is the most popular way of checking the understanding and ensuring the learning outcome of the topic that you have discussed in the class. So in this way, we have redesigned entire our curriculum using these different tools and technology in the classroom, not only for teaching learning purpose, but also for the assessment of the student. So I think that this should not stop here. Even after pandemic, now schools are open and all classes are conducting physically. So teachers should give a thought more and redesign the curriculum, having the blended integration of this technology and the other methodology, which will really help mathematics teachers to make mathematics more interesting and to give visualization to the abstract concept. Thank you so much, ma'am.
Thank you, Ashwini. That was a very nice presentation. We'll open it up now for questions, another 4 minutes of questions. I just wanted to start by asking you, what were the challenges that your school faced in making all this? It's a wonderful effort that you have done. So how did you go about it? How do you handle the challenge? The challenge of integrating technology, because this would have happened during the pandemic time and none of us got any notice. So was it that your school already had this and you continued, or?
Ma'am, GeoGebra tool, we were already aware about it. We were even using it before pandemic also. So this has given us an insight that let us have the redesigning and revamping of entire curriculum so that it will help us to conduct the curriculum or to teach the mathematics concept and reach to every student to that extent. So after 2-3 months, we as a maths team sat together and we have given a thought that how are there any other different tools. So there was a lot of research we have done, and then we have redesigned our curriculum with different tools and technology which is available, and there are really very good softwares which all maths teachers should use, and they should have blended curriculum. Even NEPs also have come up with the same suggestion that let us have a blending of all this, and which will really help students for the skill development and to develop the interest in the subject.
Shanta, can I ask a question?
Yes, sir. Please go ahead.
I just wanted to ask, when did you get aware of technology in the classroom? What was the stage at which it's not taught in the B.Ed programs at all?
No, sir. Our school has already given us an opportunity to get acquainted with different tools.
No, that's fine. Your school has given, I'm asking, when did you get used to using any piece of technology? What was your first encounter?
Sir, during pandemic only, and before that in school, means from last 3 years.
Before 3 years back, how did you get acquainted with technology at all? Was it a workshop conducted in your school, or was it a professional development workshop, or was it a government organized program, or how did you get used?
No, sir, it was an workshop arranged by our school management for all maths teachers.
Good, that's great. So very proactive management. Realizing that that's good, because many a times teachers struggle to ask management to arrange something and they find it difficult. Nice.
No, sir, we have near about 23 branches and very huge management, and this GeoGebra software and other resources we got to know through the workshop which were arranged by our management 3 years back. So it has helped us in during pandemic to have such kind of blended teaching learning.
Yeah, sure. I agree. Thank you.
Thank you, sir. Thank you so much, ma'am.
Wonderful. Yeah. Richa, ma'am, do you have any question? No. Okay. So if there are no questions, we'll go ahead for the next presentation. This is a presentation by Ms. Seema Latkar and Sneha Sharma. The topic is Novel Approach of Problem-Based Learning in Mathematics Through Modeling, Some Dominant Instructional Facts. I invite the presentation. Sneha, please go ahead. Sneha, yeah.
Thank you, ma'am. I would like to share my screen now. Is my screen shared, ma'am? Ma'am, is my screen shared?
Yes.
All right. So very good afternoon to all the eminent mathematics people present here. Today, myself, Sneha Sharma, along with my colleague, Dr. Seema Latkar, will be presenting a paper on the topic Novel Approach of Problem-Based Learning in Mathematics Through Modeling, Some Dominant Instructional Facts. A lot of mathematics talk had been going on since last 3 days in this conference, and honestly, a lot of learning. A few things we knew, but then it needed some modifications. Few new things we got to learn. A lot of new perspectives were shared. So it is not that we are talking about something new. We will be talking on the similar lines of how mathematics can be developed and how mathematical thinking will be developed. But here we are trying to give it a new perspective, that is through modeling, which is very less talked about, especially in the school curriculum. As our introduction, I head the mathematics department, and Dr. Seema Latkar heads the position of Nodal Professional Development Coordinator in our school. And it was her idea basically to present this paper, and she had been a very motivating force in our school for all the professional development initiatives that happen. So here I start. So in this paper, we have discussed the importance of mathematical and cognitive modeling for effective learning of students. We have focused on importance of teachers' training on interdisciplinary areas for correct methodology of implementation of real-life problem situations and their problem statement formulation for enabling students to think and to explore. We have discussed about few modeling elicited activities that we have termed as MEAs that can be taken up at different levels in the school. In the paper, we have also highlighted some gaps in the assessment system and the expectation by education system to induce the very important 21st century skills. So as we all know, mathematical modeling is a conversion of any problem situation into mathematical structure. The concept is used for process of mathematization of real life situations. Our world is changing at a fast pace like never before. The 21st century is all about innovation, creativity, and problem solving. Modeling enhances problem solving and critical thinking abilities. Mathematical modeling aims at enabling students to develop the skill to generalize, to anticipate the overall view of the problem and its probable ways of solution. We feel that a continuous exposure to these modeling elicit activities throughout different levels of school curriculum can produce a new generation of thinkers, researchers, and innovators. Mathematical modeling defines capability of a person to visualize the situation in various orientations, to comprehend the issues associated with it, to analyze the parameters that are involved, to do certain assumptions, to do certain synthesis, and to critically understand the sensitivity of components involved and to provide the rational, feasible, and optimal solution. So this is a simplistic approach or the flow diagram, we can say, for the mathematical modeling. And I think I can just skip it up because as we all know, it translates from a real world problem to a further, breaking down of problems into smaller steps and then putting on some mathematics into it, using graphs, using equations, and finding out a solution and then testing a solution, trying to validate it, trying to do some interpretation. And if it fits very well for the further things, then fine. Otherwise, we repeat the process. Mathematical modeling, though being very important to develop all such skills, but when we were, having a casual discussion within the faculty, we found that there was a lot of hiccups in this effective implementation of mathematical modeling. And few of them we have listed here. The first we found is the lack of appropriate teachers training in interdisciplinary field. When we talked about teachers regarding mathematical modeling, it was still considered, we found that they're still considering it as, something which has to do something at the maybe undergrad level or postgrad level. And when we talked about mathematics, it was like, in fact, if you ask me till some time back, in fact, I also used to think that mathematical modeling is something that which involves a high level of mathematical orientation. But then when we tried to break it down to a simpler level, we found that mathematical modeling is not about how much mathematics we are using. It is about how we can inculcate mathematics in a particular situation and how we can make the students think about what mathematics can be included in that particular thing. The next obstacle that we found are, as previous speakers have also told about, the schools being tight in the routine of completion of syllabus and regular activities. So this hampers somewhere the creativity of the teachers, though teachers these days are getting really ICT oriented, and a lot of things are happening, especially in last 2 years in pandemic. But still, there is still a routine of regular assessments, completion of the syllabus, so that somewhere hampers the mathematical modeling approach. So there are definitely some gaps in the curriculum that I want to talk about here. These gaps, there are a few gaps in the curriculum, and these gaps further create some more learning gap in the children also. If the learning methods do not have a real world connect, it ends up into the lack of interest for subject among the learners. The creativity and innovation in such situations is a difficult task then. These gaps need to be identified and bridged. The books referred for teaching shouldn't overpower the genuine joy of learning of the subject. And then we have the traditional methods of assessment. As yesterday Ramanujan sir rightly pointed out, that we are teaching students what to be written in the exam, not teaching what to how to learn basically. So the very fact that teachers have the flow of book-oriented journey of teaching the content with the same methods of assessments act as another strong hurdle while assessing the students. And it is really unfortunate that we judge the mathematical abilities of a child with putting a fixed pattern of questions. And the traditional method may be beneficial for those who, are able to comprehend the content very well, but then there are some people who genuinely like mathematics, but they may not be able to score well. And the last one is fear of accepting the change. And this is as a human being, I think we all have that sort of fear, and including us as teachers, because we have a set trend of doing certain things and then trying new pedagogical ways and then trying new things. So somewhere there is some hesitation. But one needs to understand the long-term implications of doing things differently to bring positive changes in the system. A positive change in the mental setup is definitely required to bring a dynamism in the system. And this kind of development requires revisiting the set trends in an organization. Modeling offers insights to how or why the students follow a particular approach or solve problem, and thinking about strategies or problem structure. So here we are talking about few modeling elicit activities. They're very basic fundamental activities, but we try to do them in a different way. So these MEAs are genuine practical situations that need thinking, discussion, analysis, interpretation, and mathematical connection to obtain solutions. These activities give opportunities for students to think of different ways to find solutions and check their validity. So in the process, teachers help as a facilitator, and teacher help in scaffolding the previous knowledge and posing guiding questions to students throughout the process. This method of learning just not caters to the problem solving, but also connects education and knowledge to the real world, and hence making learning more relevant, authentic, enjoyable, engaging, holistic, and sustainable. And this method ensures that achievement of learning outcomes, skills, and competencies. So this is a first activity I would like to share. Here the activity is to cut a circular cake, and it has to be cut in such a manner so that you get a maximum number of pieces. Yeah, and this activity is good for grade 10th, 11th, and 12th. So there are a few prerequisites. Every cut should be passing through the whole circle, and each cut should pass through all the previous cuts also. What mathematics can you find in such a situation? So this is sort of an open-ended problem. Lot of things that I discuss with this problem, maybe a lot of other things can also be thought of apart from what I am going to discuss in this now. So yes, when this question was posed up to the students, they started cutting, started making a circle and then putting few lines on it. And but this point was important, that they had to get a maximum number of pieces following a particular cut in the cake. So this activity, students are made to explore the relationship between number of cuts and number of pieces. And obviously that was not initially told to the students, that the concept involved was sequences and quadratics. But once they start doing the activity, they gradually developed the concept. So this was how they did it. so took a circle, and then when the number of cuts is 0, so number of pieces is 1. So when the number of cut is 1, number of pieces is 2. It was easy till here. Moving on to the second cut. So what most of the children did was they tried to cut in a regular way, like they were trying to draw diameters. And well, good enough. Still, they managed to get 4 cuts. But when it came to more number of cuts, so they realized that diameters won't work. They have to think of something else, because every diameter may not be intersecting the previous diameters. So then a lot of discussion happened at this particular stage, and a few people draw this, few people drew this, and finally they came to this particular thing, that the maximum that most of them were getting as number 7. And then after a lot of brainstorming here, so they got this table basically. And then this discussion was done with them, as this table they've already got. And when the teacher asked them to find out the first differences, they got to know that it is 1, 2, 3 on each stage. But when they got the second differences, it was 1. So then the topic of quadratic sequences was brought. Otherwise, the quadratic sequences as such is not a part of CBSE curriculum. Yeah, so AP, they do study AP, and they do study about nth term in the AP, but quadratic sequences as such, quadratic equations they have studied quadratic functions, but quadratic sequences is not there. So then the teacher tries to, connect the quadratic sequences to a quadratic function, and it being a quadratic function, then definitely it has to get off the form ax square plus bx plus c. I'm not going into too much of details, but a lot of brainstorming happened here when the student finally concluded that, the constant term will be the first term basically in the table itself when the number of cuts is 0. So that gives us the constant term, and the remaining a and b, lot of brainstorming was done to find these values of a and b. And some few scaffolding was also done on part of teacher, so that students could reach the final conclusion that it could be half x squared plus half x plus 1. But the whole exploration was amazing, because students could not even thought of, a simple thing like cake cutting can involve so much of mathematics. Yeah. So this was still for higher classes. Again, here the students can be provided.
Can you wrap up in another 2 minutes, please?
Yes. So in this activity, the data can be collected from the agencies, or students can collect data by conducting a survey or a questionnaire, and then they can generate frequency distribution, and they can calculate the probabilities, and they can calculate the deviations and correlation coefficient, and they can do some inference about the consistency of traffic. And then, some scaffolding can be done on part of teacher to make them understand what is the best probability distribution fit. And they can use the same data for generating a rate of traffic movement on certain selected road. And then comes differential equation, obviously, but this is higher level, as I told you, it's for the senior secondary classes once they understand what are differential equations all about. So yeah, this is a very good example where modeling can be brought into action. But here we are talking about bringing modeling down to the primary and the middle school level. And I remember yesterday Padmanabhan sir said that we need to, create stories to make the students more willing to do a particular mathematics problem. So this is how we created a situation that suppose if you want to own a dream bicycle and it costs 10,000 rupees, and you won it from your parents, and they said, okay, we will not give you the money, but you can still having by saving money on reducing certain expenses over a few months, and then you can, from the savings, you can buy the bicycle. And the students are asked to discuss in groups and find the ways to save this much of amount of money. And a lot of brainstorming it involves to make the student understand. And finally, when you can give this to students, they would actually come after a lot of discussion and brainstorming, they could actually come down to a point that they need to study the budget of the family to be able to understand where we are spending the money and what are the domains where which can save the money, and for how long should we save that money to have such a money in our piggy bank. Yeah, so I found this activity really nice, and this was something that we came up with. Few students did this, and they could include the visual representations using pie charts, and bar graphs also can be used. They can compare monthly budgets and all. So a lot of mathematics can be done in this. Another thing was the surprise party, and this we formulated for primary school. So, and we again put up a situation like your parents are working and you want to give a surprise wedding anniversary party to them. And, due to pandemic, we brought this into this thing. You learned to bake a cake and few new recipes you learned, and now you want to give surprise party. You have to do all sort of things. You have to decorate the house, bake a cake, prepare few dishes and get ready even. So how would you organize? So with this activity, definitely a lot of thinking goes into.
Sorry, Sneh, I'll have to really stop you at this point. We have to finish the presentations by 5:45. So
yeah, can I conclude?
Nice. Yeah, quick. Yeah, half a minute.
Yeah. So these are the last few slides were only just few examples that I was telling you, that these very small situations can be created where modeling can actually be taken place in the actual classrooms. And by doing all this, the conclusion that we draw is that designing and planning activities that are modeling oriented can make learning fun, and mathematics can be made as a subject of interest. Then effective lesson plans, including these MEAs and research and planned by the teachers, will generate cross-curriculum mapping and modeling in mathematics. These efforts will definitely make.
Sorry, Sneh. We are running out of time.
I am almost done. So,
yeah, sorry, we'll have to stop your presentation there.
No issues,
we have no time for questions.
Yeah.
It was very interesting, but thank you. We'll go on to the next presentation on MathsPad, an interacting tool. This presentation is by Anmol Mali, Charlotte Nelson, and Khan Muazza. So we welcome you to the presentation. Please start.
Thank you,
yeah.
Ma'am, I will be able to share if Sneh.
Yeah. Sneh, please, can you?
Yeah, I'm trying to unshare, but it is showing me new share option. It is not giving me the option to unshare.
Yeah, so sorry, you will have to end sharp in 11 or 12 minutes.
Okay, ma'am. Okay, good evening, everyone. Myself, Amoli Mali. And along with me today, Charlotte Nelson and Munazza Khan will be also presenting with me. So we are student teachers from KJ Somaya College of Education, Vidya Vihar. So as we all know that this pandemic has induced by COVID-19 has immense effect on our life, and it has also affected our educational system. Everything just went offline to online, and that too suddenly. And another thing is maths, as we all know that maths is an abstract subject. So making concepts clear to the student was another difficult task. Learning construction in online classroom was also challenging. So the National Education Policy 2020 talked about integration of technology in our classroom. And NCTM, that is National Council of Teachers in Mathematics, it suggested that technology integration can make math accessible to the students. They also talk about equity in the classroom. So there should be, so it is possible only if we make use of simple instructional tools available online, which are easily accessible in any search engine. So we found a tool, MathsPad, which was very helpful to teach students construction, which mostly for the primary level, because they are unaware about the basic tools. They have not done construction till yet. So for them, explaining construction online was a difficult task. So we focused on MathsPad. We tried to find out few researches about MathsPad, but we didn't found many. So the work or the research paper which we wrote was based on TPAC model, which talks about technological pedagogical content knowledge. So this model talks about that the teacher should be master in what she is teaching. The teacher should be master in the content in what she is teaching. The teacher should know how to motivate the student to get engaged into that content. And the teacher should know the use of such technological apps and the features which can be used in the classroom. So integrating all these points can make the teaching and learning effective. So the objective of our research was to study the perception of pre-service teachers towards the use of MathsPad in teaching mathematics. For that, we surveyed for the two research questions that were to know the perception of the pre-service teachers, but after using the MathsPad, what benefit they will get and what are the challenges they will face while teaching the students.
So, at the present, research was a qualitative study in which exploratory one-shot case study method was used. For this research, we had taken the sample as 20 pre-service teachers from the second year in a particular college of education. So the data was collected through the questionnaire using a Google form as a medium. In a Google form, we asked them the open-ended questions to know their perception about the use of MathsPad in teaching of mathematics. Yes, Amoli? Huh. Okay, so a workshop was conducted for student teacher of a particular college, and our aim of the workshop was to make them familiar with the digital tool of construction. Like for us, it's MathsPad. Firstly, what we have done a demonstration about the tabletop method, and then we asked them what are the difficulties they face while using the tabletop method. Then we have explained them the various features of MathsPad, and then we demonstrate the construction of angle and circle using the MathsPad. After explaining the students, we give them a small exercise to try out a few examples on their own, so that we can come to know that they are able to do it or not, or is there any difficulties they face while using it. And at last, we circulate the Google form.
So the data analysis. The transcripts that we obtained from the pre-service students were segregated and were put into different themes according to a research question. The first question was, what are the perception of pre-service teacher on the benefits of using MathsPad? The first theme was easy to use. 94% of the pre-service teachers said that this tool was very much easier to use. And the second was easy to understand. 82% of them said that the students will be able to understand while using this tool properly. Third was interesting. 71% of them said that the tool is interesting and attractive. And since there were different colors used in it, this can make it more interactive and engage them in learning. Second research question was, what according to pre-service teacher perception are the challenges faced in using MathsPad? First was network issue. 10% of them said that the network connection can lead to the lagging of the screen. The second was need practice. 35% of them said that there is need of practice before presenting, otherwise it would be time consuming. Third was difficult to handle in phones. 10% of them said that it will be difficult to handle this tool in phone, but it is much easier to handle it in laptop. So we come to a conclusion that the positive perspective of using MathsPad is it is easy to use, easy to understand, it is interesting. Whereas the challenges that one might face while using it is network issue, need of practice, difficulty in handling it while using phone. And since our research was done on a one-shot case study, the findings cannot be generalized to a larger population. Now, even before the pandemic, teaching mathematics was difficult. The teacher has to make the lecture interesting. But since the teacher and the students were in the same classroom, the teacher can read the environment and understand whether the student has understood the lecture or not. But during this online mode, the students are behind their phone and their cameras are off. So a teacher can't make out whether they have understood the lecture or not. So the teachers have started inculcating games and other methods to make the lectures more interesting. But when it comes to constructing, the experience should be hands-on. So while using MathSpad, we can get such experience. So it is necessary to make more more MathSpad, make awareness of MathSpad to more teachers in the near future.
Yes, so there are certain recommendations for teachers as well as in administrators. So for teachers, there should be a hands-on experience in using the tools, and this can be arranged by the IT teachers. Literature on the latest research based on MathPad should be available to the teachers. Refresher course for in-service teachers should be provided to improve the knowledge of digital tools. Teachers' handbook should be designed so as to give teacher an idea how to use MathSpad in teaching mathematics. IT textbook writers can have some interesting advanced feature of MathSpad for using it in higher classes. The recommendations for administrator are that the administrator can organize a workshop related to the digital tool for the teacher. Even they should motivate the teachers to inculcate digital tools in their classroom. And it should encourage teachers to write research paper on use of MathSpad and to study its impact on different aspects of interest, enjoyment, and attitude. Thank you so much.
Thank you.
Yeah, thank you all. It was a wonderful presentation. Unfortunately, we are lagging behind. So can we take one question? Does anybody have a question?
I want to ask a question. It's a good presentation. But when we already have, like if I take an example of Methigon, where I think the construction also can be done, and there are so many activities, so many other things can be done, then why we should go for MathSpad? Where I think you can only explain construction with that.
Shanta, can I just ask a brief question?
Yeah, sir, can they just answer this question? Then you can go ahead.
I don't know whether they are keeping quiet, so I don't know whether they're answering or not.
Does anybody want to answer that, or should we go ahead? Anmol?
Yes, ma'am. Actually, during our internship, we used tabletop method and we searched for few applications which would be easily available to every student. And actually, MathSpad, it gives the experience of using paper and pen, and it's also easy for teacher to explain the tools used, such as compass, where the students are not aware about this. The primary school students, they are not aware about this tools. They have not done construction before. So it's very simple, it's attractive, and for them to engage them into the activity, I think MathSpad is more better.
Yeah. Thanks, Anmol. Sir, please go ahead with your question.
No, my question is just out of the recommendations that you have suggested in your paper, have you implemented any one of them?
Yes, sir. We have arranged workshop on the same MathSpad tool. We have taught them to the pre-service teacher, to our sister college, and we have got a good response from them that
Good. No, that's all. I think.
Yeah.
Yeah.
Shanta, go ahead.
Yeah. Okay. Sorry, since we are running out of time. This is the last presentation that we will have by Mr. Prashanta Kumar Mahapatra. The topic is Art Integrated Learning in Maths at Middle Stage towards Enhancing Learning Outcomes. Sir, you have 12 minutes and then 3-4 minutes of questions. Please go ahead.
Thank you, madam. Madam, can I share my screen?
Please do. They have stopped screen sharing, so you should be able to do it.
Madam, is my screen visible now?
No. Now it is. Yeah.
So, good evening, everybody. At the very outset, I want to thank Professor Rana and all the team members for giving me an opportunity to present my research paper here. I am Prashant Kumar Mahapatra from Kendriya Vidyalaya Kandhamal. I have been a teacher of mathematics for 17 years in this Vidyalaya. And today I have taken a topic that is art integrated learning in mathematics at middle stage towards enhancing learning outcomes. What do these pictures tell us? Actually, as you can see, I had given a project to my students to make square root spirals. And generally, what happens, this is the normal way in which we do square root spirals. But as you can see, students, so moto, I had not given them any art form, but they designed in artistic way. As you can see here, they have designed these projects in a very impressive way. And I think this gave me an input to go for art integrated learning and do some research how art integrated learning becomes effective for the students. The abstract of my project designed to examine the effect of art integration on student learning. It was focused on student engagement, critical thinking. Also, it was focused on creative response of the students. Research was conducted with 82 participants from class 7 of our Vidyalaya only. Here, two sections.
You're not audible, sir.
Teachers observation, students assessment, and post-assessment survey. Improvement in student learning was seen by up to 19%.
We can't hear you, sir.
Yeah, I was just going to say that only. Prashant, your mic is not working properly. Please have a look.
I think, sir, he's not in the meeting now. Some internet issues.
Yeah, I think he must be having internet issue. Yeah.
Oh,
Ma'am, I am back. Actually, I was disconnected, I think. Sorry for the interruption. There was a connection issue, I think.
Yeah, please go ahead. Please go ahead.
Okay, I'm sharing my screen ahead again. Can you, ma'am, please tell me where I left? Had I given an input about the abstract?
Please share your screen so that we can tell you.
Yeah, sir.
Fourth slide.
Yeah, slide number 4. Yeah. Go ahead and a bit faster now.
Okay, sir. Thank you. Art integrated learning is a teaching learning model which is based on learning through the different art forms and learning with arts. It is a process where art becomes a medium of teaching and learning, and integration of arts makes learning really an integral part of teaching and learning process in a classroom. If we have art as the medium of or art at the center, learning by this method becomes holistic, joyful, and experiential. And as all of you know, this has been in the focus in NISTA modules nowadays. The rationale behind my study was that mathematics has so far been a very difficult subject for a majority of students, and they face a very much difficulty. And a lot of experiments are going on how to make it enjoyable. And I thought this would be a great opportunity to integrate art in my mathematics teaching so that it can be enjoyable for the students. Also, New Education Policy 2020 lays a great emphasis on art integrated learning. And from my personal experience, as I found while conducting PISA practice tests, Briggs math, and other some competitive examinations, I found that at least 50% students have a very low achievement of learning outcomes. Many students score well when it comes to test based on textbook, but they perform badly when some questions are out of box. So this made me to plan for a new method of teaching by inclusion of art in mathematics. Object is as the time is very less, I am skipping this. Limitations, actually this was limited to class 7 students of Kendra Vidyalaya or Kandamal. And although there are different art forms like visual and performing arts, this study concentrated upon visual art form only. Methodology, as I stated earlier, in the two sections, in one section I conducted the experiment, and in another section it was taken as a control group. And a total of 4 topics were selected from the textbook of mathematics, and those topics were taught in art integrated learning method in one section, and in traditional method in another section. And based upon the outcome, how students achieved, we arrived at a conclusion. These are the different topics that I had taken for the study. And now let me give some examples how I implemented this. All of you know that only painting that is famous in that is a famous art form which includes mathematical steps in them. And so these are a good source of teaching and learning mathematics. Concepts related to basic geometrical shapes, congruency, similarity, statistics, etc. can easily be learned by using these art forms. As you can see in the picture, I had given first with the help of my art teacher, actually I made the students do some only paintings, and then again I used those paintings to make deliver my lessons and make the students learn different subjects. Like I used it for congruency, I used it for similarity, I used it for teaching simple geometrical shapes, triangle, circle, and as you can see, statistics was also there, and I used it in making them learn statistical way of collecting data and interpreting data. These are some pictures how students are involved in art integrated learning, and they are enjoying it. Second example that I want to give, that find your friend. It was the name of the activity that I took here. Some paintings were made by students in the art class with the help of art teacher. Then I collected those paintings from the art teacher, and I made copies of them. Then I made some puzzles out of those. I wrote some algebraic expressions on the backside of those paintings, and I wrote some expressions so that they have equal value on one art, then another equal value on another art. In this way, I made some puzzles out of those, and I told my students, I gave instruction that find the value of expression on your card. They found the value of different expressions given on their card. Then they went for searching the same value from other students. And in this way, they moved around the class to know which are the expressions that give same value. And in this way, they assembled in a group, and again they unpuzzled it. And when they unpuzzled it, they found their own art being there in the unpuzzled set of algebraic expressions. So this was a very interesting activity for them. And in the interesting way, they could learn algebraic expressions and basic operations related to algebraic expressions. This is a coloring activity that I had given. Here you can take different, I have taken here some additions related calculations here. And I gave them to find the value. Then there are some inputs given on the side of the paper, how to color them. Suppose 2.7 and 8.7, what is the value of it? They find out. They will go for searching some of equal values. There are some additions in which they get equal values. So all those equal values will be colored in a single color. That is given in the side instruction is given there. So in this way, when they colored, they found it interesting, and with the coloring activity, they could learn here addition of. Also, there are different operations that can be taught here: addition, subtraction, of fraction, or maybe decimal, and all other things can be done here. This is another way in which we can teach area and perimeter. Very, very simple toy there, paper toy, and just a rectangular piece of paper was taken, and I folded it to make a cylinder. And after that, we can cut it to some smaller pieces of rectangles, and by that we can get this toy. Making this toy is not a very big task, a very simple one. And here we can give them to calculate the area and perimeter. Also, we can be taken. First, they calculate the area of the rectangular sheet. Then they go for calculating area of cylinder and the smaller pieces of rectangle. And by comparing them, they could have a very interesting way. In a very interesting way, they could find area and perimeter, and they could learn it in an interesting way. This is about some when I did the pre-assessment and post-assessment. This is the comparison, and in this I found that in the control group it increased by 6%, whereas in the experimental group it increased by 25%. Their learning attainment level. So overall 19% difference was there. So we can say that almost 19% improvement was seen when I used art integrated learning in the classes. And here I have taken some journal prompt, how they got involved. And you can see here how they responded to.
Mahavatra, please unmute yourself because there were noise coming. Unmute yourself.
We can't hear you.
They can't hear me?
No, I can hear you.
Yeah. Let me see if I can unmute. Yeah.
Okay, sir. Thank you, sir.
Go ahead.
Here we can see this and there. Students reflected in their journal about how art integrated learning made them feel, and the response was taken in a 5-point rating scale. And you can see here how excited they are when art was integrated in mathematics. And in this, there was a question I had given them. Do you think that art integrated learning has increased your critical and creative thinking? And 83% of students they said yes. So it was a good insight for me to go forward with art integrated learning. Conclusion: the outcome of the study suggests that art integrated learning in mathematics makes learning more meaningful, experiential, enjoyable, and creative, and invokes critical thinking, and hence enhances the attainment level of learning outcomes. In the study, a difference of 19% was found in the attainment level of learning outcomes, which indicates that if art integrated learning is made an integral component of mathematics classroom, then students will learn more without math phobia. So these are some of the references that I had taken. So thank you all. Thank you all for giving me a chance.
Thank you. That is really nice. Sir, can we spend 2 minutes just asking if there are any questions?
Yes, ma'am.
Yeah.
Sure.
Does the audience have any questions on this presentation?
May I ask a question?
Yeah, please, Richard.
Thank you. Mr. Prashant, do you think this art integrated learning is applicable for senior secondary school also?
I think it will be applicable, madam, because art is actually, as we see these art forms, we also as teachers, we become interested in watching all these things. So I think it will also help in senior secondary also, up to some, not all chapters, but a great deal of chapters can be taught, I think, in this method.
Okay, thank you.
I have a question. You said that when you asked the question, has it improved critical and creative reasoning? These are students of 7th standard. Would they be able to understand what the question means?
Madam, actually nowadays critical and creative thinking has been in the focus in particularly Kendra Vidyalaya, because India is going to have a PISA test in near future. It would have been completed till that, but it is forefront. So critical and creative thinking has been in the main focus, and we are laying focus on that, and we are giving practice work for the students. So definitely they could be able to respond, madam.
Okay, I think we can discuss this outside. I have a few, we have a few thoughts on this. So
Okay,
I think we'll end the session here. I want to remind all of us that we have a workshop at 6 o'clock, and then there is a talk on future inventors using mathematics. We have a session at 8:40 where the paper awards will be presented. So please join us for all these sessions. And yeah, so we'll end this session here. Sir,
thank you, madam.
Thank you all the paper presenters. It was wonderful.
Thank you, Shanta.
Yeah.
Thank you, Richa, for taking your time and efforts. Yeah. So we'll take a break and join at 6 o'clock for the next workshop. Thank you. Ah. Hello. Manjushri, you are there?
Yes, I'm there.
Okay. You want to share your screen? Then try.
Yes, please. I want people to bring 2 square papers and a pair of scissors. So that.
Okay, it's already 6 o'clock and you will stop by 7:15. Okay.
Yes, yes, I will do that.
So we come to the last workshop of the conference. That is on teaching math with origami, folding paper, unfolding math by Manjuri Dhume. So without wasting her time, I will ask her to start the workshop.
Okay. I would like people to actually get some paper so that this I plan on making this an interactive session where we will be folding something together. So could you all let me know if you have 2 square papers with you and a pen and or a pair of scissors? Just type in the chat. Once I know that people are ready, I will begin. Otherwise, it will be difficult to conduct the session. Just grab any paper and make it into a square. I'll wait for a minute or 2.
Yes, yes.
Yes. And as we participate in this, if the participants can actually show me what they are folding, then it will be even better.
Yes, according to the chat, Manjuri, you can ask the name and say that you share your.
Yes, I'll do that.
Okay.
Yes.
Yeah. So if you have 2 square papers with you to fold, please say yes in the chat box.
Yes, please. You just need 2 squares. They need not be colored. They could be white.
Okay. Some say yes, I have started coming.
Yes.
Manjari, this will be a good exercise. If you say that, take any paper and you make a square of it.
Okay, that is, yeah, actually.
Yeah, do it.
Yes, yes, yes. So let's take any paper. I'll do that. Take a piece of paper and cut a square from it. Alternatively, you can actually, take 2 squares. Yes. Okay. And if anyone can share how they cut out a square from any paper, that will be great. Thanks, Amita. You're ready. Thanks, Chitra. Thanks, Anaga. The rest of you, please, let's make this interactive. It's the last workshop. We have been listening to lots of presentations. Thanks, Rupali. We'll be doing something now in this session. Yes, thanks, Manohar. So I'll wait for 1 more minute. Thanks, Devidas. Thanks, Jitendra. The thing is, as I proceed, thank you, Ashok. Those who are not ready, it will be difficult for them to catch up. That's why it actually makes sense to wait a minute in the beginning and then start. Okay. So we can begin our, you tell me, sir, when I should begin. Should we begin? Please let me know, because I also want to make sure that we, complete what we have planned.
I think you have already started, na?
Yes, so let's begin. Okay.
So you already cut a square, so you have started paper folding.
Oh yes. Okay. So let us see. I just want to show you some pictures. Okay. I want to show you the joy that children derive from these activities and the learning we are all going to experience now. Yes. So these children are some of the students in the bottom row. They are learning about volume. The child in the center is telling me about fractions, and the one on the top, they are learning about triangles. Okay, as they fold, they are investigating and learning about triangles, and we'll see how to do that. But first, just a quick recap of why should we use origami to teach maths. So origami is it's a Japanese art. It's the art of paper folding, and gami means paper, ori means folding. So by folding paper, you make lots of objects. But as you fold, you can learn huge amount of geometry which is embedded inside these folds. So when children make these models, when they are playing with shapes, when they are exploring their properties, they learn a lot of geometry. And the best part is that paper is easily available, and the activities are also engaging. So it becomes a very easy way of teaching geometry. Origami can be used in many different ways for teaching maths, not just geometry, even other topics in maths. So one is that we actually use origami model as a teaching aid. And that is what we are going to focus in this workshop. The first and the second part. The second is that the folding process itself helps us to discover different geometry concepts. And you can use your knowledge of maths to design origami. That is, going to the next level. Let us first use origami as a teaching aid. So we are going to make a teaching aid now. And I call it as a 4x4 puzzle. It's a very simple teaching aid. And to show you how to do it, I would like to pin my screen. So I'll stop sharing. And I'll just pin my screen so that you all can see what I'm doing. Yes. So I want all of you to take a piece of paper and fold it in half like this. Just fold it in half. Once this is done, you have to open it. Yes. What I'm going to do is, as I fold, I'm just going to mark on all the places where I fold, so that it becomes easy for you to see what I'm doing. Like this was the place where I folded. And I would like all of you also to do this with me. That after you fold and you open it, just take a pen and highlight the place where you have folded. After this, what you have to do is, I'm going to show it like this, but please do it on the table. That's what I tell all children. Please fold it like this in quarters. Okay. So you're going to fold from the top as well as from the bottom. Yeah, I'm going to keep it on the table and do it and just hold it up. So it's going to look like this now. Okay. I'm going to just highlight these folds. This is what I've done. Actually, exploration can begin here. Okay, all teachers, we can just start asking questions, but let's hold. Okay, let's finish making the teaching aid first. Are you all ready till here? Shall I proceed? Just say yes in the chat so that I know that I can go ahead. This is quite, yes, thanks, Rebecca. Yes. So now what you have to do is, now you rotate the paper so that all the folds that you have made, which were horizontal, are now vertical. And then you're just going to repeat what we did, meaning you're going to fold in half. Then you're going to open it and then again fold in quarters like this. Okay. So exactly what you did before, so that you get a 4x4 grid. And then I'm going to highlight this so that, you know, you can see this. We have made a 4x4 grid. Just let me know once you are through, so that there's a very small part now left for making the learning aid. So done. Have you made the 4x4? Shall we proceed? Okay, thank you. Now what you have to do is, you have to make a single cut. The cut is from this to this center. Okay, along the middle line from the bottom till the center of the square. Just cut it out. I just took a scissors and I kind of cut it this way. So now you have this, you have it can move in many different ways now. You can fold it in many different ways. And your teaching aid or learning aid is ready. Yes. Done? Okay. So we are now ready for using this to teach lots of concepts. And let us start by solving the puzzles. Okay. So what I'm going to do now is, I'm going to remove my pin and I'm going to remove the spotlight also. And I'm going to come here. Yes. Here we are. And we are ready with the first puzzle. Okay, I want you to take any one side, this or this, and just fold it up. Now the question is, so this becomes like an L, isn't it? The question is, what fraction of this shape is colored? I want the answers in the chat. Yes. What fraction of this shape is colored? Okay. When you ask this to students, you are also going to ask them, can you please justify your answer? Yes. Can you explain why you said what you said? So who would like to explain? Say for example, yes, Mr. Bharat. Could you explain why you are saying what you're saying? You please unmute yourself. Sir, everybody can unmute themselves, right?
Yeah.
Yes. So anybody who wants to explain their answer, please unmute and explain. Yes. The correct answer is yes. What is it? How do we do it? Okay. So let me just take you to the correct answer. The correct answer is 4/12, which is the same as 1/3. And why? Because when we say fraction, we say take the total number of parts, put them in the denominator. And then what's the question? What fraction is colored? So how many squares are colored? There are 4 squares colored. 4 out of 12. So 4 out of 12 are now colored, right? Can you see how powerful this is and how simple this is? It is amazing. It is amazing how engaged children are when they learn with this. Okay. Okay, now we'll just play a little more. Okay. Now can you tell me what fraction of this shape is colored? What I have shown on the screen. Yes. Tell me what fraction of this is colored. Please write the answers in the chat. And anyone, please feel free to just unmute and tell the answer. Yes, Anaga, would you like to explain? Let's have other voices also. Yes, please. Your answer is correct. Yes, Anaga. Or Ashok, who would like to answer? What fraction is colored now?
Yes, ma'am.
Yes.
Hello.
Yes, tell.
This will be 2 upon 14.
Yes, and why 2 upon 14? Correct.
Because total number of squares is 14.
Yes.
And in that 2 is colored.
Yes, perfect. Thank you. Thank you. So, can you see this? A simple tool like this, and we can ask what is the fraction color. So, what happens is the core meaning of fraction in these 2 puzzles, the total number of squares have changed. First they were 12, now they are 14. But still, so the child has to understand that the denominator is going to change. The numerator, of course, is changing, but the denominator is also changing, right? So, so that is the power of this. Now let's look at one more. Okay, what fraction of this shape is colored? And now you have to explain it in different ways. Yes, Pushpanjali, correct. Now can you tell me what's the answer? What fraction is colored? Come on, I want all of you to take this to school, to your nieces, to your small kids, and make them play with this puzzle. Yes, 4 upon 12. Correct. Now, you know, when I ask this to children, yes, Bharat, they tell me and explain. When I say, okay, explain, they will explain in many different ways. Okay, Bharat, could you explain it? Your answers are correct. Yes.
Total parts are 3.
Yes.
Out of 3, 1 will be color.
Correct. So you see, different people see different things. While we see 12, Bharat is seeing 3 columns. Okay, and in these 3 columns, 1 column is colored and 2 columns are white. So out of 3, 1 is colored. Yes. So although the puzzle is the same, children, when we are writing sums on the board, children look at it in a different way because each of us perceives and gives importance to different things. Anyways, so we will now proceed with the puzzle. This is the correct answer. And now I'm just going to take it here. What fraction of this shape is colored? Now what fraction of this shape is colored? Yes. Two upon 10. Yes. Nice. Now I'll ask you another question. Okay. Can you show 1/5 color in another way? Can you all show 1/5 of this of the shape colored in another way? This is one way. Can you show it in another way? Somebody please show your video. Do it and show. So you are still going to show 1/5 only, but in another way. Who would like to share this? Come on. Just play with the puzzle. Show 1/5 in another way. Come on, try. I know most of you will get it. Don't feel shy. Please share your screen and show, or share your video. Can you, I'll give a hint. Like, I'm going to fold this further.
Ma'am, may I try?
Yes, please. Go ahead.
But mine is not a colored paper. It's just
just put a cross.
Yeah, it's something like this.
Who is this? Can you please put on your video?
Yeah, the video is on.
Can I show you?
Yes, please show it. Why am I not able to see? Is it my network issue?
I don't know whether you're able to see me.
I'm not able to see. Should I stop sharing? Okay. Yeah, now I can see. Yes. Yes, sir. Please, can you hold it a bit high? Rebecca?
Yes, ma'am. Something
Okay.
like this.
Yes. So this is okay.
Oh, 1 minute, 1 minute. It is like this. This is the way.
Sure. Maybe I'll pin you. Is it Mr. Ashok? I'll pin you, sir.
Yes.
1 minute.
Yeah.
Whom have I pinned?
2 out of 10.
2 out of 10. Correct. Now, can you show this in another way? It will still be like 1/5, but it will not be 2 out of 10. Rebecca Thomas, you were showing something.
Yes, ma'am.
Can you
So this was what I was trying to show.
Okay, so now you have how many? 10. Achha, so you have folded it in a different way, right?
Yes, ma'am.
Yes. Now I have a question. Can you have only a different denominator? Not 10. Make a different denominator. We want 1 out of 5. Try. It should still be 1 out of 5. I have to unpin now. Okay. Yes. Anyone? Anyone would like to try? How about this?
Yeah, can I show you?
Yes, please. I will remove pin. Who is showing?
Ashok.
Yes. Yes. Just hold it a bit higher up. So now this is how much?
4. It is not.
No, it is not 10. It's not a multiple of 5. Yes.
Okay.
Yes, yes,
Sorry.
yes.
Yeah.
No problem. Keep trying. Yes. Anybody else? Please. Okay. So I am now showing only 5. Okay. And out of those 5, 1 is colored. So this is also 1/5, right? 2 upon 10 is 1/5. 1 upon 5 is also 1/5. So there are many things that you can do with this puzzle, okay, or with this learning aid. Let's go a bit. I want to make sure that I take some more things also. So we'll go a bit faster now. Yes. Can you all see my presentation now?
Yes.
Okay, thank you. Now what we are going to do is, I had some more questions. Okay, But I'm now going to ask you this question. Can you fold this paper so that half of the shape is colored? Come on. This is very easy. Please. Can you show and fold it in different ways? Okay. So that half is colored. And please share your video. This is the paper. Half of it should be colored. Yes. And then maybe you can just tell me the numerator and denominator if you don't want to show.
Oh, ma'am, 4/8. That's exactly half of it.
Yes, yes, nice, Rebecca. 4/8. Yes, thank you. So you did like this. Anyone else? In fact, what happens, you know, Rebecca, when I do this in the school, no, then they will say, ma'am, 4/8. Then they'll say, ma'am, 3/6. Ma'am, 2/4. Ma'am, 1/2. So they suddenly, you know, get a hang of it. And that really makes us happy. Okay. So, so although what is happening over here is we are changing the size of the big shape itself, but if you just look at it as a fraction, it is the same amount as a percentage, right? So this brings us to the next question, that if we are doing this for higher standards, we can even ask questions like this. Okay. We can even ask area and perimeter. We can ask percentages. Like we can say, can you show 25% of this shape being colored? Now, my slide is saying area perimeter, but this was the point I was trying to make, that you can then move on from fractions to percentages, from percentages to, you know, ratio. Like, for example, can you tell, like, okay, this group, what is the ratio of colored part to white part? Yes, please. What is the ratio of colored part to white part in this figure? Please put in the chat.
4/5.
Yes, correct. 5:9, right? And what is the, so what happens is, even though this is a simple tool, it can be used for explaining concepts like fractions, percentages, ratio. We can even use this for area and perimeter. Okay, so I use this in the classroom for all these different topics. And all the teachers who have experienced this also use it that way. So I invite all of you to please use this learning aid in the classroom. So this is where origami is used as a teaching aid. Okay. Like, although this is just a teaching aid, we can also use the process of folding to discover geometry. Okay, so I'm in the, you know, because we have limited amount of time, I'm just going to move on to the next model. Okay, this is a challenge. Okay, this challenge is that, can you fold a square, okay, in a shape of a triangle so that its area is half? So you have to fold the shape so that its area becomes half. Why don't you take this one only and just fold it so that the area of this becomes half and the outline is a triangle. It should be a triangle. That's first challenge. Second challenge is you can just make it into a square. Yes. Participants, please share. I just want the area to be half. Okay. And who would like? Yes, Bharat, diagonal. Correct. So if you make it into a diagonal, you get the yeah, let me just do that.
Triangle.
So yes, you get the triangle. Correct. Now suppose you want a square, what will you do? So this is a triangle. Okay, my folding is not accurate now because I'm doing it in the air. Okay. Suppose we wanted a square, then any ideas? Huh. The end result should be a square and the area should be half of the original area.
Fold it up as well as from the left to the right, from across the midpoints of each side.
Come again. Could you show it?
Ma'am, is it from the triangle or from the main?
From this. It is
main
from
one?
this. Yeah.
Yes, ma'am. So it's basically you fold it 4 times.
I can show you.
Huh. So Rebecca, one challenge. Huh? If you do it like this, no, its area becomes 1/4.
Oh yeah.
I can show you.
Yes, sir. Sure. I'll stop spotlighting so that we can see you. Yeah. Yes. We're not able to see. Is it only me or what? Yeah. Yes. So what you have done is you have brought all these corners to the center, right?
Correct.
Perfect. Yes. Thank you. Thank you. Yes. Now the challenge number 3. Then now the third one is very, very simple. Huh? Third challenge is make it into a rectangle. Who will do that? Come on. How, Amita? Fold all the sides. Can you show? Please show. Yes. Who is going to show?
Sorry, it can't be. I just made it 1/4 of it. Yeah.
Yes, no problem. Try. Please try. Make it into a rectangle. Rectangle is very easy. We also have lots of
Hold it at the.
Fold it along one set of squares.
Yeah.
So even if we fold it like this, okay, it's a rectangle, right?
Yes.
Yeah.
Right.
So that is like very simple. Okay. Yes. Remove all pinned videos. Okay. So this. Now next. Okay. Now I want to fold this, open it. We want to make it into a pentagon. Can we do that? I'll give a hint. Okay. It's not a regular pentagon. It is an irregular pentagon. Can you fold this to make a pentagon? Try. Fold the square to make a pentagon, which is half the size of the original square. So, yes. It's a combination of the folds that you used for making the square and the rectangle. Anyone? Yes, Anaga. Show.
Fold like this.
Yes. Correct.
Yeah, fold along the triangle edges and then fold along one set of squares.
Yes, perfect. Thank you, Anaga. That's correct. So what happens is when we say like that it is a pentagon, first everybody thinks that it must be a regular pentagon. So you have to give that hint. Okay. Now,
the one thing I want to say here is it is nice because the area visualization is a little different here and it requires a little bit of thinking for the children. It's a very good thought process there, right? So that's
yes, that's right. Okay. So basically we are making, okay. Now the next question, Anaga, and all of you. Once children say this, like even if they say triangle, okay, just fold it along the diagonal. The question that I ask is, how do you know that it is half? How do you know that it is half? Okay, so the fact that when you are overlapping these, okay, it is covering it exactly. That is why whatever is on one side is on the other side, and all if you open it becomes a square, so it is half. Okay, so this thinking is very different. It is very different from the formula thinking that our children are getting used to. Okay, so that is why this is very powerful. Now there are two more challenges in this. I leave this to you and we will move on to the next model. The two challenges are, make this into a parallelogram which is not a rectangle or a square. Okay, but now I'm going to like leave it as a challenge for all of you, and we'll move on. Till now what we have done is we have made a teaching tool and we have been using that teaching tool, okay, for reviewing different concepts. Now what we are going to do is we are going to actually do some folding, and in the process of folding and unfolding, we want to discover some geometry. So I invite all of you to take the second square that you have with you, and I'm going to run a very small video which will take you through the steps of folding. And then we will discover the geometry. Just give me 1 minute. Yeah. Can you all see this discovering geometry video?
Yeah.
Yes. In this video, we will look at a puzzle. Take a square paper and first fold it in half. I would like all of you to, once you unfold it, I would like you to mark out the place where you fold it so that you can see it. Okay, it becomes easier that way. That's all, no other reason. Okay, the next folding becomes easier. But if your paper is crisp and there is enough light, then we can move on. And now you have to fold it in such a way that this vertex lies on this crease and the angle starts from this vertex. Let me show you how. What I do is I just lift this and start sliding it along the center line and checking if the angle starts right from the vertex. I take it up till it matches and the fold starts from this vertex and then fold it. I'm going to pause here so that, I'll wait till you all finish this. Just please type in the chat once you have finished, okay? Okay, thanks, Rajni. Thanks, Parul. We'll wait a bit because, thanks Manoj. Yes, Anaga, thanks. Thanks, Ashok. Once I get a few more done, we will continue. Thanks, Rebecca. Yes. Thanks, Jitendra. Thanks, Devitas. Shall I move ahead? Yes, Meghana, Chitra. Thank you. Shall I move ahead? Yes, Amita. Pushpanjali. Yes, good. So next couple of folds are very easy. Okay. Now there are just 2 more folds. Fold this edge to meet this edge. Now fold along this border. Now open the model and mark out all the lines in bold using a pen. The puzzle is, wait. So I'm just going to pause this here, okay, so that you all get the time to actually trace out all the places where you have folded. There are only 4 places where we have folded, okay. So there are only 4 lines, and keep it so that it looks like an A. And then what I do is in the school, I actually mark out all the points, the intersection points, the vertices with letters. Okay. So I go cyclically, I go clockwise, starting with A, B, C, D. So what I'm going to do now is I'm going to share my presentation, which shows the marking done. This is how your model will look. Please let me know once you are done. This is a very powerful lesson for children to understand angles and to understand properties of triangles, parallel lines. There are many things that you can review. This is an application of many concepts which are taught in 6th, 7th, or even 8th standard. I use this for 7th and 8th standard school curriculum. It can even be used with younger children. But for them, we actually make them measure the angles. Whereas for the older children, we tell them, okay, you have to reason out the angles. Okay. Please let me know once you have finished. Thanks, Manohar. So that I can continue. Yes, thanks. Okay. Thanks, Meghana. Thanks, Ashok. Okay. So it is just going clockwise. The left top corner is A, then B, C, D, E, F, G. Okay. So now let us see. We have made 4 folds and then unfolded it. Now we are going to discover the geometry. We'll start with something very simple. Okay. Like how many 90 degrees or right angles can you see? Rather than which ones, can you tell me how many right angles can you see in the fold that in the open paper that we have made now? For students, we have to tell them like, can you name the angles? They can even show them. That is perfectly fine. So anyone can please answer this so that we can move ahead. How many 90 degrees are there? Yes, Bharat, thank you. So there are 8 90 degrees. Yes, 4 corners of the square, and then we have made this. This is a perpendicular bisector. So these are the 8. Okay. Now comes the interesting part. Okay. Now you have to ask the children, and all of us will also do this. What do you notice about the 3 angles that are formed at point B? Anyone? Please. What I would like you to do is I would like you to actually do some folding and investigate. Okay. What do you notice about the 3 angles that are formed over here? Okay, Amita, you're saying that their sum is 180. Correct. Perfect. What can you say about each of those angles? How do they relate to each other? Linear pair. Okay. I want to know. Yes.
They're on a straight line. They're
all on a straight line. Yes. Anything else? Yes, Ashok. How did you say that? Can you explain? I would like you to show it. Yes. So Ashok says each of them is 60. Can you prove? Your answer is correct. Yes. So this is where the folding process has to be like, you can fold and show.
Yeah. Yes.
Yes, Amita. They are congruent. Yes.
Yes, when we fold it, they fix on each other. My
Yeah.
my camera is not working. So I cannot.
Okay. So I'll show it. Okay, see this.
Two edges are meeting.
Correct.
2 edges meet properly, so they are all equal angle.
Correct. The edges meet, so they have to be equal. So children have to notice this, that when you're folding and when they overlap exactly, it means that the angles are equal. Okay. What is the meaning of angle? That itself is something that many children have difficulty understanding. Okay, thank you.
Thank you.
Yes.
Same idea. Tikka.
So because they are, okay, so this is the answer, that they are all equal to each other. Yes. And that is because when you fold them, you can see that they overlap exactly. Yes. Perfect. Okay. Now that we have got this angle as 60 and the other angles also as 60, now we can take them through, what is the measure of this angle, AGP, where they will have to use some properties that they have learned. Anyone can tell the answer so that we can move ahead. Please. What is the measure of angle AGB?
30 degrees.
Yes, because of the angle sum property of a triangle. Perfect. Now that we know that it is 30, can you find out what is the measure of this angle? No measurement, you have to reason it out. We want this angle BGE. What is the measure of angle BGE? And how will you find? BGE. Again, you have to justify. BGE. No, try again. Here you have to use exactly the same technique that was used for 60 degrees. I've given you a hint now. Come on. No, Anagha. No. So what will you do now? How will you reason it out? See these three angles over here, 30 and this, okay? That is FGE and EGB. Just fold the paper and see what happens.
They are equal.
Yes, which two are equal?
FGE and EGB.
Yes, when you fold it, you can see that the edges exactly coincide, right? And these three angles form 180. One of them is 30.
So 75 degrees.
Yes, perfect. So we can discover this by folding and checking that the angles are equal. Right on the top, we got 360 degrees. Over here, we got 275 degrees. Right? So here it is. Okay. Now the challenge is to figure out what are the rest of the angles. Okay. The rest of the angles are not difficult at all now. Like we have most of the angles over here. What will this angle be? Now
15 degrees.
15 degrees. Perfect. Angle sum property. Right. What will this angle? Now this is interesting. Again, you can use a bit of folding now. Fold this corner. Just fold this corner, everyone, and see what happens. What do you discover?
One angle is perhaps twice the other angle.
One angle is twice the other angle.
No, angle BEG coincides with angle GEF and BEC, both.
Correct, together, right?
Yes. So that is 45 degree and rest one is 30.
Yes, correct. So you see, what has happened is, I just want to tell you all, we just took one square paper, okay? We made 4 folds on it. But we could revise so much of geometry. We could do a lot of reasoning, critical thinking, isn't it? And we recapped the properties of angles of a triangle. And if you want, you can even look at parallel lines and transversal over here. Anything else that you notice? I use this for many more concepts, but I want it to come from you now. Please tell me, what else can you ask children in this? Now, almost all angles are done. Yes, please. What else can we ask?
What type of triangle is this?
Yes, what type of triangle is this? So we can say find all right angle triangles, or we can anybody see can anyone see a equilateral triangle here? Can you search for it? An equilateral triangle.
Ma'am, the upper part B and the half of that HD, what comes in between?
Yes, the intersection, because those are parallel, right? So it has to be an equilateral triangle. You see, you can ask them, can you search for quadrilaterals? Like, can you see trapeziums here? Can you see, there are so many things that you can, use this for. And
congruent triangles, I mean,
yes.
60, 90, 30.
Yes, 30, 60, 90. So similar triangles. Okay, which triangles are similar? You can ask. Okay, and why are they similar? So you can just overlap one on the other. You can ask them to cut it out. So this exploration with a simple piece of paper becomes very, very effective. Okay, and this is what I wanted to share with the group. here are all the other angles also. I think the 30 degrees is not yet written over there. But we also use this for, you know, quadrilaterals. Yes, trapeziums. Yes, you can ask them where are the trapezium. And then like every time you have to say, why are you saying it's a trapezium? Can you explain? They have to tell you why they think it's a trapezium. So then it comes to properties of trapezium, right? So is there something? Yeah. Okay. So this was the second model that I wanted to share with the group. And actually, as LearnQuest, we conduct many such activities, and we have like a curriculum that is built with paper folding activities for standard 6, 7, 8. And these are the different concepts that are covered. I just wanted to share this with all of you so that you can, like, if there is also one sample activity, what I would like to do is I would like to take you to the website and show an activity which you should all please try out and ask your children to also. 1 minute, I'll just take you there. Give me a minute. I'll stop sharing this. I'll share my screen. Yes, so this is the LearnQuest website, and on the website, if you go to programs for schools, there is origami and maths. Okay, so over here this is what I showed you just now. Like this is, I don't know whether you can see this window which popped up, but over here there is a sample activity, and you can actually go and try out this activity. This is an activity in which I think it's opening in a new window, so you all will not be able to see it, but it is to make a spinning top. Okay, it is free, so anyone, all of you can actually go and try this activity, where let me just take you a bit to the next part. And yeah, so in this activity what they do is they actually make a spinning top. This activity, you're going to make a spinning top, and you're going to discover different triangles and angles that you've learned in your maths class. For this activity, you will need 7 squares. So because it needs 7 squares, this is not a good activity to do in a workshop because it needs too much effort. But please do use this activity with your children, or you could try it out yourself. These are some there are some resources online, like these are some links for people who have written lesson plans. Okay, and you can use these lesson plans if you know how to do folding, then use these lesson plans to teach different concepts. Okay, and there is a good book by Dr. Thomas Hull, and this is on Project Origami. So this book is just full of activities to be done in a classroom for exploring geometry using paper folding. And this is at a very high level, like it is for college level also. So please explore these. It need not be just for basic concepts, but he goes on to college level maths as well. So actually this was what I had planned to share with everyone. I'll be happy to take any question answers from all of you. I'm going to stop so that I can listen to you, or we can have discussions.
Yeah, if you have any questions to ask or comments to make, please go ahead. Or you want to discuss something? Hello. Good evening.
Yes, Chitra, you have something. Please unmute yourself and talk. We'll be happy to have a discussion. So, thank you. So what we actually do is just to share what we do in the classroom is we have made series of lessons like this, and what you will see that the spinning top lesson, that is a self-paced lesson, means children can do it. There is a, since it's in the Google form, they will answer the questions, they will move forward, they will understand the answers, okay, and carry on from there. So they will do something and they will learn in the process. Normally these lessons take around 40 to 50 minutes, okay. So most of these are one classroom kind of sessions, and you can definitely finish it in one period. As long as children have the paper ready, it is like it is something that really works well. Any questions?
Hello, ma'am.
Yes.
I'm Amita.
Yes.
Will there be more lessons on your LearnQuest site?
Yes, you see, there is a inquiry kind of page over there. Please write your details. We will get back to you because we have lots of lessons. Yes.
Okay. Thank you so much.
Yes, welcome. So anyone who is interested, please do contact us.
Manjuri, can you write your email in the chat box?
Yes, yes, I will do that. And you can also write to learnquestk@gmail.com. Both these email IDs, we will be happy to, let you know the lessons and share it with your schools.
No more questions? Or yeah, question is, can we engage students in class with this activity? Manjuri.
Yes, yes, sure. In fact, the engagement level is so high that they want more. Okay, if you look at the photos, and then we also do projects with this. Like you can do one part today. So, see, there is something called as modular origami, in which you have multiple pieces which you put together. So you could just make one piece in one session and then another piece and get children to assemble it together. So that way it becomes a good project also for children. There are many ways in which we use this. Say, for example, if I'll just give a simple example. So I teach how to make an envelope. Okay. So this is a paper folded envelope. Maybe I'll just pin myself so that I can make it easy for everyone. Yeah. So this is an envelope which I have made by paper folding. Okay. Now the question. So this actually becomes a website place. Yes, yes. I'll just put it on the website. See, what happens is, suppose you fold an envelope. The question is, you have to say, okay, I want to put a 100-rupee note that will fit exactly into the envelope. Then what should be the size of the paper? So these activities, they are not just for teaching, some model, but they make children think. You can make them do proportional thinking with this. See, open the model and then see, okay, if this is the length and this is the width, this is the size of the envelope. So if I want to put a 100-rupee note, then what should be the size of the paper? So like this, there are lots of applications. I remember yesterday there was a workshop where a sir was telling that, it is better if we start with the problem and then teach them, the maths, how maths can be used to solve it. So these are all application related. Like you teach them how to make a box, and then you say, okay, now I want to put this tape in the box. What should be the size of the paper? Or how will you fold? Because the folding method is now known and they work backwards. So actually it is very interesting to make children think this way, and they also enjoy it.
Yes, they are enjoying it in the class, and I tried it also.
Oh, yes. Who is this, please? Can you please share?
Yes, I'm TGT Maths from Kendriya Vidyalaya.
Okay, okay. You use paper folding?
Yes, I used paper folding, and also I taught students how to find the volume of cylinder using paper folding.
Okay.
And many other things also.
Okay.
And I liked the way you shared.
Oh, thank you. Actually, I would like to thank Dr. Inder, Dr. Rana for giving me the opportunity to present this in this conference. I am really grateful for them. Because my purpose is to share this. There is one more thing. So many a times what happens is the limitation is, okay, teachers say we don't know how to fold. Okay. But that is why I have made these lessons where there are videos. Now technology is helping, where the videos show how to fold. They will ask the question and the teachers can take the answers and ask even more questions. So even if the teacher does not know how to do paper folding, it is okay because it is all there in the video. And that can be projected in the classroom and children can watch that. And trust me, children help each other. I mean, even if the teacher doesn't know, there will be some children who get it and they will teach each other, and the class proceeds. So one thing is, we always tell children, please help another. If you know how to fold and get it, help someone else also. Indices rule. Okay, so half again, is it? Ma'am, Meghana ma'am, you use it to teach indices.
Yes, ma'am.
Yes. Number of
I also
pieces.
use
yes.
For indices rule, I also use this in my school.
Okay. Thanks. Yes, we have activities for indices also. Exponents. Yes. I mean, some of these I have lots of, maybe I should share my YouTube link, because I have made many videos and uploaded them on the YouTube channel. Maybe I will just send the link of my YouTube channel here, so that people can just go and use the videos over there. Just give me a minute.
You can let us know your channel name also. That also we can find.
LearnQuest.
Yes.
Just type LearnQuest.
Okay.
I was trying to get the link. LearnQuest.co.in. That's the name of my website. Over there, you will get a link for the this thing also, YouTube channel
also. If there are no more questions, suggestions, queries for Manjushri, then we would like to thank her for the interesting session and coming over to the platform and sharing her ideas with us. So thank you, Manjushri.
Thank you, sir.
Yeah.
Thank you.
Okay.
Yes.
So the next lecture is it's at Let me just.
7:30.
7:30. So it's about 20 minutes by Professor Po Shen Lo. He is from USA. So it will be early morning there. He's trying to get ready. And the title is Developing Future Inventors Using Mathematics. So very interesting idea. So let us join at 7:30 in case you want to have something, a quick bite. So break for 20 minutes. We come back. Please. Thank you.
Thank you.
Infinity.
Mr. Square, are you all right?
I got stuck in
Can you hear me?
one place, so I was thinking that
Apostle, are you okay?
What's the matter with it?
It's gravity. He must return, and soon. What's happening?
Oh, it's just a little war. The X-axis is attacking us. Savages.
Everything's black. I can't see.
Our time is up, my friend. I have to send you back. Good luck teaching the gospel of 3D.
No, please don't send me back. I can't bear to
Hey,
go
Square.
back.
I'm afraid I won't be answering any calls from Flatland for the next 1,000 years.
Did I save my world?
Shh. Ignorance is bliss.
No, please don't send me back. Oh no. Oh no. Oh no. No! No! No!
Let's go, Daddy! New Year's! It's the new millennium! Come, let's do the proclamation! Hurry!
Whereas the states have been troubled by ill-intentioned persons pretending to have received revelations of 3 dimensions every 1,000 years since time began, it has been unanimously resolved by the Grand Council that on the first day of each millennium, all such apostles of the 3 dimensions shall be imprisoned and executed 3 days hence.
Tell your mother I'll be back. Tell her I had to go see your Uncle B. Dead. Oh, dead.
Who goes there?
I'm A Square, attorney at law, here to see my client B Square. Allow me to pass.
No
in the name
one
of the
is
law.
allowed in. Get out of here, you pest.
A Square! A!
Mrs. B,
A Square!
are you okay?
A! Children, say hello to your uncle.
Hello, children.
Children, go play off to the side. They won't tell me what the charges are. They won't let me in. What's going on,
I
eh?
need to get in there. I have to talk to your husband. Can you distract the guard?
You bet your south side.
Look out! Look out! A woman!
Watch it, buddy. Hey! Oh, Mr. Suicide, what are you doing in here?
I'm here to see my client, B Square. Allow me to pass in the name of the law.
Law? What law? I was sworn to protect the law, the Constitution. They tore it into pieces yesterday. I'm a soldier. They have me guarding a bunch of civilians. I should be in battle.
He's my brother.
Brother, huh?
Yes, sir.
5 minutes.
How did you know I was here?
I saw it. I saw what happened. I saw them arrest you.
What? You dreamed it? Had a vision or something?
No, I was there. Sort of. I was in Spaceland looking down onto Flatland and saw President Circle arresting you. He had no right. I can get you off. I know I can. All I have to do is explain to them that up, up, not northward, but up, above, on top of. They'll understand then. I should have remembered all of the words, but I was distracted and beside myself. I was sick, but listen, B, there's another dimension. There's a 3rd dimension, and I'm here to spread the word.
What? Are you mad? You're a monster! You're gonna get us all killed! Where do you die?
Infinite in the one. The infinite be the truth of existence. It is, and there is no other besides of the infinite in the one. The infinite be the truth of existence. It is, and there is no other besides it. The cloudland of metaphysics, the universe, from the cloudland of metaphysics, the unity that exists.
Thus speaks the monarch of Pointland.
That final
Hello, Professor Low. Are you here? Okay.
Hello, Professor Poshan.
Yeah, I guess he's in the meeting, and
Okay.
he'll be joining soon. He's trying to join with some other device, maybe, I don't know. He has written in the chat that.
Okay. Yeah, I think he is in joined with an PM. I think that is his PSLL monitor.
Yeah.
Yeah. Ocean Lay monitor.
Let's wait for 1 or 2 minutes.
Hello, Professor Poshan. Is he having problem with connecting or?
Yeah, maybe.
He is in the meeting.
Right.
Soumya, would you like to circulate feedback form last time?
Yeah, sure. I'll do that in the meantime. Yeah, I request everyone to please fill up this feedback form. I'm going to paste it in on YouTube also.
Okay, fine. No, we thought you are in the meeting and that is the issue probably. Okay, yeah, sure. Please. No problem. Yeah. Take care. Just got.
Is there some update?
Yeah, got a hello.
Yes.
So he said he'll be joining. There was a technical issue on his side.
I see.
So he's joining soon on another device.
Yeah, okay. Fine. We wait.
Yeah.
Hello. I think I'm finally connected.
Hello.
May I ask,
Welcome. Good morning.
Hear me? Is everything working?
Yeah, we can see. We can hear you.
Terrific.
Yeah. Your video is off, right?
No, actually, the video is on now. There's the yes, you found it.
Okay.
Your audio is very weak. Is it possible to increase your volume, input volume?
Is this any better?
Yes. Now it's fine.
Okay. I just turned it to maximum.
only your, okay, so let me formally welcome you. Okay, right. So we are, I think let me give a very short introduction to you. Professor Poshan Law. I'm pronouncing your name okay? I don't know. He is professor at Carnegie Mellon University, Pennsylvania, USA. I think you should go to his website and homepage and see what all he has achieved. So because we are already a bit slightly behind schedule, so I will ask him to start his talk on developing future innovators using mathematics. Please.
Great. Hello, everybody. Nice to meet all of you. And I have to say, it's a real pleasure to be able to talk to all of you because the work that I'm interested in doing spans across different parts of the world. And I will say that I've always had a very strong respect for the work that many people do in India. And so welcome everybody. Apologies for being late. It's the time is different over here. I mean, there's a time difference over here into the United States. And actually there are some small innovations that I was trying to roll out where we were just working on some of the technology over the last week. And I wanted to make sure this could be on, in fact, in this particular talk. Great. So the thing I want to discuss is actually about the concept of innovation. Because if you think about it, what's the point of education? What we sometimes think of teaching as trying to have people learn skills and then to be able to follow those skills if they see the same problem again. But I think what we have seen in the past 2 years with this COVID pandemic, and really if you think about it, every 5 years or so, you see there's a big change in the world. And so actually what we want our next generation to be able to do is to be able to innovate, is to be able to come up with a new solution. And that makes us think a little bit about whether or not we should be trying to do our education in a slightly different way. By the way, something to make this talk hopefully a little bit more fun. I'm not sure if you noticed, but this Zoom has a funny thing now. We have added a new thing to this Zoom. So if you actually type anything into the chat, it actually will just appear and everyone will be able to see it more easily than if it's just in a chat. And hopefully we can have a little bit more fun this way. Aha, I see somebody already typed in. And what you're also finding out now is that your message doesn't immediately go into the chat because I have a moderation queue by which I can take out anything that is not appropriate. But you should probably be able to see that it is actually populating now with the various messages people write. There's a 10-second delay on all of these particular messages. And I encourage you, by the way, because of the fact that there is this chat down here, I encourage you to please participate because that is far more interesting than me talking to a bunch of black rectangles. Okay? So I'm putting this on purpose because I have a certain philosophy about teaching, which is that if we want to be able to encourage people to participate, needs to be a way that they can feel that they can participate. And already you're seeing one piece of innovation that's coming in here. Well, maybe not innovation, it's just copycatting. If any of you have ever seen something called Instagram Live or Twitch, this is actually how those platforms are able to keep the interest of kids. So that's actually what's going on right here. So during this talk, if there are any particular things that you even feel making a comment about, just go ahead. It will be fun. And that way, that's actually how I get immediate feedback. By the way, you're also noticing my eyes are flipping between the sides. It's because I have two screens in front of me. One screen is showing me the real-time messages that you are writing. So I can see right away as soon as your message comes. And I have 10 seconds if I need to knock out something, I will. Right now, I'm not going to knock anything out, only because of the fact that these are all reasonable comments. But actually, this system is designed in a way so that if there were actually disrespectful comments that need to be knocked out, we'll take them out. Ideally, there's another person helping with that. But anyway, so going back to this concept, I'm going to give this talk, and then throughout the talk, please participate actively with each other. And then, at some points, maybe I'll even ask some questions and people will put things in. Yes. So the idea I wanted to put is that the world is changing. And in fact, what you're seeing right now in this talk itself, which is the reason I was late, what you see in this talk itself is that when we see new challenges, we need to come up with new solutions. And actually, I was thinking about what I wanted to talk about and changed what I wanted to talk about because of the fact that the Omicron variant just has taken hold, and many parts of the world, at least I'm aware of many parts of the world in USA and Europe, are preparing to reopen school after the new year in a way where they're even remote. Good gracious, we thought that we were done with this remote teaching, but somehow remote teaching might be back, at least for a few weeks. And that's why when we came up with this idea, we said, let's go and put this out. I will be able to tell you more about this. You guys are teachers, I assume. I'll be able to tell you more about how this works, and you might even be able to use it yourself if you end up having to teach a remote class again. Okay, but this is already starting to set the stage for the fundamental issue, which is that we have the world is changing. And if you have a changing world, you need to be able to have students be able to solve new questions. Now, how do I do that? The way I usually do that is I actually like to teach mathematics through math competition questions. And I don't want to use slides. I don't actually like to talk with slides. Instead, I like to talk in a way where I just draw on my own little blackboard here. Boom. So let's go and talk over here. And what I want to do is I just want to even talk about a very, very brief question, just to give a concept of what I mean by these math competition questions, right? And so the purpose of these questions is actually to have a bunch of problems for which students will actually have to think as they're trying to solve the problem. So, for example, an example of a question that I think is particularly beautiful. I may have shared it with your group. I'm not sure. I gave the talk to a time before, I believe. But I want to just put this out here because not everyone was at that previous talk. And it gives a conception of what I mean when I say a question which is somehow one that prompts people to think. And it's a question I use when I interview people too. So here's a simple one. If you just draw some lines. Actually, I want to be very careful, not supposed to intersect each other. How many lines do I have? 1, 2, 3, 4, 5. I want one more. Well, this is good enough. 5 lines. So I have 5 lines. Okay. So here I have 5 lines. And then a question that I like to ask, actually as an interview question, when I'm deciding who I want to work with, who I want to hire, is I say, well, how many triangles are there? Now, actually, usually I do this with 6 lines. It's just that 5 lines is what I could draw right here, but usually I draw 6 lines. And if I had 6 lines, it's actually even harder. But why I give this kind of question is because, especially the 6 lines version, I've actually never met a single person who managed to count them all. Oh, by the way, what's a triangle? A triangle is something for which it could be bigger than just a small triangle. I mean, this thing here is a small triangle. And maybe that thing there's a small triangle, and this thing here is a small triangle. This is a bigger triangle which contains some smaller triangles. But the reason I like this particular question is because it's one where I've actually found out that if you give it to students, a lot of students, first thing they do is they say, I can count them. And when there are 6 lines, by the way, there are 20 triangles. And again, as I said, I've never met a single person who managed to count all of them. But when you give these kinds of questions, then people see there's multiple ways to solve a problem. And the multiple ways are, well, you could try to count, or you could try to be clever. And I always like the problems for which one of the brute force methods is terrible. It looks promising, but unfortunately, it's actually terrible. And if you try to do it with 6 lines, again, you can't do it. But then an example of a good question that helps to teach invention is one where you look at it, there's a brute force thing which looks tantalizing, you go and try, then you find out it doesn't work, and the teacher has some hints up their sleeve. So to me, a good question to use for teaching invention and teaching creativity is a question for which when you look at first, you don't know what you should do. But there are 2 hints that the teacher has that they can put up. I see that somebody already has the answer. Sumyade. That's right. So by the way, you can also see the power of being able to see the thing coming in. Of course, maybe you have the chat window and you can see it in the Zoom sidebar. And so, maybe that was not as exciting for you, but I'll tell you a little tip by the end of how you can make it so it doesn't even appear in that Zoom sidebar and you as the teacher have full control. Okay, but anyway, so Subhya has put the answer. But what I mean by a good hint is that a hint should say something that lets you start thinking. And in fact, one of the hints I give, hint number 1 for this question is, oh, let's not count triangles. How many intersections? And this is use combinations. Okay, so now the emphasis here is how many intersections now? We want to use combinations. Don't just count the intersections. Don't just say 1, 2, 3, 4. Start to think, is there some kind of systematic way that you could use to count how many intersections there are? And once you say use combinations, the reason this is a good problem is because, again, it's for the audience who already knows what choose means, they would say, how could I make an intersection? Intersection comes when you choose things. It's when you choose two lines, right? Intersection is where you choose two lines. Okay, so that's hint 1. Use combinations. And this hint 1 is designed so that if you're a student, you still don't exactly know how to solve this problem yet, but you're already starting to think. And then why I say 2 hints is because if you put the second hint in, which is how would you make a triangle? It's like the hint I usually ask people is, what combination makes a triangle? I can't believe we might be teaching online again. What combination makes a triangle? And that's with the second hint, a lot of students will be able to start thinking and say, okay, so now I need to make a triangle. What makes a triangle? Most students say three points. But the problem with the 3 points making a triangle is because not every 3 points make a triangle. For example, this point, that point, and that point there doesn't make a triangle because you need the lines. And then people start to think, what else can make a triangle? And that's when you get the thing that Sumya said, which is that you can take 5 lines, just choose 3 of them, and there you have it, give your triangle. So that's it. It's 5, choose 3. Yes, so it's 5, choose 3. And at that point, this is my example of how I usually go about teaching the concept of invention. If you want to teach invention through a problem, actually, whenever I teach my classes at Carnegie Mellon University or wherever else I'm teaching, the way I like to do it is I like to always come up with these questions for which I expect that you won't know how to do the question, but I have some hints in mind. And my idea of the optimal question for teaching this invention is exactly question for which you don't know what to do, but 2 hints later, you will know how to do. Okay, so this is one way of teaching. But I want to say a few more things too. So one thing is teaching through interesting questions. But another thing I often do is I will go traveling around and try to get people interested in math by explaining how mathematics helps you to invent as well. Now, this is just what I choose to do. I'm a coach of the Math Olympiad team for the United States of America, actually the coach. And the way that I approach this is I'm trying to get as many people in the country and the world as possible to be interested in pushing themselves harder in mathematics. And to put a story around this, over the last summer, I actually traveled around 40 different cities in the United States of America, giving talks. I spent 2 months going through 40 cities, giving talks. I think about 50 or 60 talks. I lost count. And in all of these places, I was giving these talks to students, in fact, outdoors in public parks to be safe from COVID. So I spent 2 months of the summer going around in parks. But why I was doing this is I was going around and showing people some interesting mathematics, but also telling them a little bit about the work that I do, which is actually creating new things. So a lot of times people associate mathematicians as people who just think about ideas or think about problems like this. But what I like to show people is that mathematics can also be used to come up with new ways to solve problems that people may never have thought of before. And I'm talking about real problems. So for this, I'm going to talk about the next thing that we work on, which actually it's not about teaching. The next thing I'm going to talk about is not about teaching. It's about technology. But I'm going to share with you something that I lead. I'm the guy who led the technical and scientific development of this. And it's a new way of fighting disease. But the beauty of it is that it boils down to some game theory and some mathematics. After talking about this thing, I will actually talk about one more innovation, which again is something that I lead, but that happens to be right square in the domain of education, which probably will be of interest to all of you too. But these are 2 actual innovations that are driven with mathematics. And so what I usually do is I show people some interesting math. I share this philosophy of what does it mean to be teaching people how to create and innovate. And then instead of just telling people, hey, you should go create, innovate, I go and tell people, hey, this is what I actually do. Here are 2 things that I've come up with. So the next one I want to talk about is a new way of fighting disease. Now, this way of fighting disease, fortunately, we don't seem to need it right now because it looks like this new variant of COVID is not that lethal, thankfully. So again, don't go out and just try to get it, but it seems to be that it will not wipe out the world, thankfully. But you never know if someday in the future a lethal virus emerges. Then we'll need to deal with controlling the spread of a virus. All right, so this actually ties into game theory. And the way I'll talk about this particular innovation is it's all in the context of how do you go about controlling the spread of a disease. And the way that people always did this for the entirety of history, and this is something I spoke about last year, I believe, at this conference. So this is going to be a relatively quick review for people who have seen before and brief introduction for people who haven't seen before, so that I can go on to the next innovation. But this particular one is how you control disease. Well, remember, the way you do it is you find the sick person. And then after you found the sick person, you find out who they were around. This is standard. Human beings have been doing this for centuries. Find out who the sick person has been around, and then you attempt to remove all of them. That's what you're supposed to do. You attempt to remove all of them. Okay, well, there's a problem here. The problem is that actually, unfortunately, a lot of people don't want to be removed. You see, the issue, let me just move it this way. So actually, the problem with this particular way of controlling disease is that if you're trying to remove people who are around the sick people, who were around the sick people, they don't want to be removed because removing them is not helping them. It's just telling them, please don't get anyone else sick because it might be too late for you already. And that's the reason why it's been very difficult to control this disease. There are even countries which have very strong governments, where those governments might have had methods to really try to find out who was around the sick person and really round them up and move them away. But nothing's perfect. And there might be some people who were around the sick person that the government never figured out. And when the government told people to be pulled away, well, they may have forgotten to pull away this person. And that person wouldn't voluntarily go chase after the truck that's driving away all these sick people, saying, you forgot me. No, because unfortunately, the people's incentives, the selfish incentives, are not to go and be removed just because it's too late for them. So this method doesn't work. And in fact, even countries which were doing quite well before using this method, they had to give up. It just didn't work, even if their government was strong. Now, I live in the United States of America, which is a democratic society. And in our society, the idea of a government dragging people away is not very popular. And so this method definitely didn't work. But then that's what caused me to think about game theory and also graph theory. Graph theory is the area of mathematics I work on. You see, this is only one part of a large graph. Graph is network. There are more people. So I'm drawing all these people, okay? Here are all these people. And if I have all these people, I want to say what each of these lines means, by the way. Each of these lines means that those two people spend lots of time nearby each other and often. Okay, so every time I draw a line between two people, that means that those two people spend a lot of time nearby and often. So what? Well, there's an issue here, there's a definition here I want to share. So let's say this is you. There's a definition called the network theoretic distance. I'll call it the network distance. And the network distance between any two nodes of a network is just the smallest number of steps that it takes to go from one to the other. In this case, it's 1, 2, 3. So the network distance between you and the sick person here is 3. Okay? So our concept is actually quite simple. So again, the notion of who's connected to who, that means that these two people spend a lot of time nearby often. And here's this notion that there's a sick person 3, network distance 3 away from you. And our idea was actually very simple. All you do is you just make a tool that tells everybody how far away from you each new reported sick person is. Not like in real time, saying that you just went to the grocery store and here's a sick person right next to you. No, I mean that every time there's a new report saying, oh, somebody just diagnosed sick, how far away is that from you? We just measure how far away it is from you in terms of this network distance. Well, what's the big deal? The point of doing this is because then you could potentially show people what it looks like this. So this is about graphs, charts. If you want to use charts to show people how charts could be useful, if you want an example of how charts could be useful, here's what you could do. This is a chart that shows how far away each new sick person is from you. And the height of the bar is telling you how many sick people there are. It's hard to read the numbers. The numbers are actually behind this particular comment box right now. But, well, you know what? Let me just very temporarily remove that just so that you can see the labels, right? So this is you. This is the first, the second, the third, the fourth. These are the degree of connection, how far away that particular sick person, that particular new diagnosis of a sick person is. And this is telling you how far away, and this is telling you how many cases there are. Why does anyone care? Well, the reason is because, let's turn this back on. The reason is because you can show how this changes over time, like this. So I'm now playing. And you can see it's moving. Moving in the sense that there are more and more people getting sick. Suppose it looks like this. The way to read this chart is that the date has changed. Oh, maybe that wasn't clear. Let me do it again. Okay. So I want to play this again. Just a second. The date is changing. Excellent. So the date's changing. And so what this is showing is that as the time changes, here's how many people are sick, and here's how far away they are from you. Okay, who cares? So what? Well, it's interesting because what I've just showed you is a new tool which never existed in the entire world before we thought of this. And we actually made this, but before this, there was no such tool. But this new tool lets you do something that you could never do before. Does anyone know? So this is where game theory is coming in. And I'm asking you guys because, well, we have a chat here, so we can have some fun. What can you do with this tool that you could never do before this tool? Suppose there was some contagious and lethal disease. Suppose there's something that you don't want to get. And suppose there's a tool that will tell you every time some new person gets sick, oh, how far away is that new person from you in terms of this count? And the count says that you frequently spend time with this person, who frequently spends time with that person, who frequently spends time with that person, and oh, that person was sick. Anyone know? What does this let you do that you couldn't do before? Aha. I see there's a comment that's already coming in. This is good. So it's don't spend time with new people. Exactly. So the point is that this tool is letting you know that, oh, it's getting closer and closer and closer. Maybe now is a good time to pull back. And that's why it's so important. This is about nearby and often. Because the point is, if you find out that frequently you're around people who are frequently around other people, well, actually, that means that this disease is very likely going to jump over to you unless you pull yourself out of the society temporarily. Okay, but now that's interesting because that's where the game theory comes in. Remember, I said it's very difficult to go and separate the sick person, separate the people who are around the sick person from society, because that's not helping them. Those people already are exposed to the disease, and you're telling them separate so you don't get anyone else sick. Why are you suddenly interested in separating now? So this is very interesting. Remember, it's hard to tell someone, it's too late for you, please separate so you don't get anyone else sick. But how come in this situation, you actually want to separate? This is where game theory comes in. Can anyone type in? So like, what's special now? Because previously I thought it was so hard to tell people stay home. It's very hard to say stay home so you don't get anyone else sick because you might already be sick. Why do you want to isolate yourself suddenly here? Why does this tool make you want to isolate yourself? Indeed, yes, thank you, Inder. Isolate yourself is exactly what this is making you want to do. But why? What I'm saying is, how come here you want to isolate yourself, but previously you don't? When I say previously is the old-fashioned way of saying, hey, you were already around the sick person. Go isolate yourself so you don't get anyone else sick. How come this time, when you see this thing, you actually want to isolate yourself? Game theory is about incentives. Game theory is about what is in it for me. Aha. So somebody has that. Somebody has a comment coming out now, which is that now you can see the effect of isolating. Actually, that's actually really powerful. Being able to see, oh, if you do something, now you can have a result, right? It's nice to be able to see. That's why when you drive a car, you have a windshield, so you can see out through the windshield, or at least you are able to see where you're going. Yeah. But the basic principle is this thing solves the game theory problem. And the theme behind a lot of what I'm talking about today, this one and the next innovation, they're both around game theory. So the idea of game theory is if you can make something for which every single person wins by their own participation, then the whole system will work. And previously, they don't win by their participation because their participation is get out of the society so that you don't get anyone else sick. Suddenly over here, the win is, oh, there's a lethal disease, huh? Well, if there's something coming in, I don't want to get sick. So I'll get out and I win. Oh, but now here's why we were so interested in working on this. It was after making an observation about a year ago that this thing could save the entire world, the entire democratic world, from a future lethal disease. Here's a quick question. Suppose that there was some future lethal contagious virus, where lethal means that if you get it, 50-50 chance that you die. These exist, like Ebola. There are diseases like this. Suppose there was a disease. If you get it, 50-50 chance you die. Even if you are young, even if you are athletic and great shape, 50-50 chance. That's what Ebola does. Hey, in that situation, what fraction of people do you think would want to use an app voluntarily that will warn them whenever there's a new strike of the disease and tell them how far away it struck? How popular do you think that would be? Just think about it. What's in it for you? So again, the scenario is that you have some future lethal disease, kills half the people who get it. Ah, we have. Yes, I know what you're talking about. Aroiga Setu. I think, and also, yes, and I also see people saying, this is popular, but here's something I want to be very careful about. Actually, you don't have this. This is what I've just described is the only one in the world that does this. So the Aroiga Setu app is very different. The Aroiga Setu app tells you two kinds of things. One kind of thing it tells you is every time there's a new diagnosis, it tells you that there's a new diagnosis 1 kilometer away from you, or 2 kilometers, or 500 meters. I've been to India many times. If I'm in Mumbai, how many people live 1 kilometer away from me? It's useless. It's useless. The thing is that there's so many people around that which one, I don't know. But there's another much deeper issue, which is that people travel a lot nowadays, even inside a city. And it could be that the person you spend time with teaching at the school lives 3 kilometers away from you. In which case, a 3 kilometer away strike of this lethal disease is far more relevant to you than a 500 meter away strike for which you'll never see the guy. Okay, so I'm emphasizing that we have actually come up with something significantly more powerful than Aroiga Setu's and the whole world's idea of how far away did the disease strike. The key insight is it is useless to know how far away the disease struck based on the home addresses and the meters. But it is very useful to know how far away disease struck in terms of the number of these frequent close contacts. But there's a second thing Aroiga Setu does. Aroiga Setu will also tell you, oh, somebody already got sick. Somebody already got sick. And you were already around them. Please stay home. Aroiga Setu does not give you this. Aroiga Setu gives you this, where I just cover up everything. Just block all of this side. Yeah, block all of this side. Aroiga Setu just shows you this number right here. Nobody else thought of this, actually. And the reason, by the way, is because apps like Aroiga Setu and all of the apps that everyone else made in the world, all they were trying to do was take the old-fashioned method of contact tracing and make an app for that. There was no innovation, by the way. There was no innovation of what should we actually do with this new possibility of having smartphones. The only thing that they thought about was, oh, well, we are doing contact tracing. Let's use smartphones to do it. Sort of like saying, hey, we're going to try to put teaching online. Let's just go and throw it all on Zoom and hope it works. It doesn't work very well. But if I go back to here, so I want to make very clear, the Oroiga Setu app and every single app in the entire world, actually, except for what we've made, every other system either only tells you geographic distance, which is not useful, or it tells you only after you're directly around them, which is not useful to you. And it's asking you to please inconvenience yourself to go help everyone else. But we were the ones who realized this. And so actually, it's important to note two things. The first is, who would want such an app? We already see, yeah, lots of everyone would want it. This is clearly just in your benefit. But here's the second beautiful thing. How would the average person react? If the average person was using the app and it was actually 50% lethal disease and they see this, what would they do? Suppose that it's a 50% lethal disease. Suppose the average person sees this. And by the way, if it gets to the zero, if the red gets to the zero, you have a 50-50 chance that you die. What would the average person do? I guess this is fairly obvious. I mean, the average person would just choose to stay home. Not because they have to, but because they want to. That's the power of game theory. Let me contrast with Oroiga Setu. The flip is if you just tell someone, like over on the other situation, the other standard apps, if you tell someone, hey, it's 50% lethal, and you already got it, now stay home so you don't get anyone else sick. How compelling is that? Just compare those two. Actually, if you think about it, if it's 50% lethal, is what you're going to do for the rest of your life just stay home? When I say rest of your life, it's like, well, just even think about human incentives. If you're told you got 50-50, I mean, you might already be infected, and if you actually got it, 50-50 chance, you're just dead. Stay home, and then that's it. I'm just trying to paint the picture of how the game theoretic incentives are very, very bad in that situation, actually. So basically, what I'm pointing out is that nobody else thought of this. So very surprisingly, you have countries with billions of people. India, China, both of them put out apps which are only the after the fact telling the people be controlled. Actually, the country that started all of this was Singapore. And it was also followed very quickly by South Korea and mainland China. And these are countries where the standard approach that they use to control population is to control the population. And so all of those apps were actually designed to control the population to help make sure the disease didn't spread. And that's one reason why those apps were highly unpopular in the United States of America. We are a country where people don't want to be controlled. They want to have their own freedom. And so what we did is we invented a new way. We invented a new way that still separates these two groups of people. But the way that we separate the two groups of people is by making something for which it's in your direct incentive to use, and it's in your direct incentive to take action when it warns you. And against COVID, not very useful because people don't consider it to be lethal enough. But what we have made is such that if there's a future lethal disease, well, this could actually save the entire United States and quite possibly your country too, because you're also a democratic society. So that's the first thing. That's the first thing that I was working on quite recently. But the main point of this is, what does this have to do with mathematics? Actually, a ton. This is using mathematics to look at the world and invent something new. I often explain to people the difference between mathematics and, let's say, engineering is that in mathematics, the beauty is when you come in with a new way of looking at a problem. And when you look at the new problem, everything falls apart nicely. It's because the shift of the frame of reference suddenly solves the problem. Also in mathematics, oftentimes we like proofs. A proof is where you start to think about all the things that could go wrong. And that's why what I just described over here, it's game theoretically sound in the sense that the things that we're asking people to do actually make sense. And so it's natural that I guess it's mathematicians who came up with this approach. With that, I want to move into the last part, which is another thing I've been working on lately. And it's the latest thing that I've been working on because with the COVID becoming not as big of an issue, well, now I'm moving back to education. So if I want to think about education, the next thing is, well, what can we do to try to help to make education more engaging? So there's a little bit that I want to show you right here. And I'm particularly happy with this because I think it might be useful for all of you, especially if we end up going into remote school again. I don't know what India's stance is on the Omicron variant, but the stance of many other countries is it looks like they, even though it's not as lethal as the previous ones, people don't want to have it spread too fast. So we are seeing things like universities in the United States shutting down their doors for the first 2 weeks of the new term, which is going to start after the new year. But what was I thinking about when we were doing this thing? Well, it's because I also was teaching online, and I was teaching online in the university. I was also teaching online with online courses. And it's really, really hard to teach a class where everyone is just black rectangles. It's even worse when those black rectangles correspond to students, because at least adults, you're here because you want to be here. You're here because you see that there's some value you're going to get, and you're probably at least listening. But with kids, especially middle school kids, they might not care. They might not be listening at all. In fact, you might find out that they're just not even on the screen. And here's something I noticed. Early on in the pandemic, when people were using Zoom, in Zoom, if you let middle school kids type in the chat, they very quickly type lots of nonsense because you can't moderate the Zoom chat. You know, here we dare to let the Zoom chat be open because these are all very responsible people. And you're not going to write blah, 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 all kinds of nonsense. But if you let kids do it, you might get nonsense, especially if they change their username, right? So you can get all kinds of nonsense. You might even get some like random other person who's not in your class show up and start dropping nonsense into your Zoom chat. And then what I saw happen is that some teachers would tell their class, don't type anything into the Zoom chat, it's too disruptive. Or they would just turn the whole Zoom chat off. But when you do this, it does something game theoretically, which is bad. It makes the middle school kids stop paying attention. And in fact, they often would switch to something totally different, not even the Zoom app. I thought a lot about this. I think it's because the psychology of kids is that they actually want to be heard. They want to be seen. They want to be heard. That's natural psychology. Now, when I was growing up, that corresponds to actually just physically being somewhere, right? If I want to be seen and I want to be heard, I would just go somewhere, I would do something, I would say something. But the interesting thing is that the modern generation of kids, the way that they are seen and heard is like this. This is actually the standard method of people communicating, whether we like it or not. It's just like how kids will just text you instead of saying something to you. And so I started to think, how can you actually go and try to use whatever drives students to align the incentives and bring this into an educational experience? Oh, interesting. So somebody said it could happen more with the college students than with the high school, with the middle school students. Wow, it might be that in India, your middle school students are better behaved. They're different backgrounds of people. Actually, it's very funny. In the United States, the difference between college students and middle school students is that if the college students don't want to be there, they just don't even join the Zoom, period. They're just not even there at all. It's not that they join in the black screen. They're just gone. But in the United States, the middle school students are required. They're supposed to do it. But what I'm trying to get at anyway is that there are students who are not mature enough, let's say, and what they want to do is they want to be seen, they want to be heard. So how do you help them? Well, the way you do it is you go and tap into what they normally do anyway. They normally are on all of these chat forums. They're on all of these websites like Twitch, and what those have is they have a way to let the students or let the person's name be somewhere and let their comment be somewhere. And what they want to do is they want to have made a comment, and they want the comment to be seen by everyone. Okay, so the key is we actually need to make it not that the chat is off, but we need to make the chat very on. So what I'm saying is this is something that nobody had done before. Everyone was only thinking, how do I control the problem? There's an analogy here to the disease control. Instead of like disease control was, how do I control the problem? Not how do I empower the individual? I'm using the same theme again right now. Don't just control the problem, empower the individual. What does the individual want anyway? Why were they writing all that nonsense? They wanted other people to see them. Okay, let's make it even easier for everyone to see them. Throw it right here. But now there's a catch. You see, that's why the 10 seconds comes in. What I identified was that the fundamental problem with Zoom was no moderation. Because I also ran live streams on YouTube Live, and I would always have somebody on the side helping me moderate, killing bad comments. And people loved it. we had students who were just very actively watching this thing. They loved it because they loved that even while I'm talking, they can be telling jokes that are kind of related. They can be making comments about what I just said. If I tell a joke about a banana, then they're like, oh my gosh, and then they say something. Do you know what I mean? Like I was actually finding out that these middle school kids were more engaged than the normal class simply because of the fact that they could just be having fun right down here. Okay. Makes you wonder why Zoom never put moderation in. They've had 2 years to do this, but they never did. That's okay. So we did. So what's going on right now is that, oh yeah, by the way we always do this is if we're actually running this, we actually turn off the Zoom chat, except that you can only chat to host and co-host. And if you want to know what's going on under the hood, that's why I've signed on twice. The PSL Monitor account. That's the one which, if we were running this in our classroom, I would turn off all of the chat and you're only allowed to talk to PSL Monitor. And you can talk to me too, but I won't see it. Anything you want to say, type into PSL Monitor, type a private message. PSL Monitor is a computer over there. On that computer, there's a program I wrote. And what that program does is it takes the Zoom chat window and it takes screenshots of the Zoom chat window 5 times per second. Now it converts those screenshots of the chat window, those are pictures, converts those pictures into words. All of those words are sent up into a server, which I can see. And that particular server is letting me see all of the messages coming in real time when I can kill them if I need to. By the way, once you do it this way, then those messages they're not seen by anyone else. It makes it so that everyone, when they chat, they have no way of making their nonsense be seen by everyone else. But instead, what happens is that if they're chatting, then their message is seen by me on a screen that looks like this. So this is actually what I have. So I just shared my control panel. In fact, if you type something into the chat, you'll see interesting things start to happen. So I put this here because I want to talk through this. There's game theory inside this too. And I'll have to explain why there are 2 columns. So if people start typing anything, then this thing will start to move, and then you'll be able to see what I mean. Aha, now it's going. So what's going on here is that everything that is happening, all of those chat messages, they are being seen by my program, which is on the other computer over there. And then it's thrown immediately into this. This is a website that we operate. And this particular website is taking those messages as they're coming in, and it's showing me on this side every message as it comes in real time. That's how when I was giving this talk, I was able to be so responsive, right? It's because actually I have very hard time seeing the little comments in Zoom, but on my other screen right in front of me, I can see this. So I can see everything coming in real time. You may notice that there's this delay where it takes a while for the message to come in. You may be able to notice what's happening. It's moving its way up. And once it gets all the way to the top, then it's going to appear here. Very simple mechanic. Okay, but so the point is that with this system, now if I want to, for example, bam, I used the wrong button. Let's knock that one out. Yes, right. I'm sharing so many different screens that I'm going to use this one. So if somebody makes another comment, I'll just show you I can knock it out, and then I'll just knock it out over here. Well, we'll wait, but I'll knock out the next. Oh, there we go. So let's try again. Boop. It's gone. So at this point, the let's try again is probably not going to appear. So you can see the wow appeared, the fantastic will make it next, but the other one didn't appear, got killed. No offense to you, Sumya. Thank you so much for being willing to try this with me. But I just wanted to show you the system is such that now you can have moderation in Zoom chat and you can put the whole thing down here. Oh, but there's more game theory here. So this alone is not exciting. This alone is okay. The exciting thing is what's going on over here on the right side. Which side? This side, this side. What's going on this right side? There's a reason that there are 10 categories. These are buckets. These are buckets. So what's going on is that there's also something in here where in a classroom full of students, I don't want that this chat gets clogged. I don't want that this is clogged with just too many things. So there's a rule. Only one message every second. And here's where the game theory is starting to come in. Which message? Only one every second. What if 15 people all typed at the exact same time in the 1 second? Only one will make it. Which one? Random. Aha. So now we have some stuff coming in. Perfect. So there's going to be all this stuff coming in and it's random. You see there's way more here than over here. It's because these are called buckets. Every second is one bucket. And you can see only a few of these won. The way this works is that it's rate limiting for the human concentration, but it's also setting up a game theoretic dynamic by which, oh, now if you want to go and see your message to be said, to be shown on screen, you need to win the lottery. The lottery is all these people answering at the same time. Who gets through? Only one. Random luck. Except that it depends. The way the random luck works is that, oh yeah, which programming language? I'll answer that too. But which one will randomly be picked if there's all these that come in at the same time? Well, at the beginning it's fair, meaning every single message that came in that second, equal chance. But if there's some messages which are really good and the moderator loves it and presses the, oh yes, check mark. Check mark is where we say, definitely let it in. You know, I can go and press a check mark if there was a fresh message. If there was a fresh message, I can just go, bam, I love this message. It goes in. Okay, and if that happens, that person gets an extra point, reputation point. If I kill a message because this person was bad, they get one less reputation point. And the power of this is that which message wins in the 1 second is related to how many reputation points you have. So for example, if you make a bunch of nonsense comments and you get the X pressed too many times, you get no tickets. So actually, even if you're the only one who made the message and there's no one else in the same bucket as you, you just won't even get to appear because you have 0 votes. What this does is it slants the incentive structure so that the middle school student or the high school student or the elementary school student, their incentive is to make a good comment. You see, it's the analogy to what I was doing with the disease control. You empower the people. What do they really want? They want to be seen. How you get seen more? By writing good comments. If you write a good comment, you have more chance of beating out the other people when it comes time and there's some kind of a contest to see which comment goes through. And by doing this, we solve a bunch of problems at the same time. The first is the engagement, because we know that these middle school kids, they want to see their name here. They want to see their face. We're actually building something now to put a little face near each of those, well, face, whatever icon you want, next to each of those, next to each of those usernames. But they want to see themselves there. So let's give them a chance to do it and put it in a way where the teacher, if you see lots of nonsense, you can get rid of the nonsense, right? But at the same time, you can, once you get rid of the nonsense, then that makes it so the student has no incentive to write nonsense. Because if they write nonsense, it's just making it less likely they'll ever get to be seen again. On the other hand, they have incentive to write good things. And so if they write something good, suddenly their score goes up. In fact, one of the next versions we're building, your score is going to display right next to your name. So it's like, yeah, I want my score. What's my score? My score is basically how many things I said that the teacher said, great job. So I'm just sharing this because this is the latest thing that I've put out. And I'm working on this because I see that the world is moving in a way where we have lots of online education nowadays, not only because of COVID, but we have other things. And so I actually built an entire online school. And what we have is that the new technology on which all of our things are based on is around engagement, around the idea that you have kids, and the kids, well, they're young. We will try to engage them with interesting math, with problems that they don't know how to solve, with entertaining teaching. What are those FP, etc.? That's a good question. I want to know too. So what are those FP, etc.? I'm not sure. Let me see. What do you mean? So I'm wondering if there's something which the way that this chat is working. So I actually don't understand what you mean by what are those FP, etc. Would you be willing to expand a little bit more just so that I know what you're talking about? But meanwhile, I'll answer.
Some of my chats are like, I can see some PE. If you see my last chat.
Oh, yeah. Okay, yeah. I'll tell you what's going on. What's going on is that, remember I said the way this is working is that the other computer is taking pictures of the chat. It's taking pictures of the chat, and it's using the pictures to convert them into words. So sometimes it actually can't recognize if it's not like proper English. Although I will say there's a new version of this, which is what I was building last night, which actually is able to even circumvent the taking picture part and just get the straight up words. So actually, probably within about a week, definitely within a week, we'll have a version of this where there's not even a picture taking. It's just using the Chrome web browser. Okay, now you're curious what this is. So I'm happy to explain a few of these things. What programming languages were being used? Well, there's a lot of stuff written here in JavaScript, actually. It's using JavaScript, TypeScript, is a thing called React. We are using a Firebase, is Google's cloud databases. And what software are we using so that I'm visible in front of the screen? I'm actually going to be sharing all of this on a website. Basically, because I see a lot of the world is going to be going to online teaching starting in January, I'm actually going to share this technology with everyone. What's going on is that there is a way to go and get this whole system where all you will need is a Google Chrome web browser. And if you have a Google Chrome web browser pointing to your Zoom, it will be possible to have this entire interface, which just sucks in all of the chat for you to play with. And then the thing that I'm using to have myself appear in front of a screen, well, that's actually a program called OBS Studio. And I'll have instructions on how to do that, because that's actually how you're able to overlay all of these things together. Like over here, so that everyone is able to see the chat as it goes. You're able to see my picture. You're able to see whatever else is behind. OBS Studio is a free program that lets you layer a bunch of different things on top of each other and do really all kinds of fancy tricks. So effectively, what's going on here is that, yes, there's a lot of these technological details, but at the heart of the solution was, how do you go and invent something that will help to address a major problem? And the major problem was online teaching is not engaging. And what we just saw is that just now, even in this small setup with these adults, we had some more engagement just because of the fact that the thing is here. And you can imagine that if you're doing this with students, it will be even more popping, because this is the way that they're used to actively communicating. And so, yeah, thank you. And so, oh, by the way, also makes my life way easier, because I have a much easier time reading these big words of the comment than looking at the tiny Zoom, right? But now you're actually just watching the entire thing. What you see here is my own control screen. But the entire thought process was how we go and solve big problems. First big problem was pandemics. Second big problem was online education. And if you think about it, at the heart of these is math. Right? It came down to game theory. It came down to these ideas of how do you align all the incentives. It came down to probabilities. I'm using probabilities to deal with these buckets and the random selection of who gets through. But in the end of the day, I like to give these kinds of examples because they show how you can use this mathematical thinking to go and actually create and actually invent. And that's what we need in order to go and show people, that this mathematics is useful. I see somebody just asked, is there an equivalent one for Microsoft Teams? I haven't built that one yet. We could. I mean, we're starting with Zoom just because that's what a lot of people use. But the hard part was building all of the different pieces. And for example, getting the thing to work, connecting in with Zoom. I did that yesterday in like a day. So yeah, hope this works for all video apps. We could totally do that. And actually, what's the best way to share information about this thing? I don't know. I mean, if you want to keep up with this, there is a website, zoom.poshanlo.com. Actually, that doesn't even go anywhere yet, so that's not useful. But soon, this website, zoom.poshanlo.com, will have instructions on how to set up all of this stuff. And right now, if you want to follow any of the work that I do, my website is just poshanlo.com. And anything that I come up with usually shows up there. And this particular work is going to show up there soon, because I want to make this available for everyone in the world. With that, I think we have hit the time. So I don't know what you want to do with the time. Inder, you're the one who runs this. If we're done, we're done. If you want to have questions is fine, but I know that I went over already.
We can take one or two questions because we have something else to follow later on.
Exactly.
Yeah, so we'll invite questions from participants. Many of them you have already seen in the chat box and answered anyway.
Yeah, I'm watching it as it goes.
Yeah. Yeah, but if somebody has a very specific question related to the talk, or maybe which will give Poshan some idea about what more to do, like Sangeeta Gulati said, whether video apps will work or not, whether it is for somebody said for Microsoft Teams it will work or not. So those are the things. But if anything else you want to ask, please unmute your mic and ask, or put it in the chat box, whichever you find comfortable to ask the question.
If I may just
Yes,
ask,
sir.
as a teacher,
Yes,
how do you
Sangeeta, why do you
manage?
say that? say the name first so that he knows.
Yes, sorry. Yes, I'm Sangeeta Gulati here, and it was lovely to attend this talk. It was fascinating, absolutely fascinating to hear you and see these. I've seen your earlier lecture as well, where you talked about this solution for pandemic. But as a teacher, the thought that's coming to my mind is, when you're teaching, how do you manage all this gizmos that are there with you? Because we are struggling only with one tablet and one Google Meet and chat and so on. So what's the trick of you managing everything and delivering the content and managing the engagement? So if
question on time management.
Yeah, so I will say, actually,
balance.
Right. So to me, the way I do this is I actually think back to the old-fashioned way. I love teaching in a real classroom, by the way. Even though I'm doing all this stuff online, I love the in-person. That's why this summer I went in person to 40 cities. In person, the way I teach is I'm looking at everybody's eyes. I want to know, are you following? What are you thinking? Express something. That's why I put this right here. Because I found out with the online teaching, if I could not get feedback from the students, I could not teach well. So actually, it's ironic. More stuff like this is better if it's right in front of me. Okay, so now actually what I have is I have two screens. One screen is letting me see what I'm teaching. The other screen is really just showing me this, oops, wrong one. It's showing me this one right here, right? And I'm not really clicking on that. I'm just using that one to know, here's what people are thinking. Here's the temperature of the room. I always have an assistant who will go and help and do the kill the bad things. You have no time to kill the bad things yourself. Right, but I mean, you could imagine that if you have some student who's respectable, right? You can take turns. It's just that give them the access to the room. It should be a good person. If they see something bad, you kill it, and it's actually very easy. Once there is, it's back to game theory. Once everyone in the room knows that you say something bad, it will get killed. They will stop saying bad things. You see what I mean? Because actually the way that the game theory is set up, you say 3 bad things, you have no votes left. Then you basically got completely shut up. So just no for the hour. The next time you come the next day, you're back, reset, you get another chance. Okay? But the point is, you just need to know. It's like with the law. You just need to know there might be a police to catch you if you commit this crime. Then you don't commit the crime. But the problem with the Zoom was there was no police. So everyone just commit all the crime because they know there's no consequence, if that makes sense. So my point is, a lot of this game theory is about making it so that you, the teacher, don't have to do as much. And the pandemic control is to make it so the government doesn't have to do as much. It puts it so it's the person's own incentive. So on this, you only need one trusty student. You can take turns between students, the ones you trust the most, give them the access to the website, just tell them you kill the bad ones. That's all you have to do. Now you go and do your teaching, you go see everything that appears here, and you actually, the way I know I'm doing a good job is if there's people talking. This is actually what I mean. If people are not talking, I'm doing a bad job. They're not paying attention. And so I start asking questions, get you to say something. And then it's less to manage.
Great. We look forward to this, coming to us then, definitely. Thank you. Congratulations on your work.
See, if nobody else at present is asking, then I will take my chance. If somebody wants to ask, please go ahead, because the host should not be taking all the... Yeah, somebody wants to ask something? Okay, if nobody takes the cue, then let me ask. You see, when I teach, hardly students put anything in the chat box. Because what I'm doing is I'm using tablet PC and writing on the tablet, and that is being sort of sent to them via Zoom, say for example. There is a chat box, but I normally like in a classroom, I ask, hey, Mr. So-and-so, are you there or are you sleeping? So I pick up the one who is awake and start talking to him or her and do the problem, sort of taking that person as a helper for solve the problem. So that is the way I sort of try to bring interactive, but I don't know online class, whether I have found nobody writing in the chat box. No comments at all about how you are teaching, what are you teaching, is it good or it is bad? They won't write bad anyway, because it is all known who is writing the comment probably. But there's no, I don't know, in the school, because I'm teaching slightly first year university students, whether school, there it may be possible in the chat, they write such things. I don't know. So that's not my experience anyway. Yeah.
Yeah, so my experience is that the reason why students don't write in the chat box is related to whether or not when they write, they get a response. So what I've noticed is, for example, some teachers, it's inconvenient for them to be able to see the chat at the same time. And then if the students know that the teacher is not going to see the chat, they don't write.
That's possible. That's possible, yes.
And also there's this issue of like, if you write in the chat box, will other people react? And so what we have noticed is actually at our university classes, the bigger the class, the better the chat box works, because then some students know that someone else is going to engage with them. So the point is that by putting it into the front center, now suddenly it's so that everyone can see what's actually happening. So I guess if you want to know the entire setup I have here, basically I have a thing I can write on. I have a preview of what's going to everyone's screen, and I have the chat. So I have basically two screens in front. One is showing me the direct feed that I'm sending out. And when I write here, I can see the feed, right? So the point is, I just have something I can write on and I can see a feed. You only need two screens. You need a writing method and two screens. One screen to show the feed going out. The other screen helps me to know what's coming back. And the way I always try to make more chat is the instant someone types something, I see it in the other one before it gets here. And I'm going to respond to it. And I'm going to say, good, 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 right? And the more you encourage, the more people actually participate. And I'm doing that on purpose because to me, that's the first level of even being able to teach a class. If the people are not engaged, I may as well be saying nothing. You see what I mean? My point is there are all these other things we think about in the teaching, but with the online, the biggest problem is that they might not even be in the room. In the normal classroom, we have all the theories of how you teach, and at least the kid is in the room. Here, the kid might not be in the room. So I'm trying to solve that basic problem. Put the kid in the room, and then we start teaching.
I do that classical method of tapping the name and saying, hey, are you there?
Yeah.
And if it responds that at least the mic is working and I can interact with the student. So others know that they can be randomly asked and whether to see whether you're online or not.
See, that works, but I found that the students are pretty clever in the sense that even I'm clever. When I'm on a Zoom call that I don't want to really participate in, I turn off the video, I do some other work, and I listen for my name. And whenever my name is called, I say, yeah, and I make up something. So what I'm trying to say is, I know I do the same thing.
Yeah, sure.
So how do I stop that? I need to make it so that that student is so actively engaged that they are actually in this. You see what I mean? That's what I noticed from my YouTube live chats. I want the kids to be in this. Not just listening for their name, because they became professionals about this over 1 year of online learning.
Yeah, sure.
Okay.
Yeah. Anybody else has a comment to make or a question to ask quickly? Last comment or question before we wind up, because we have to go to the next session. If you like to join, you can join. We are having a concluding function after this. So if you have time and like to join, you're welcome.
I wanted to ask a quick question. May I?
Yeah, please go ahead.
Yeah. So it was really wonderful listening to this innovation and the game theory involved. Given India and the fact that internet may not be great at many places, could you think of innovations where we can have similar things, but which don't require Chrome web browser or things that will again require more internet?
Yes, absolutely. Actually, the thing that we're doing with the Chrome web browser is going to be very, very light on the internet usage. So the reason why this is interesting is because this is less internet requirement than a video. This is actually just words. So the power of the Chrome web browser thing we're using is that when you have the Chrome web browser, when you open the web browser and don't do anything, it's using no internet. Now, if you go and use the browser to go and connect to something, then it starts using internet only to get that information. But so we have a way of using that connection between the Chrome web browser and Zoom just to get the words. And by getting the words, then you can use the words and throw them on a screen. But words are very light. The key is that words are light, videos are heavy. So what I will say is that if it's not working, we want to know. Because in my opinion, this thing should not be something for which this part should not be where the internet matters.
Okay.
Great.
I think,
and somebody asked for my email. The best way to contact me is by, it's support@potionlow.com. So this one I will actually go and type in the chat myself. I'll put it here, support@potionlow.com. The support is useful because it doesn't only go to me, it goes to me and it goes to some other people as well. And then somebody will be able to point to me to do this.
Yeah.
So
thank
let
you.
me go ahead.
Thank you for sharing the contact.
Yes.
And
wonderful.
So any more questions, any more doubts, any more clarifications, suggestions, please do contact him. And from all of us, so let me thank you, Roshan, for being online with us at this time and agreeing to be supporting this conference. Thank you very much. Very nice.
You bet. See you next year.
Keep up the good work.
Thank you. Bye-bye.
Bye. We have about 5 minutes for the next. So if you want to refresh yourself and.
Yeah, so concluding session was scheduled at 8:40, but we can do it at 8:45 maybe.
Yeah, 5 minutes we can give for people to.
Yeah.
Or we can start at 45 anyway, so that others can always go and quickly come back.
Yes.
So 2-3 minutes to start the concluding function. Yeah, Richa, you are there. Shanta.
Yes, sir. Yes.
Good. So,
sir, I'll be sharing one screen. So share screen is enabled for everybody.
We will wait. Soumya will start the proceedings for the concluding function.
Huh.
As and when he calls academic review committee to say the results, so we will do that.
Sure. Thank you.
So Soumya, you want to? Hello, Soumya.
Yeah. Should we start or?
I think we can start.
Yeah. Okay.
Yeah. Yes.
All right. So yeah. So hello everyone. We are at the concluding session of this conference. There were a lot of very nice, informative talks by eminent educators from around the world. And also we had many workshops, hands-on workshops. I hope all of us have knowledge through these workshops. So I'll just say that we had around 210 registrations. And almost all of these sessions, we had around 40 to 50 both in Zoom and some few participants attending continuously. Thanks a lot for your participation, active participation. So I now request members of the Academic Review Committee to declare the Best Paper Award. Over to you.
I think Shanta and Richa both will do together.
All right. Yeah, you can share your screen if you need.
Yeah.
Yeah.
Can you see the screen?
Yes.
Yes. Okay. So this was been a wonderful conference. We've had a total number of 27 papers that we received, and they were broadly, the slide shows broadly the areas in which the topics were. So we had some on learning model, we had some papers on MathsPad, Excel and Mathigan. We had one theme of experience of innovation and integrating technology into the classroom. We also had innovations coming from origami and integrating art. We had a few presentations on study habits and parental involvement. Overall, I think the presentations were very nice and were pitched at the correct level for largely school teachers. We did have one or two presentations pitched at the undergraduate level. So it was a very rich learning experience, and it was amazing that in the time of COVID, teachers have not only lots of work, but have also taken the time to do this research and present it to us. So in terms of evaluating these papers, the Academic Review Committee has followed the rubric that was put up on the website. There are four categories that we have seen. And then we have also listened to all the presentations and we have asked questions. Richa will be declaring the results, but I just wanted to say that that there were very broadly two categories. One is direct involvement in the classroom, and the other one was more very education research oriented, where we were doing correlation studies and things like that. And I think the results also kind of reflect that. And I'll now hand over to Richa to declare the results. Thank you.
Thank you, Ma'am Shanta. Good evening, everyone. On behalf of all the members of Academic Advisory Committee, I take this honor to announce the Best Paper Award. But before that, I would like to share my experience. It gives me an immense pleasure when I see the math educators across the globe are really working and exploring new ways of teaching mathematics to make teaching learning effective and interesting. It was really a wonderful and challenging experience to review the papers and mark them. And all the committee members will agree to me that all the presenters were well versed with the topic they chose, and they presented their papers in the best way possible. So finally, the announcement of the Best Paper Award. So it's shared by the two presenters. So one is Miss Manjushri Dhume, and her paper was on play and learn math. Another one was Rebecca Thomas and Jacqueline Karim, and their paper was on the effect of student technology use and 21st century skills on teacher efficacy and beliefs in online science and mathematics classroom. So we committee members found one more paper which was very well taken and presented. So decided to award a special mention to the paper presented by Mr. Prashanta Kumar Mahapatra on art integrated learning in mathematics at middle stage towards enhancing learning outcomes. So congratulations to the winners and to all the participants for their efforts. Thank you.
Thank you, Richa.
Thank you, sir.
So let me also congratulate the winners, two winners, Manjushri and Rebecca and the team. And hope next year, next conference probably, as and when we have it after 2 years, more papers will come, and it will also encourage Mahapatra for continuing good work he is doing for mathematics and art. And also I would like to take this opportunity to formally thank please keep your mic muted for time being. Thank the Academic Review Committee. I sort of only once or twice I contacted them and asked them, would you be part of this? And they willingly agreed. So thank you. Thank you, Shanta. Thank you, Richa. Jonaki, are you around?
Yes, I am around.
So, thank you, Janaki. And whether Santanam sir is there or not, but
yes.
Oh, good. So please come if you have camera on. That will be nice to. Yes, that's great. So thank you, the review committee. for your efforts, time spending, and evaluating. And of course, your efforts only support the conference, right? As far as this is concerned. So thank you very much. Yeah. I also would like to thank all the speakers. Anyway, I have individually, as and when they spoke, I have thanked them. But this is really heartening that even international speakers, whenever I asked them once, they immediately said, yes, we are willing to come online. So people even have gotten up early in the morning, 6 and 7 from US to come and lecture online. So that is also very heartening that there are people who are really concerned about education and math education. So I thank from my heart to all of them. I thank all the participants who registered for the conference, whatever the reason could have been for registering. But I was happy to see at least 50 persons, 40 to 40, 45, 50 teachers who are really interested in knowing and listening. And they are the ones who constantly sort of 12 hours a day. As somebody had put it, our conference ran about 12 hours a day. That is, even in the physical conference, that does not happen. It does not happen when there's a face-to-face conferences. At the most 9 to 5 and 9 to 6 or something. And then we say, okay, we want to go for sightseeing now, the city where we have come for the conference. So I took advantage of that, that you are not going anywhere, you're staying at home. So my idea was to give as much as possible to all the teachers and every participant so that I feel happy when my teachers get benefited from it. So thank you very much, participants, for joining and showing your interest in this. I think the only person who has not been thanked till now is Dr. Soumya De, who has been helping behind the scenes in various capacities. So thank you very much, Soumya.
Thank you, sir, for the opportunity. Thank you.
My pleasure. Pleasure is always mutual. That's my pet, become sort of pet dialogue. Somebody says it was a pleasure. I say pleasure is always mutual. You can't clap with one hand. You need other hand to clap also. So thank you very much, Soumya. And implicitly, Janaki says it, I should thank my wife also. For two reasons. One, she took care of all the registration. As and when forms came, she took the Excel sheets, entered the data, prepared the emails to be sent to them, and so on. And unofficially, she also evaluated the academic paper presentations. I don't know how much her evaluation was good or bad, but she had passed it on to Janaki, her evaluations as a non-mathematician, what she thought of the presentations. Okay. So
in fact, I would like to add, sir, that we very much took that into consideration, and Richa and Shanta will know that we discussed that.
No, it's okay. Yeah. I'm just saying that it is her sport also that I keep on doing this. Even though there was no financial sport or any other sport, I said online, like asking for a वो भिक्षा पात्र होता है ना, उसको लेके जाते हैं, इसमें एक invited talk डालिए, इसमें एक workshop डालिए, इसमें ये करिए, and then we make this a successful one. So thank you very much. Thank you all of you. Soumya, from my side, it's okay in case you want to say something.
Can I say something, sir?
Yeah, please.
Yeah, sure.
Yeah.
I think Soumya was good. Yeah.
Sorry, Soumya will end the thing, I suppose. But
no, you won't end it, I think.
Okay.
Yeah, no, it's okay. Please go ahead, Janaki.
Yeah, I was just saying that, I mean, this is just not a formality, but deep appreciation to you for, being steering this ship for so long. Since 2005, I have been a part of this conference, and it is not easy to, there are many conferences which start and, sort of wane away, but to have this sustained effort and with the same vigor and the same rigor and in every possible way. So thanks to you for guiding, for taking this forward and so many people have joined this the time conference and have been benefited by it, and it will continue to do so, I'm sure, in future. So just wanted to acknowledge your efforts, and Lalita ma'am, I've always seen her by your side, and that's why I thought I want to say thanks to her too. And I think I represent the whole community of time in thanking you also for this. Thank you.
Satana wants to say something. He raised
Yes.
Please, sir. Yeah.
Hats off to you, Dr. Ranaji. I had been conducting conferences for the past 20-25 years, AMTA conferences, IMER conferences, and I'd been attending so many conferences also. This is a new experience, namely, I have never conducted an online conference so far. AMTA also, I told them that it's very difficult for me to conduct, but he has conducted in excellent way. Not only that one, the main point here is it has been recorded. Therefore, I am using it for my students also. And in future, I will use it for my teachers also. So that recording facility is there. And Ranaji mentioned one more thing. Once you come to a place and attend a conference, after some time, they want to go for outing, this, that. It's not taken very seriously. Here, serious people are there and seriously they have taken, and the conference also went on excellently, very well, and the credit goes to the whole team headed by Mr. Ranaji and Jonaki and others. Thank you very much.
Yeah.
Sir, can we have a group photo?
Yeah, I think Santa wanted to say something. She came and then went back probably. You wanted to
okay.
Santa?
No, nothing.
Okay,
I just wanted to thank all the participants and the organizing team. And I think Janaki mentioned Lalita ji, and I think her support is really valuable. And I hope that we all meet again in the next conference and keep in touch between the conferences as well. Yeah.
Sure. Welcome. In case, before we take a group photograph or whoever is present today, I want to, some people had asked me that they want to say something. So I said, conclusion is the best place to say these things, whatever. But I think enough has been said about me. So don't mention anything about me, but say about others, please. If anybody wants to say something.
So if someone would like to say something, please raise your hand.
Yeah, Sagar wants
to. Please unmute.
Namaste, sir.
Namaskar.
First of all, greetings to the organizers of the workshop, all the members, especially to Rana sir. The training and the workshop which has been going on for the last 3 days was a treasure trove of the information, benefit from innovative concepts and technology. Thank you, sir.
Welcome. Anybody else?
May I say something, sir?
Yeah,
please.
My name is Ashok Khopkar. Can I start my video or?
I think now we'll say everybody put on your video.
Yeah.
So that we can take a photograph also later on. So switch on your video in the meantime, and Ashok ji, please continue.
Yeah, I'm a retired mechanical engineer, learning and loving maths all the time and applying it in practical engineering. And I want to pass on that love and passion to my grandchildren. That is the reason I joined this conference. And I really enjoyed the new methods. That is what I wanted to know, how kids can be made to love mathematics in all its branches. Thank you very much. It is just out of the love that I have been spending 3 days here with experts like all of you. That's all. I am not a mathematician. I am not a teacher also, but it's just that one. Thank you very much, sir. Thank you.
But Ashok ji, that says you have mathematics at heart.
Yes.
So you are a mathematician. Yes, please.
Low level.
We still don't have some videos on. I wonder. Yeah,
may
please.
I speak a few words?
Yeah, go on. I'm
would
waiting for others to switch on their videos. Otherwise, we'll take a half photograph or whatever it is comes.
Yes, sir. So I would like to thank the entire committee for arranging this. It's really been enriching for all of us. And we in fact had exams in between, but whenever time was available, we made it to this. And thank you so much. It was an enriching experience. And I would also like to thank my co-author as well as my teacher, Dr. Jacqueline Karim, for all the support that she has invested for helping me through this entire process. Thank you so much, everybody.
So if nobody else wants to say something, then probably we should take a snapshot.
Yeah. Anyone?
Yes. Yes. I think from my country, I think I am one of the participants of this conference. So,
can you please switch on your video? We can't see you.
Yeah. So actually, I think a little bit problem when I started to the video.
Okay.
It's okay.
Yeah. So yeah, it displaying for me cannot start video. I don't know what is the problem. So, sir, good morning. Good morning to all, to the organizing committee. So Professor Rana sir is my virtual guru since 1994. When I was starting my career to teach theory of integration in Guntur, Andhra Pradesh, I completed PhD in SV University. Now I am working as a senior lecturer and former head. Just I completed my headship in July 31st. Now I am in sabbatical leave. So I got an opportunity to attend such a wonderful conference. But I am unable to attend completely because of the time duration. So mine is early morning. Yours is evening. So I skip some of. I am in West Indies, sir, Trinidad and Tobago.
Oh, West Indies. Okay, okay.
Yeah, the University of the West Indies.
Okay.
3 campuses, but I am staying here, Trinidad and Tobago.
Okay, fine. Please continue.
Yes.
What you want to say?
Yeah, sir, I am very happy. This is, I don't know the number of participants. It seems to less in such a great conference. But I believe such a conference is possible to extend it throughout the world, usually where the maths lovers or where the living like me, Indian citizens who are working outside. So they can promote such a great conference to local people. The problem is a time duration. If that can be relaxed, common time duration, east and west, like morning and evening, and extend the time duration, maybe the people can benefit, lot of people can benefit both east and west side. That is, I don't know, but I am really try to this is actually we are going every time, every week, monthly once to outreach programs to schools to create the interest, attracting the interest to mathematics, and we are organizing maths fair, etc. So for that purpose, we can attract more students through this platform.
Yeah, Sridhar, I think it's very nice you are doing there. So do promote the idea of something similar to time conferences, and you can have it for your local, so that time zone is not affected. So that is one way of doing it. So
yes, sir.
Is that I am always willing to help you to organize that kind of a thing. Okay. So
Yes, sir. Thank you very much.
yeah. So with that, shall we take the snapshot? If somebody has already taken.
Yeah.
Yes.
I request everyone to please open your videos, whoever wants to be in the photograph. Okay, so maybe we wait for 5 seconds.
Well, why not?
Okay, so yes, let's take photograph.
Yes. Good. That's great. Thank you. Well, you have a YC camera, which lets you know that you have been shot.
Yes.
Okay. Thank you. Thank you very much.
Thank you.
Thank you, sir.
Let me say goodbye for the time being for 2 years to all of you. And let me also float this idea that this year Unison World School came forward to join Math for All to organize, co-host this conference. So I'm open to any school, any institute, any industrialist, any philanthropist, anybody interested in promoting math education is welcome. So we have 2 years for anybody to contact me and then finalize something for the next time conference. Let us hope and wish and pray all of us stay safe and stay healthy. स्वस्थ रहें, व्यस्त रहें और तंदुरुस्त रहें. So there are 3 things. So eat well, be healthy, and keep working. So with that wish, let me take leave and let us close the conference formally. Thank you all. Bye.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you so much, sir.